Learning to make great games is hard as hell. Learn with us at unf.com to make it easier. Did you ever wanted to create your own real-time strategy game but didn't know how to start? In this tutorial, you will learn how to develop an RTS game from the ground up, only using Unreal Engine 5. You will develop the base mechanics of the game using blueprints, create the landscape of our level using materials and Megascan assets, show relevant game information in the HUD with widget blueprints, also interact between those blueprints by using interfaces and event dispatchers, and lastly design and implement a simple artificial intelligence agent based on the different states of its behavior. The overall goal of this tutorial is to build the foundations which you can later use to develop new features on top. There are no requirements needed for this tutorial, and as always, knowing your way around the editor is recommended but not mandatory. If you get lost along the way, you can contact us in our Discord server, and also you can download the project files in our website, which you can find in the description below. I hope this tutorial is a great learning experience for you, as it was for me. With that said, let's start! Let's start development by getting the assets that we're gonna use. We're gonna open this Epic Games launcher, go to Unreal, go to Samples, and here in the Legacy Samples, Legacy, we are gonna select the Strategy Game sample. This comes with C++ code, AI, and a lot of stuff. We only want the assets, those boxes, the buildings, and well, some rocks would be nice. So just create the project. After you download it, it may say 4.18. You can use whatever you need. Probably choose the latest one and just create it. When you create it, I already have created it, so I have the folder here. You can search where you have put it, and you will find the assets, in my case, Unreal Projects Strategy Game. What we're gonna use is these assets inside it, and whenever we copy and paste this stuff, there will be a lot of things that will be not working, and other ones will be entirely corrupt, especially the blueprints. So what we're gonna do is, well, just copy all this, and let's create our project, and we're gonna add that stuff to my project. So I'm gonna launch Unreal Engine 5. I'm gonna select a blank project so we can build everything from the ground up. So games, blank, blueprint is fine. Usually for an RTS type of game, C++ would be a really welcome feature, but for now, let's just stick to blueprints. And yeah, sure, my first RTS could be nice. Let's click on create, and well, let's wait till this is opened. Now that it's opened, we can dismiss the plugins, we can update the project file, and we can go here in the content drawer that you can open also with Control space. And in the content folder, let's just right click it and show in Explorer. Inside it, I'm gonna create a new folder called Strategy Game Assets. And inside it, I'm gonna paste what we copied before. And it seems I don't have it, so let's just open again my folder. This was not it, this one. Strategy Game, inside the content folder, let's just copy and paste everything here. Okay, so this is Don't copy in here changes to the source content, import it. Would you like to create just to all for now? Yes, 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 yes. And also let's save all. And now we have our project, blank project, with the assets we are going to use. It will be a good idea to set up a quick scene here in Unreal so we can test the size of the assets. We're going to create the camera first. So in order to test that camera, for example, looking down, we need to know how much distance do we need. And it will be a good idea to create a quick scene. So let's create a new level. Gonna create an empty open world. Gonna go to my content drawer and create a folder for my project. So new folder, my first RTS. It should be the same name that your project has. Inside it, I'm gonna put a map folder, maps. And now let's save my current map. Let's just call it Rocky level, because I know there's a lot of rocks in the assets, and yeah, should fit a little more better than any other name. Let's create the lightning. We'll go to Window, Environment Light Mixer, so we can create fast this scene. Create a light, create a skylight. We won't see it until we put an atmospheric light, then volumetric cloud, high fog, and well, a sky atmosphere will also be a lot welcomed. Also here in the skylight, if I don't see it here, then I will need to click here and check the real-time capture. All this lighting stuff, let's select it and let's put it inside its own folder. Let's call it lighting. And well, it also would be a good idea to move them a little bit so they are not overlapping. Yep, okay, with this done, let's create a little landscape. We're gonna go to the landscape mode, and here I'm gonna leave it just like it is. Could be a little bit big, but if your PC starts to suffer, then you can change it to a smaller area. But I really don't know how much I will use of this landscape. If it's too much, then oh well. I'm gonna just here get my noise tool, and I'm gonna paint some noise through all of the map, and it's a lot bigger than what I intended, so let's just increase my brush size, and that's too much. Tool strength, that's a little bit better, but let's put it like that. I just don't want to have a completely plain terrain. Yeah, that's a little more better. And we are going to need to smooth the part where we're gonna have our gameplay or whatever we're gonna do. So let's smooth it out. We can increase the tool strength here. And let's say, yeah, this is the playable part. Gonna want some type of mountains here. That could get interesting. I'm just using the sculpt, and with a click we can increase the height of these mountains. If they are too big, they seem quite nice. So let's leave it like that. This will be my playing field. So now it would be good to maybe make it completely smooth here or completely flat. We're gonna use the flatten tool. I'm gonna do this so I don't need to change the rotation in the created assets. Yeah, and I'm gonna smooth this part a little bit better, so it doesn't seem like it's too flat. Yeah, and that should be okay for now. And now let's bring some assets in. The assets that we're going to use are here in the strategy game assets, and we can filter this by static meshes. I can go to my select mode. We can switch from these modes with shift 1, shift 2, shift 1, shift 2, shift 3. So I don't need to click here every time. Let's put the assets. And to get a better view of my scene, I'm gonna press F10. So this details panel will go to the side and we can bring it up like that. But I wanted more of my map. So here I can see that there are some element towers that hopefully the material is not broken. Here we also have this building, and it sure seems like the material is broken, but we can fix it later. What is this? Simple brewery. Some gold stuff. And rock. And it seems that like these are all the assets. Wooden planks. I believed if I went to the environment, buildings, no, environment, meshes, and I select everything here and move it to the side, we can also bring everything, but seems not working for me right now. But we have this building that we're going to use as the main base where all your assets, all your workers will spawn. So let's see what's happening with this. It seems it doesn't have the material that it needs. So let's go to here, and these buildings, these blueprints, if I try to open them, they just won't let me. So what I'm gonna do is materials and see here if it something is called brewery, and we can search here. Brew, nope. Building, nope. Ground, and it was not brewery, it was brewery here. So let's see if this material works. Doesn't seem to work. Let's open it. We are missing the textures. Could it be that it didn't copy the textures? That shouldn't be it. And here this texture sample completely empty. So let's find it. Here in textures, environment textures, let's search for just BR. Here's the brewery. It's called brewery here, but doesn't matter. Just put it here, or well, just keep it selected. We'll select this texture and click here, so it begins to be used. Let's apply it. The current material has compiler errors. Oh, but why? Ah, these are the compiler errors. Yeah, let's finish this. This should be a mask, and this should be another mask. So this one, let's put it this part, and the normals, well, here is the normal. Let's select it and again save it. Let's see now if our brewery is looking good. Looking kind of weird, so let's use the other mask, this one. There it is. This one should be working a lot better. This is it. So now we have this mesh that we're going to use as a main base. Looking pretty cool. And we're gonna fix the other ones, but whenever we need them. Maybe this rock will be needed. Yeah, I'm gonna really use this rock, and I'm going to use this gold. Let's fix this rock and this gold pretty quickly. So here I'm gonna again press F10 so I can go to my details panel pretty easily. Here I do not have a material. Let's find its material. And we can click here in the strategy game and just find environment rocks. Let's just type rock. Combine data. This I don't need. This is the material that should be used. So let's just, with these selected materials, obviously it is not working, but we can just replace the materials again. This should be the texture, the base color, because it has a _D, which means diffuse. And the normal, well, should be really close. Here it is. And let's add it. Well, select the texture sample and add it again. Let's save it. Let's see if my rock is working properly now. There it is. And we will do the same treatment to the gold one. And here I pressed Ctrl E, and I should do that with the rock also. Ctrl E, or just right click and edit, because by default the word grid material is being used, so I don't want to use that. Otherwise, every time I drag and drop a rock, I will have it in gray, and that's not what we want. So here, let's just type gold. This is the material, and let's open it. Here I will type, oh, not types in, but type gold, and hopefully we can find the texture. Here it is, and we will see which one we need to use. So let's just try it with this one. Select it, the texture sample should be the one that I already have. The normal, again, should be this one. And this emissive color, probably this part. And I just drag and drop. Let's just use it like this, and it seems I made a mistake with this one. This is the diffuse one, so, and this is the emissive. It is showing the name, so yeah, my bad. Let's just use the diffuse here, normal, and the other. Let's see if this is working. Let's save it. Gold pile seems to be working pretty good, actually, and the rocks also. Nice. Let's not forget about the brewery. Let's just edit it. Oh, and it is using the material, the correct one, so we were not forgetting anything. Let's just close this. And here we have some sizes. Obviously, this rock, I'm gonna modify it, scale it up and down, and do a lot of stuff with it. But for now, it's looking fine. This is the scale that I'm gonna use as a base. So whenever my camera is looking here, I can determine which kind of distance I want to use. Now, a good idea will be to get rid of this material, use something that we can modify and then adapt it to our game. And also, it will be a good idea to make that landscape material so I know from which distance it will work, and then I don't need to modify it that much later. And yeah, it's looking fine, this landscape. So let's create that landscape material. Let's go to the content drawer. Let's go to, well, let's delete this search. Let's go to my first RTS and remember to right click it, set the color and choose your favorite color, or well, whatever color it will help to pop this up. So if I'm looking through here, I can just, oh, here's my project folder. So in my project folder, let's just create a new folder called environment. And inside it, I'm gonna create a material called Rocky Level, or just Rocky Landscape. And it will be my Rocky Landscape material. Let's just double click it because it will be a landscape material. Here we should search for fully rough. So we don't want our material to be shining. And here let's add the layers. Layer blend. We will have a ground. We will have rocks. And we will also have maybe, I'll just call it rocky ground. Just like this. For now, I'm just gonna put some colors in it. Just like this. And let's say our ground, we should really match some of the colors here. Just so I don't need to guess too much. So the ground maybe could be this type of color. Let's use the eye drop. Like this. Okay. The rocks will be, double click this. Let's use this eyedropper. And should be a darker kind of, maybe this darker kind of color. And the rocky ground could be exactly the same as this one, but a darker shade, so I'm gonna do that. And now let's choose a darker shade. Okay, let's save it. We can close that. And now we can select our landscape and be sure to select everything that is below it. Here's my landscape material. Let's use the Rocky landscape. And we're not seeing anything, right? So let's just go to the landscape mode. Let's go to paint. And here we have those layers that we created. So we're gonna create the information of those layers. So weight blended layer, just select environment here, and ground layer info is fine. Rocks, let's just do the same for everyone. Let's save everything. And we should really in the environment have a folder called Rocky level and put everything inside it. Hopefully this does not crash my engine. It's good. Every time you move some stuff around, especially some stuff that is being referenced by something else, let's just right click it and fix up the redirectors just in case. And now you can see that everything is colored in the ground color. We can add the rock color here and paint. Paint it good. You can increase the movement of the camera by going here and moving this. That should be enough. If I want a rocky ground, maybe I could use the tool strength here, the brush size a little bit like this. Just paint it something like this. And then smooth it. So here I'm gonna increase the brush size. So it becomes like patches of rocky ground. It also would be a good idea to smooth this part. Maybe rocks, paint. This part should be a little bit rocky. And let's smooth it. Yeah, let's not worry about it too much for now. We're not gonna really about this part too much because we are going to replace the colors by some texture, so doesn't matter right now what we're seeing. And let's get those textures. We're gonna get them from Megascans. Here in the content drawer, you can go to add Quixel content, and here in the bridge, I'm gonna use this Heartland Quay Shore collection. Go to the collection. There are some assets that we could also use, but here I'm gonna filter them by surfaces, and I have gave them a heart to the assets that I'm gonna use. So I'm gonna use the surface. You download it and then you can click here to export it. I just selected medium quality. This is 2K quality, is more than enough. You can even go lower. Also this cracked shale beach rock and this layered rock cliff that I'm gonna use for the rocks. Now we can close this, and here we have the materials and especially the textures. Okay, so now let's use those textures. Let me open my rocky level, rocky landscape, and now instead of using these colors, I'm gonna move it a little bit. I'm gonna deselect these parts, and I'm going to drag and drop here, let me put it like this. So I have my content browser open, and I'm gonna drag and drop these textures. So which one would be the ground? Should be this one, this cracked shale beach. And also I'm gonna drag and drop the normal. Now the rocks are gonna be these layer rocks, and also the normal here. And at last, let me put this there. At last, we will have the rocky ground, which is going to be useful for us to create some blending, interesting blending, to avoid some tiling here, tiling issues. So I'm gonna use this cracked shale beach. This is the texture, and the normal also I'm going to use it. Now I can close this content browser. And for now, let's just connect the layer ground, layer rocks here, and the rocky ground. Now, let's see what's happening. Save it. And now my level has these zones, has this, well, this is an issue. Let's just paint it over. Let's smooth it. For now, let's just leave it like that. But we do need to fix this tiling issue, that it is easily visible. Okay, I'm not the best with materials, but we will do just a quick fix. I don't want to throw away these colors just yet, but here we will get the first. Let me check that all the node previews are updating, so we can see what's happening with the textures. And what I will use is the first world position. With this node, we're gonna get the information of the world position inside our material. And this world position, I do not need the three values, the X and Y and Z. We will need here with a component mask, we can choose which values do we need, X, Y, and Z. So I only need X and Y. I'm gonna divide this by the number I wanted to tile the rocky level. So here, this is just a number. I'm gonna press 1 and click, and this will create a constant, a scalar. You can find it like this, scalar, scalar parameter. Well, we're gonna convert it into a parameter, but not just yet. So it will be a constant like this. It's the same. So let's connect it like this. We cannot divide by 0, so we should really put this in a number that is a power of 2 for better results. So 4, or just multiply that. I'm gonna use 512. Enter, and now we're gonna plug this into the texture sample. And let's see, oh, let me apply it, or just save it. Saving it will apply it also. And it's not tiling that much. I mean, now it's a little more visible. Let's start fixing it, and we now see how this world position is affecting our texture. Pretty cool, right? So what I'm gonna do is make this a parameter, and this will be the ground tiling. Gonna duplicate that. Should duplicate everything really. Copy this, paste it here, paste it here, connect it to these UVs, and this ground tiling should be rocks tiling, and rocky ground tiling. Now, we should play around with these values, but doing like playing it around here and then applying and then checking the level takes a long time. So what we're going to do is create a material instance of this landscape so we can check the results more quickly. Just right click it, create a material instance. This will be MI because of material instance, and MI landscape should be fine. Now let's change the material. Let's just leave the landscape mode. Go to the top here, select the landscape, and here we'll select the MI rocky landscape. Nothing will change for now. What we need to do in order for it to change is open my material instance and be sure to save it. Open it, and I'm gonna put it floating like this. And now we can modify those parameters that we created by right-clicking the number and converting it to a parameter. Which this will mean is that if I select this part, I can click on rock tiling, and I don't really need to select this part. I'm just doing it by habit. And I can multiply this, for example, by 2. And see if the tiling changes. If it doesn't change for some reason, then this has happened to me before. In the landscape here, you have chosen the rocky landscape, but in the other zones, it may not be chosen. So we can, well, select every landscape streaming proxy here, and also put here the landscape material that we need, which is this one, rocky landscape, and just put it here. Now we can see that it did change the tiling. And let me find my, here it is. I opened that window with Control Shift. You can see everything that you have created. And here now I can play around with the tiling, but be sure to do it in increments of the power of 2 values. So here, 2, that should be enough, I believe. Let's try with, again, multiply by 2. That's a little bit better. And that should be fine. This floor should be the ground tiling. Let's multiply it by 2. I can still see the tiling, so let's do it again. A little bit better, again. Yeah, and now it's not that apparent, especially because we have some spots where we are using the rocky ground. And for the rocky ground, that it is tiling a little bit, I'm gonna multiply by 2 and again by 2, just like that. If the rocks need to be bigger, well, need to tile a little more, we can make them bigger like this. And it was good to have 3 parameters because we can have different values. Now they are really flat right now. We have not added the normals, but let's do that right now. Rocky landscape. And here in this material, we're gonna add the normals. We're gonna use the same process here, layer blend, just copy it, put it to the normal. We're gonna connect this. Like this. And if you just press apply and see the results, you're not gonna really see that much, and you will see that there are a lot of mismatches like this. And it's because we are not tiling them correctly. And we will need to use the same code down here. You could just drag and drop the values to the UVs the same way that we did here. It will work. Of course it will. And we can check if that is working. We can now see some bumps in my map. It's looking a lot better actually. But we want to clean, we want to keep this material clean. So let's just create here. In the first one, the absolute world position for the ground, we will right click this and we will break the node links. And I didn't want to break every node. I just wanted this pin. Break node link. Yeah, like that. And here we're gonna create a named reroute declaration node. I'm gonna call it ground tiling. And I don't want for it to have the same value. Ground tiling, and this parameter I'm gonna call ground tiling value. And I'm gonna add that to the other ones. It shouldn't matter that much, but I really don't like having the same identifier name. It's the programmer in me that is telling me don't do that. But I'm gonna, here also I can just keep my Alt key pressed, click here, and it will unpin everything. And here name reroute declaration, F2 to change the name, or just right click it and rename it. You're kidding, there is no rename here. Well, F2 to also rename it, or you can rename it here also. This will be rock. Oh, excuse me, I pressed another key that I didn't want here. Name rock styling. And the same here. Named reroute declaration node rocky ground tiling. With this created, we can use these declarations. So we just name reroutes, even here we can find it. Ground tiling, gonna put it here, copy it, ground tiling here, which was the next one was rock tiling, and the other one was rocky ground. Gonna put them like this, gonna select them, press Q to make them snap, and I'm gonna copy this and paste it here. Perfect. And the shortcut that I'm pressing is Q. You can select more than one node, and here alignment, Q will straighten the connections. Perfect. Now it's looking very organized. And if for whatever reason I change something here, then it will also show here. Let's save it. Let's see if it's looking correctly, and it seems it is looking correctly. The colors are, yeah, good enough, I believe. Maybe the rocks could be this color, but we can tweak everything later. With the landscape material done and our asset placed in our map, so we can decide the size of things, it will be a good idea to take a little break. So if you have been sitting for these almost 45 minutes, you should really get up, walk a little bit. You can think on what type of game do you want to create. But it will be useful for everyone to just take a little break here, maybe drink some water, and then come back. Having said that, I'm gonna continue with the next part, where we are gonna finally start programming something. Now that you have come back refreshed, then we can now create the framework classes needed for our game. These are the game mode, and let's go to our content drawer. Oh, let me save everything. Yep, let's save everything. Let's go to my first RTS, and I'm gonna create a folder called core, where all the core elements of our game will be. Inside core, let's create another folder called framework. Inside it, let's right click and create a blueprint class. Blueprint is the way we have inside Unreal to create interaction between objects. So interactions that we will create will be using a graph system in order for us to add functionality. Now, every blueprint will be derived from another class. And a class is just a fancy way of saying a little text where we are describing how an object will be defined. For example, if it's a bike, it will have two wheels, it will have a motor if it's a motorbike. If it's just a pedal bike, then maybe it will have chains. And also, not only the attributes will be there, but also the functionality, like what can the bike do? It can go forward, you can stop, and whatever it is you can do with a bike, can do tricks maybe. So in this case, it's important to pick a good parent class. An actor will be anything that we can put on the level, and it's one of the main classes that we're going to use inside Unreal. But for now, let's create a game mode, which is a class that we will use to define the rules of the game and also set up the default values of our game whenever it starts. So let's put it GM and let's call it the same name as our project. The other classes in the framework, and before I jump ahead, the game mode with rules, I mean the rules that affect the state of the game. We're gonna go deeper in it in a minute. Well, maybe an hour. But here, let's go back to the core, and we need to create framework classes for our player. So let's create a new folder and call it player. Here we need a way to manage the inputs that our player will send to my characters. And we're gonna use the blueprint class called player controller. The player controller will work as a brain for any character that we can use inside Unreal. So whenever I tell it where to go, it's gonna pass through the player controller. So I'm gonna call it player controller and the name of my game. And we need something that will represent us inside our game. And that is usually a character. Because it's an RTS, we don't really see a character that we control like a normal game. We should be able to select a lot of characters and send them commands. So our character in this case, it would be a floating camera. Now, whenever we do not need a character, we will create blueprint class, and here it will be a pawn. A pawn is a type of blueprint that can be possessed, and here you have it. Possessing is a way of sending that input from my player controller to my character. If my character is not possessed, the input is ignored, and when my character gets possessed, or in this case, when my pawn gets possessed, then my pawn will do something like move around. And I'm going to call it blueprint player camera. Could be player perspective, whatever you need. Let's save everything. And now that we have created these classes, we need to define them inside my game mode so I can use them every time my game mode is being used. So let's go back to the framework, double click my game mode, and here in the class defaults, you will see the classes that will be used by default. Let's use the default pawn class and change it to my player camera. And the player controller class, let's change it to PC my first RTS. Compile it, save it, well, close it, and let's go to the project settings now. Because right now my game mode is not being used. I want the game mode that I created to be used by default, so let's go to the project settings and let's go to gameplay, maps and modes. We can define the startup map, we can define our Rocky level as a startup map and also our game default map. And in the default game mode, I'm gonna choose the GM my first RTS. Now, whenever I press play, I should be able to find my player controller here. It's in yellow because it is created during runtime. And we can also find my player controller somewhere here. Oh, I did find my player controller. This is my character, my pawn blueprint player camera. So it is working correctly. When I press play, you will see that we have a static camera that I cannot move. And also it's starting wherever my camera is. Let's change that. We know that we are using here in player, my BP player camera. And I'm gonna put it here. And if you don't want to change every time you open a new tab, a new asset, and you want to dock it here, we can go, and this is driving me nuts, so that's what I'm doing it. Editor preferences, I'm going to here, asset editor, open location, default, I'm gonna use the main window. We can set as default, but for me it's fine. Now every time I open something, should be open here in the main window. So let's go back to the player camera. As I was saying, we want to set up a way so we can define the distance of the camera and maybe the field of view. So let's add a camera. And we could make the camera just start there or move it like that. But I always want it to be facing this center of this blueprint. So we can move this blueprint around and it should be still facing that way. A neat way to do exactly what I'm saying is just, let me reset this and add a component called spring arm. And this spring arm has been added to whatever component I had selected, and this should be the other way around. So I'm just gonna hold this spring arm and put it on top to detach it. So now they are in the same space. And I'm gonna put the camera and drag and drop it on top it so we can attach it to the spring arm. And now we can see that the camera is at the end of the spring arm, which is very useful because if we rotate the spring arm, we can make it always look to the center. Let's just go over the fact that this is the blueprint editor, and a blueprint is just a way of holding different components. We have a lot of them. Static meshes, if you want our blueprint to have a visual representation of a 3D object. A skeletal mesh, if that 3D object has bones and we want to add some animations. And we will go over this a little bit later. But we can add a lot of components and make our blueprint really custom to our needs. Now let's compile, let's save, and if we press play, we are now seeing our camera. Whenever we're looking forward, it is now looking down, exactly like my blueprint. So I need to define a starting point for this blueprint. So whenever we want to create our default pawn, and our default pawn is defined in the game mode here, player default pawn class here, my player camera. Whenever we want to decide a starting point for that blueprint, we can here search for player start, or here in basic it should be our player start, and drag and drop it to the level. This player start, which it says that it's in a bad size because it is clipping the ground a little bit. Here we can just, oh, and my camera is way too fast. Here we can just elevate it to the sky and press end, the end key, so it snaps to our surface. So now whenever I press play, it doesn't matter where I am, our blueprint will be spawned here. Now it is spawned. Oh, I moved it accidentally. Here it is, and oh, it seems I had two player starts. Excuse me. Let me delete one. And it seems our camera is too near to the ground. So what we're gonna do is go back to the blueprint player camera, click on the spring arm, and each component we can modify some properties in it. Here we can modify location, rotation, scale, but we're gonna modify the target arm length. Maybe 2000. Something like that. Let's compile it, save it, and let's press play. Yeah, now it's showing me the edited blueprint, and it seems that I need to go even farther. Maybe multiply it by 2. Yeah, should be a lot farther. Again. And this could be nice. Yeah, this should be it. This is like a good scale. If you are not liking the rotation we are giving it, you can make it more. We can increase the pitch or decrease it, but I believe the one that we have at the start, it was fine. And for some reason I deleted that, which wasn't what I needed to do. Here 40 could be it. And we can also play with the, if we select the camera, with the field of view, maybe changing it, and I believe should be easier to see if we just drag and drop our player camera, select it, and press end, so it is there. Oh, and here, why is it happening this way? It's because our target, our spring arm does detect collision, and we really should not use this, because otherwise whenever we are here with well, with a mesh, with a collision, it will detect it and it won't be a nice experience. So let's just remove the collision in the spring arm. Spring arm, do collision test, put it in false, compile it, save it. Now this character, press end. You can see what the camera is seeing. And why did I did that? Because I wanted to play around in my details panel. I'm gonna select the camera and I wanted to play with the field of view here. So we can change and see how it is being seen. We can also change the perspective to orthographic, but usually that doesn't yield too much good results. It really gets rid of any depth, so we are not going to use that. Camera again, orthographic no, perspective, but I maybe 40, 45 could feel a lot better, because if I press play like this, and if I change the here in the camera 45, compile, save it, if I press play, yeah, it seems a little bit better. I'm just going to increase the spring arm again. So maybe just add 2000 and press play. A little bit more. There it is. I'm liking this view a lot more actually. Compile, save it, and now we can proceed. To move the camera around, we need to add some inputs. Let me delete the blueprint player camera here, because remember that this gets created automatically, so we don't need to bother too much about it. So to create an input, we go to the project settings. If you don't have it open, edit, project settings. And now in the project settings, we have a category called input. In input, we will go to actions mappings and axis mappings. These will be the two ways of adding inputs inside Unreal. Axis mappings will be very useful whenever I need a value that goes from -1 to 1. For example, if I'm going forward, like this, let's just call it move forward. And let's say my move forward is, I can click W. I can also add another input, like gamepad left X. Excuse me, Y should be forward. And this has given me a scale of 1. If I needed to move backwards, it's really not needed for me to create another axis mapping. We can create another input key, press S, and the scale I can reverse it. And well, the gamepad doesn't need that, but because it already gives me values between -1 and 1. If I needed an action, for example, accepting something with the button A or with the enter key, something that I just need to know if it's pressed or released, then action mapping will be the way to go. For now, I only need axis mappings, move forward and move right. This is for me to move the camera, and move right should be D, and S, well, excuse me, A, and the scale in A should be -1. And to complete the gamepad setup, gamepad, move left thumbstick X-axis. I will want to reorganize this, but it seems I can't, so I'm going to do this just for it to be a little more organized. Left, Y. and here one. Okay, now it's done the way I like it. Now with the inputs set up, I can use these inputs in my game. We said that the player controller was the one in charge of the inputs, and you really can put them either in the character, well, in the pawn or in the player controller, but for now I'm gonna use the player controller. So I'm opening my player controller in the event graph, which is the graph where we're gonna add most of our functionality, and you can see some nodes already. We're gonna add some nodes for the input. So here I'm going to use the name that I already assigned, which is move forward, which is an axis event. I don't need only the value, I need both of them. So axis event give me the event and the value. An event in Blueprints is just the starting point of any type of functionality. So whenever something happens, this will be executed. In this case, this is two of the most common events inside any blueprint, which is begin play that gets executed at the start of the game. You can test this by adding here a print string. Hello is fine. If I press play, I should see hello in my game. And the event tick, it's an event that runs every frame. So if I put this here, it will draw the hello message every frame. So we have move forward and also move right. And we want to add movement to our pawn. So this player controller doesn't have our pawn here as a component. Our player camera does have more components, but doesn't know about the player controller. By default, because we have here in the project settings, maps and mode, defined that my player controller is the player PC, my first RTS, and the default pawn class is my player camera. By default, my player controller is possessing my player camera. So I can get the player camera by right-clicking, get controlled pawn. And with a pawn, I can add input. And I will add movement input like this. And I will add movement input like that. If I'm moving forward, usually forward means X positive and right means Y positive. Up and down is the C value, and I do need to make sure of what scale value I'm sending it. Otherwise, I'm always sending a value of 1, but if any key is, if every key is released, no key is pressed, then this axis value should be 0. So we will do it like this. If we compile, I have an error here. I don't have a target, so let's add a target, which is the control pawn. So I'm asking the control pawn to add some movement input for me. Let's compile, save it, let's press play, and we will not see anything if we press WASD. Why is that? Because inside my pawn, there is no logic inside it for it to handle that input. So to make things easier, here in the components, I'm gonna add a floating pawn movement. And this component will be in charge of deciphering what to do with this movement input. And we can change some values inside it, like the max speed, deceleration, acceleration. So let's press play. Gonna click inside my game, so my mouse is hidden. And here we will press W, I move forward, S, I move backward, and I have movement in my camera with the WS key. I just wanted to show this type of input because it could be useful whenever we're implementing keyboard and also movement with the mouse. And I also wanted to test the speed at which the floating point movement is moving, so the max speed should be a lot higher, like maybe 3 times the value. Yeah, and this seems fine. Now, it all depends on where our camera is being spawned. If you by any chance rotate this like this, then whenever we press play, we're looking at the other direction, but if we press W, we're still moving in the positive x-axis. So what we're gonna do, just to make us some freedom in the rotation that we could have inside my camera, is change the world direction and see where our control point is looking. So we're gonna get the control rotation, and here I'm gonna get the forward direction, forward vector, and here I can ask for the no, not that one. Oh, I need to break this. Okay, I'm gonna put it like this just to show you what will happen. The forward vector should add some forward input, but if I press S, I'm not only going forward, I'm also going a little bit down. So to fix that problem here, I'm gonna split, and I really only want the yaw value. So I'm gonna move this a little bit to the side, gonna make some space. And now I have the direction. And the scale. I'm gonna do the same for this one. I'm just gonna copy and paste this. But instead of getting the forward vector, I'm gonna get the right vector. Gonna split it, connect the yaw, and connect the world direction and the target, just so it is a little bit more cleaner. Let's press play and everything should be working the same, and it doesn't really matter if we rotate it 90 degrees, it should still be working the same. To create the movement with the mouse, we need to change some stuff. First, we need to get the mouse movement. So, project settings, here in input, we're gonna add another axis mapping, and we're gonna call it mouse movement. Here, we're gonna select mouse. We could use mouse X and Y, but we will use this time X and Y. Now with this, also, we're gonna open our player controller, and inside it, here we have this mouse right here, it is. We are going to add our mouse movement, and in this case we really don't care too much about the axis value. We only want to know if our mouse is in the edge of our screen. So let's first print where is our mouse, just to know that everything is working nicely. I'm gonna set a duration of 0 so my screen doesn't get filled with messages. Now, when I'm gonna test, I'm gonna see that if I press inside my capture, I lose my mouse. So let's go to class defaults and here show mouse cursor. Now let's press play. If I click, then it is still showing the message hello, but my mouse is going over the edges and we want to get my mouse stuck in the edge so we can edge scroll through the map. So let's go to project settings again, and here in viewport properties, default viewport mode, mouse capture mode, just leave it like this, and in the lock mode add lock always. Let's go out to my player controller and here add the mouse position node. Get mouse position, and we should be able to append a string, which is just joining two strings. And I'm going to add the location here and the location Y here. So the X and Y will be shown in a screen. So now 0, 0 should be this corner and the maximum volume should be here. Okay, so now we need to know when should we start the movement, right? So whenever this is 0, we should start the movement, and whenever this is the maximum volume of X or Y, also should be time to add the mouse scroll. So what are we going to do then? Here we can also get the viewport size, and here in get viewport size and right click. Let me see if there's another viewport size. Viewport size scale. No, this one. My mouse was controlled very weirdly. Okay, so here is a vector 2D. We can split it and we will get the vector size. We can then use this vector size to get a value from 0 to 1, so it becomes easier to check. I really don't want to do something like this, like compare if this is more than 12, 8, no, 12, 0, 0, and this is, oh, this is the maximum edge. No, it's better if we just translate everything from 0 to 1, and from there we can just compare between 0 and if it's 1, then it's the other edge. Okay, so to get a value from 0 to 1, I need the current value and the maximum value. So this one we can just divide by the x1, and the y-axis will be the same conversion. And now let's see if this is giving me a value from 0 to 1. So here should be 0, 0, here should be 1, 1, or almost 1, 1. So at least I know it is working, and I know that I won't be able to use 1. I mean, we could round the numbers, but why go through so much? So if for whatever reason it's just, I don't know, 98, 0.98, then it's probably the edge. Okay, now with this in set, we can start, and I'm just going to copy and paste this part. Don't really want to delete my debugging just yet. With this in place, what we're going to do is whenever this value is less than maybe 0.1, then it should be detecting as an edge. And maybe it's too much. Let's put 0.02. And what are we going to do here? What we're going to do is have a variable that will store the movement that I should add to my axis. Okay, so we have one value for the move forward. So here I'll add variable, and I'm gonna call it mouse forward scale. Set it up as a float, and here also mouse right scale. Now I can check if this is 0.2, and we should probably use some variable here, and I'm just going to call it viewport edge threshold. This should be editable if needed, but if it's in X and it's lower than this value, then what we should set here for this, if we're talking about X, we should use the right scale. Let's set it up. And here I'm gonna add a select node. We could add a lot of if nodes, but it will get cumbersome in a bit. Or maybe at first, let's just use the if nodes so it's easier to understand. So let's just add an if node, which is a branch. And here, if this number is lower, then we are going to use the right scale as a -1. And we can already test it, but first we need to do something here. Because right now I'm using the x-axis, even though, and let me print it, even though it would probably sometimes output 0. Let me just put 0 in duration. See, here I have 0, which is this value. So if this, I could also add an if node, but let's use a select so we can get used to it. Here in the scale value, I'm gonna just drag and drop it and choose select. We can use select float, and here it will ask us something, a boolean. If it's true, it will pick A. If it's false, it will pick B. So I want to know if this axis value is different than 0. If that's true, then we will pick A, which is this axis value. If it's false, then we will pick the mouse right scale. And now let's try if it is working. And right now X seems to, it seems to be working just fine, but let's see what's happening with this value, -1, and this should be true if we are using it that way, and we're asking if this value in X is less than the viewport edge threshold, which right now this is outputting true. And what I just did is a debugging mechanism that Unreal has to know when our project is doing a specific action. How did I did it? I just press F9. You can do it like that, or right click and toggle breakpoint. So whenever this gets executed, it will finish. And we can inspect our code and the values inside it. We can just put our mouse on top of it, and this tells me this has returned a true value. This is the viewport HUD which is 0.02, and this one is 0. So at first, our mouse is starting in the 0, location, so this is being true, and we have not set up this value to return to 0. So that's why we are still moving around even though our mouse is not there. So if it is false, then just return it to 0. Now if I put my mouse here, it is working, even here, even here. And we should test it with also the right side. So if it's false, then we can test the right side. So we could do something like this. And add another condition. So here, if the viewport HUD, but I want to test if this X is greater than 0.98. We can get this number if we just subtract 1 minus the threshold. Like this. So if this is true, then the scale should be 1. And if everything else fails, then it means we are at the center, so the mouse right scale should be 0. Okay, let's press play. If we will go this way, it works. If we go that way, it also works. And I'm seeing that I have a lot of threshold. We can, what did I do with the, here it is, F3. We can move around. If we press Shift F1, we can release our mouse and we can move around our scene, and it should still work because we are getting the viewport size. And the threshold, it may be too much. We can change it to 0.1. We can polish the camera movement because I don't really like having this type of conditionals inside other conditionals. Doesn't make too much sense to me. We can just get rid of this, well, this part, and use the same select node we used here. So here, gonna add select float, and again, if the viewport edge threshold, if the mouse position is less than 0.01, I will use -1. If it isn't, then let's use another select. And here we will add, again, if the mouse is greater than 0.99, then we will use 1. Otherwise, 0. So it looks a little bit better. And I'm gonna put it like this. We need to do the same exact calculation for the mouse up, well, the move forward, pretty much. And it is working. So let's do the same for the other thing. So let's just put it like this. I'm just going to delete this part, and I'm gonna delete this part. So now I'm just playing with the Y position, and it's exactly the same. We just need to replace this with my forward scale. We can drag and drop a variable and drop it on top of it to replace it. This part is exactly the same, and well, this part is this part. Now we will move it like this. And I need to also replace the code on top of it. And yeah, it's the same thing. So let's move this a little bit up. We're gonna select the scale value here. Mouse right scale. Let's replace it with mouse forward scale. And here, axis value should be different than 0. And press play. And right now I'm getting the inverse values. So let's just change here in the forward. This should be +1, and here should be -1. Now it is working correctly. And this means that if you decide to use the keys for some reason, the keys will be very important. And when is my S key not working? But my W and my A and D key are working. So if I'm moving here and I press the other direction, the keys have the priority and the mouse is secondary. If you want it the other way around, then you just need to change this comparison. Like here, I would put it like this, and then this to A. Now, why did my... Oh, this is why it was not working with my W, S, and S key. That was why. Okay, the last thing to get the camera finished should be changing a little bit of the movement. Let's just use this shortcut, Ctrl P. It's very useful. Use it all the time. And I'll just type player camera to open the blueprint that I created. And here I'm gonna change first the max speed. Maybe this value should be fine. And definitely the acceleration should be changed. Maybe twice the speed. A lot better. The deceleration should also be upped. And even more acceleration should be fine. Yeah, and more deceleration. Let's put more acceleration. Oh, a lot better. Like it a lot more. Yeah, that's great. Let's get rid of that debug message. And this is firing every frame because our mouse can move every frame. But we're setting up this scale and this other forward scale and using these values to drive our RTS camera. So let's select all of these inputs Move them a little bit lower and press C to create a comment, and this comment should be camera movement. We have added the camera of our game, the inputs of our game through the mouse and through the keyboard. And now, well, we should add the character, but in this case, our player doesn't have a specific character, right? So what we could start doing is start with the base. So we have a blueprint of a building that later we can use down the road. So let's add it. Here, I want to create a blueprint with this mesh. So what I'm gonna do is, let's go to the core, let's go to create a new folder, and this one I'm gonna call it building. And inside it, I'm gonna want to add anything that a building will have. Now, we will start creating this RTS game. Take in mind that it's just a beginner's tutorial. There will be a lot of optimization that must be done in order to ship one of these games. So whatever I end up doing, I will try to make it as scalable as possible, but there will be always some kinds of caveats and asterisks on the things that I'm doing in this tutorial. So I'm just not trying to optimize everything to the max, just whenever it is convenient for me. So let's create our building. Blueprint class, actor. An actor because it's a blueprint that I can put inside the map. And I'm gonna call it blueprint building. And really, that should be it for now for this building, because maybe a building doesn't mean that I only need to have a static mesh. Maybe it could be a moving building and I would need a skeletal mesh. So here I'm gonna use a concept of programming called inheritance. So we can create a base class, and from there we can create a child class. How do we do that? Here in the content drawer, blueprint building, right click it and create a blueprint class. This building will be the specific building that I need. So this will be my, how could it be called? Main camp. Or maybe main building or main square, main, let's just call it town hall. There it is. Sounds a lot better. So here in the town hall should be, let's open it, our mesh. So let's add a static mesh. I'm gonna call it town mesh and give it the value that we need, which it was the brewery 01, this one. Let's remember that in Unreal, saying that a blueprint has is facing front means that it is facing the X positive axis. So let's turn it around to face the X axis. There it is. Now let's save it, compile it, and let's drag and drop it to our map. Let's just remove this and let's put the town hall here. Because I know this mesh doesn't have a back-facing part, I'm gonna put my town hall near one of these mountains. So maybe here could be a good spot. and I lost it. Here it is. Just to simplify things for me, I'm always going to make these rotations based in 90, just so it's easier to position stuff. And here I would need to modify the map in order to cover for this building part. And now we can tool strength, brush size. Here, using shift, we can lower it so we can see more of our building. Like that. And still a little bit more. Yes, so much better. Any part that we need to add here to hide this, then we will probably just hide it with more meshes. We really don't need to be that strict about it, or we can move it around like this. Yeah, it probably won't even be visible. So let's just find our player start, move it here, press play, and there we have it. Yeah, it's showing a little bit, but I won't get too mad about it. It won't bother me too much. Maybe a little bit here, like this. Okay, that's a lot better. And this brewery, it should really have a little more interesting view. Maybe I can rotate this. Yeah, it seems a little better. A little more interesting. But for now, let's just not worry about it. I will want to select this building just to do some stuff. In order for me to click this building and for it to work, just like this, we can go to our player controller and in the close defaults, we can search for, where is it? Enable click events. The click event will be left mouse button, and now our building, I will need to enable any type of click. And in order to know if this has any type of click, we will add functions, override, and touch enter. No, it was actor unclicked. I'm gonna put print, and let's try it. Should not be able to work. Oh, it did work. I thought this I thought this mesh didn't have a collision. So if it doesn't work for some reason, checking the mesh here, collision, block all dynamic should be able to block the visibility channel, which we are using right now. And that will make this actor on click work. So what I'm going to do here is create a custom event. Oh, excuse me, like this. And here it will be a building click event. Like this. And this actor on click will call the building clicked. Now, why am I doing this? Because we will have different types of building. Here in the town hall, I really should move it out of this core functionality because the town hall is just a part of the overall game. So here in my first RTS, I'm gonna create a folder called buildings. And our buildings folder should house my town hall of here. Also, I can duplicate it and call it house. And we can create another one, duplicate it, and call it barracks, where our soldiers could spawn. And this will mean that if we open the house and wanted to write something on the building clicked event, we can. We just need to go to the function and we need to go to our event called, no, this is not it, building clicked. This is it. Now let's test a little bit. Let's just remove it, just so the explanation of parent and child relationship, it is clearer. So here in the building, I'm just gonna type building clicked, because I don't know what type of building did I click. Okay. And here in the house, I'm gonna add a house in my map. Should look exactly the same. Building clicked, building clicked. If my house, I want to tell in the message that, oh, I'm clicking a house, then I can overwrite that event that I created. And here, house clicked. If I press play, I will click the brewery, building clicked. I will click the house, house clicked. Now, this is overwriting the functionality inside the parent. That's why I'm not seeing this string. But if something here is code that I need to run inside the child blueprint, then I would need to right click here, and this does not need to be selected. Right click here and add a call to parent function. You can decide when to call it, like this. But now it says house clicked first and building clicked second. If you need to do it the other way around, then you can do it. You can select the order of execution. And now house clicked was second and building clicked was first. We want to click on buildings because we want to do stuff whenever we click on it. And also we need to show when a building is selected. This will be very similar like when we were going to select units. So let's just get that out of the way. Now, the way we're gonna show the selection is through decals. Here you can search for decal. And just imagine that this decal is a circle decal and that we will put here. So that way we know we have used the correct building. So let's create a material for this decal. Here inside the building, core building, just create a new material, m-underscore selection indicator. Let's open it. Let's set it up as a deferred decal. And we need some way of making this, and let me put it as a plane, into a circle. So for that, we are going to use the translucent. Now I'm gonna add a base color. Gonna press 3 and click. This is the same as just right clicking, constant 3 vector. Gonna select a nice shade of blue. Maybe that one. That seems good. Now we need the circle. Let's just right click here, radial, gradient exponential, and I'm gonna add something to it. First, let's put 0 so we can check what this gradient is doing. The radius is 0.5 by default. We can modify the radius, maybe go a little bit higher, and we will see that the circle gets too big. We can connect this to the opacity, and we will see that it is changing. So I'm gonna return that radius to 5, and the density should be different because I need values a little more higher. By default is 2.3. Let's make it maybe 4. Yeah, that's better. Now we need the inner circle, so let's do the same thing. Copy and paste it, and this is what we're going to add here. Now the density should be fine for now, but let's add it and see what's happening. Right now the circle gets a lot brighter because it's like duplicating it, but we need to change the radius to a lower value. So let's just press 1, click, and here radius is 0.5. Let's just go to 0.4. Now if we look closer, the middle part gets brighter, but we want it to get darker. So for this, we're gonna invert it. Just multiply it by -1 and connect it here. Right? But it would be good if it was more noticeable. So let's increase the density. Maybe 10. Yeah, 10 could be good. 20. 20 is a lot better. Now I have this circle, and let's use it in my decal. Rocky level, this decal material, change it to deselection indicator. And now we're seeing the circle. It would be a good idea to make it a little bit more brighter. And for that, we can, instead of using the base color, we can use the emissive color. And I haven't applied it yet. And it will be a lot brighter, and we can even multiply it. Multiply it, emissive color here. I'm gonna add a constant, 1, promote it to a variable, well, to a parameter, and let's call it emissive multiplier. By default it's 0, let's just put it maybe 3. And this color also should be a parameter. Selection circle color. That's good. Let's put this like that. And now it would be a good idea to create a material instance out of it. It will be exactly like doing a child and parent relationship. Let's just call it MI from material instance. Let's use this material instance in this decal that I just lost. Here it is. My selection indicator, and I can double click it, open it here like we did before, and we can start changing values, and we can see it update immediately. We can change the color. So when we have units, enemy units, then we can add a red color. So I believe 3 was good enough. And the selection, for now, let's just leave it as it is. And I'll reset this parameter. Now we need to implement the selection indicator inside our buildings. And every building should have one. We could create it on the fly, but that costs CPU resources. So let's open our main building, blueprint building. In the viewport, I'm going to add the decal. I'm in this decal going to select my MI selection indicator, and if you can't see it, it's because there is no mesh here. I'm going to add a plane just so we can see it, and later I will remove it. So here this decal is facing the wrong way, so let's just move it like that, or like this, should be the same. Now we're talking. Now my decal is looking at the right way. And what we need to do is change some parameters, especially the decal size. And let me not remove the plane just yet, because we don't know which building we're gonna use. For example, let's just open our town hall. Here we clearly see that the indicator is in the wrong place, right? So what I'm gonna do is move that indicator, and we can do it per instance of building. So we can just move it around, make it grow. For example, here, decal size, we can just scale it. And let's just also scale the plane. Decal, move it around, and we should make it fit. At the best of our judgment. That should be good enough. Yeah, at least for me, plenty good. We can now get rid of the plane. And if we go to a rocky level, our buildings all have these decals. And this wasn't the building? Ah, the house has its own decal here. And this was the decal that we added for testing purposes. So this is good. I only want it to work whenever I click it. So let's just, and now that I know that I'm not gonna see the part that is looking back because it's open, I just remember that, then I can make it a little bit more closer to the front. Okay, now let's hide this decal. Every building should start with the decal hidden, so let's just click on the decal and click on hidden in game. Compile. You can also click the visibility if you don't like it to be here in the editor, otherwise it will still be showing. Compile, save it. And when this building is clicked, I'm gonna remove this message. I'm gonna make this, and let's just call it selection decal. This selection decal set hidden in game. New hidden should be false. And that's pretty much it. Let's press play, click on it, and nothing happened. Great! Just what I wanted to see. Let's see what's happening here. This selection decal hidden in game. It's in true. Let's see, F9. Oh, I should also turn the visibility. I forgot about that. My bad, my bad. New visibility, now it should work. Play, click, there it is selected. This one was the testing one. If we added a house, like this, should work. And it did work because it showed the little decal that we haven't set up in the house, because the house won't be using this skeletal mesh. The deselection part is a little bit more tricky, because it implies that we know what we have selected. So we need to save somewhere what have we selected. Okay, so in the building, whenever I select a building, well, this is the graphic part, so I'm gonna put it like this. But first I need to save somewhere that I have selected this building, and the graphic part will happen afterward, because I always prefer to have the gameplay on top and then any code related to graphical stuff. So, and let me save the town hall, we don't need it. Selection indicator, we also don't need it, just press yes. And we need to save this building somewhere. And let's remember that we can click on units, buildings, and maybe more. So we don't really know if I'm only going to click on buildings. Here in the framework, excuse me, in the player folder, let's open my player controller. And my player controller is the one that will know which actors have been selected. So we need to create a custom event called actor selected, and we need to add an input, because here I'm going to add selected actor as a actor, and I'm going to save it. I'm gonna add it to a list, because right now I'm just clicking one thing, but later I want to be able to click multiple things. Actor selected, variable, it will be actor, the variable type, and here selected actors. This actor selected, what it will do is add to this list of actors. And excuse me, I need to make it into an array of actors. So here, select here, array. Perfect. Selected actors, gonna make it here. And the selected actor is the one that will be added. Now we need to deselect all the actors. And to do that, we can create a custom event, deselect all actors. Now we can tell the actors here to get deselected. So for each one of them, what we could do is, for example, here cast it to the building, and here we can create a functionality to deselect stuff. This is a direct way of communicating between our blueprints, right? And let's use that direct way to call this actor selected before deselecting this stuff. So in the building, when the building is clicked, then I'm just going to get the player controller, and we don't need a da there, player controller. Player index will always be 0 if you are in single player mode on or in online multiplayer. Let's cast it to PC, my first RTS. The only way the index won't be 0 if it's local multiplayer, like playing 2 people in the same computer. But RTS don't play like that, so we are fine using the get player controller. Now this one we already add, how did I call that event? Actor selected. Actor selected, and the selected actor is this one. So let's just send it a reference to itself, like this. This blueprint is sending a message to my player controller to add the actor selected. And let's just call that add actor selected to list. And for any type of communication, we need a sender, which is this class, the message, which is this one, and a receiver, which is the player controller. In order for one message to go to another blueprint, we need a reference. In this case, the reference, we got it from the get player controller, which we casted to my first RTS player controller. This is a way of getting the exact functionality that I need from the player controller, because if I just try to here type add actor selected, I won't find the function that I'm looking for. Okay, so with this we have added the actor, and I just want to add here in the building a way to make that selection decal disappear. So here I'm gonna add a custom event and for now I will leave it just like this. New hidden will be true and visibility will be false. Save, compile, and this should be able to add the actor to a list. For the deselect all actors, we can, like I said, cast to my building and call that custom event. And whenever I click on an empty space, which should be added as an input, project settings, action mappings, and mouse selection, which is just a left mouse button. Mouse selection. When this is released, we could check and just deselect all actors. So here, when I click, I can see the selection. When I release the mouse, then it's deselected. So it is working, kind of wonky, but we will fix it, don't worry. Let's make this solution a little bit better. First, we need to move this deselect all actors and move it to the actor selected, add actor selected to the list. So whenever we select an actor, first we deselect all the other actors, and then we add. Now we're not cleaning up this array, so after we complete this, we should selected actors just clear. And now we will have a very clean array. Now I wanted to also change the way we are communicating because I don't want to cast for each building, unit, or whatever we want here. I just want to send a message to get deselected. For that, we're going to use interfaces. And here in the building, probably would work with units and anything that is clickable, especially because I already created this selection indicator and everything else. I'm just gonna put it here. Blueprint class, and wasn't that way. Right click, blueprints here, interface. An interface is a special kind of blueprint asset. We're gonna call this blueprint interface selection events, or selection events. And enter. And why is it special? Because here inside the blueprint, we can't edit any functionality. We can only define the name of the functions and the inputs and their outputs. So in this case, I only want a function that deselect and maybe we cannot select it if we need it, but let's just compile and save for now. And that's it. I don't really need inputs or output right now. So let's go back to my player controller. And now we don't need this cast. We can here for each element, I'm gonna ask if it is the interface is being implemented. So does implement interface. Which interface? The one that we created, that was the BPI selection event. Gonna add an if node like this, and it's occupying too much space, so let's put it like that. And if we are using that interface, then we are going to call deselect message. There it is. And let's call it, because I just saw that there are some deselection here, deselect elements. We're gonna call this deselect this. So now it is sending a message called deselect this. to whatever actors are inside this array. Now, my building should be inside this array, so in the building, I'm gonna implement this interface. So the implementation of the interface will make it so my building will start using all the functions that are here. And we can define the functionality of these functions, because here I can't add any type of code. So now, in the building, let's go to class settings, implemented interfaces, and add our interface. Here in the interface, now that it has been added, we can look in the My Blueprint section of My Blueprint, and here in interface, we will see every interface function that we have implemented here. So let's start filling the gaps. So right-click it, implement event, and deselect this should replace this custom event. And voila! That's pretty much it. This is the implementation of the event deselect this. Let's press play, and it should be working as always, but even better. Now with the selection system in place, we can start adding units. So let's find the unit that we are gonna use. Content here, let's go to a skeletal mesh, flamethrower, and this one should be it. Let's see if it is working. Oh, yeah, sure, let's create it. Let's see if we can use it. Attached asset could not be found. It's fine. Let's see if this has the... Yeah, should be fine. Let's save it. Save this here. And let me see if the animations are working. Showing folder view, Warhammer anims, idle. Could not find the skeletal. Choose a new one. Yes. The dwarf ground. And yeah, it is working. That's good to know. Let's fix the materials, right? Let's go to the skeletal mesh. Here we need asset details, and I don't want it to be like that. Like this. We have two material slots. We should be able to create the materials needed, and we can highlight to see which slots are affecting which part of the body. So this one is the overall character. Let's create a material here. Material. And for this, in my first RTS, I'm gonna create a new folder called characters. Duplicate it, open it, new folder, dwarf. Inside it, we will add the dwarf body. And here also the dwarf accessories. It could be called armor. Yeah, it should sound a lot better. Search for it. Dwarf armor. And it is simpler. And reflects the state. Yeah, that's the armor. Let's open the dwarf body. Let's look for the materials we need. And it will probably be here in characters, dwarf grant, materials, equipment, grant, warhammer. And oh, there are already the materials here. Let's just open them and fix the same way we fix the textures here. Oh, this is a parameter. Diffuse parameter name. Here is the texture. Dwarf. If I can type right. Dwarf grant blue diffuse blue, and there should be a red, I believe. Well, let's just put it like that. The normal dwarf grant. This is a mask, this is the normal, and here I have the mask. There we go. Let's save it. Let's add it. Browse. Where is my skeletal mesh? Here it is. And let's add it. Select it, or just drag and drop it. Ah, that's better. Armor. Well, equipment. Ah, I was near. The name. This is a material instance. So we need to select the parent. Parent should be something with dwarf, I believe. Dwarf grant equipment, this is not it. Grant, this is not it. Also armor. Well, it could be the grant, and we just change the diffuse with the equipment. The normal with the equipment normal, and the mask with the equipment mask. Let's save it. Let's go to my skeletal mesh and add it. Yeah, and it's working correctly. Yeah, pretty good. Pretty good. There is a warhammer somewhere, probably. Hopefully it's not lost. If we need it, we will add it later. Let's save this. And now we have our character. We can proceed to add a unit. That will be this dwarf. Let me just remove these other materials and the materials that I created. Or we can leave it there. They are not bothering no one. If we need to add something to the dwarf, we have a place to do it. Okay, so let's go to the core. Let's go and add a folder, unit, and here what I'm going to create is we can add a blueprint for any type of unit, but I don't really want to have a parent that will work for maybe 20 units, 40 units. It doesn't seem very scalable to me. So what we're gonna do is create a blueprint class, and we will select the, where is it, actor component, and I'm gonna call it blueprint unit component. And we will see how we are using this component for, well, most of the stuff. We do need to create this worker, right? So let's create the worker unit. Now we will have a lot of workers. We will have different types of unit. So we can here go to my first RTS, go to new folder, and maybe if later on in another tutorial we add different types of workers, we can extend from them. Yeah, let's here in the core unit, let's add here the worker unit. Blueprint class, and as I said before, this is a starting point. You can optimize a lot of stuff in the future. And for example, instead of using a character, we could be using a pawn. It will be a lot more lightweight than the character, but we will need to fake a lot of stuff. And I don't want to make this tutorial last like 10 hours. I'm seriously concerned about the length of this tutorial, but so I'll select a character just for convenience. Gonna set the name as blueprint unit. Oh, excuse me, worker. And the worker will have the unit component here. So everything is just the same, but we have this unit component. Okay, so this worker needs a mesh, so I'm gonna select my dwarf. This dwarf should be here. Yeah, -50. The capsule height, maybe a little bit less, maybe 50. Seems alright. Maybe 55. And I can drag this a little bit to the bottom and change this to 60. Yeah, that's better. Yeah, and the radius, let's just keep it at 40. That will be my unit for now. Let's compile. Let's save it. Let's move it to the ground and see how small it is. And it's way too small, so let's change the scale of the worker. And here in the capsule component, I can choose to duplicate the scale, compile it, save it. This should be twice the size, so let's put it like this, press play. And it's a little bit better. I'm not really sure. Yeah, it should be fine because it's well a dwarf, right? So the scale should be fine for now. I will try with 2.5. End key. Let's press play. Yeah, it's a lot better. I like that scale. Good enough for me for the first worker unit. Now it's time to take a break again. It's good to get up from time to time, take a walk, take a breath of fresh air. And while you do that, I can review what we have done. Also, if you have opened your map again and you are not seeing anything, be sure to go to Window here in World Partition and World Partition Editor. You will see that maybe these boxes are unloaded and you won't see anything. So just select everything and load the selected cells. So we have added a unit, polished the selection and deselection through blueprint communications. Also, we have created the needed classes for our game to work, created the player camera, and also added movement through the mouse and also with the keys. Right now the key movements are with W, A, S, and D, and I would probably move it to maybe the arrow keys or something of the sorts. So if you're in the Premiere, well, you can take a pause, but if you're just watching this later, be sure to pause the video and take a break. We should be energized, so let's continue. Let's start by selecting our unit and making it move. First, let's focus on the selecting part. Right now, if I select it, nothing happens. So I'm gonna open that unit, can right click and edit the worker, and I will be using the shortcut Ctrl E in the feature. Now here we had this blueprint unit component, and I'm gonna also edit it. And here open full blueprint editor. Okay, now that we have these two classes open, I need first to add the selection decal. So in our blueprint worker, let's add the decal. The decal should be rotated 90 or minus 90. And also, we should select our selection indicator, the material instance. That's better. Let's compile, save it. Let's see it in the here. And we need to make it a lot smaller. So we could also add a plane. But the plane should be outside the decal. Now here I have reset the rotation. Let's scale it. Let's scale the plane. Just so we know what's happening with the decal. And this decal definitely is too big, so let's just scale it down. And we can get rid of the snapping by clicking here. And also, we can continue fine-tuning it. Something like this would be fine. Now you will see that it is affecting our character, and that's not something that we need. So we can click on the mesh. Here, search in rendering, it should be advanced, and receive decals. Let's just put it to false. Now we can put the plane at the feet, and we will see that it is working correctly. We can get rid of that plane, compile and save it, and see if it is working. It seems it is working, so yeah, that should be good enough. If we select this, yep, seems good to me. If for some reason you need to, or well, you want to keep the same size of the circle, and what I mean is this part, this size, then instead of scaling, you need to modify these values, decal size. I'm just scaling because if it's a small unit, then at least for me, it makes sense that it is a smaller circle. Okay, so we have that part. Now we need to remove the visibility and hide it in game so we can select it. Yeah, pretty good. Now, would be a good idea to also make the decal a little bit smaller and right near the feet. Yeah, like that should be fine. With this, we can start making the selection work. And because I do not want to create for each character that I have inside my game, I don't want to create an event here, capsule component, add event, unclicked, and then do that thing for every worker. I'm gonna use this component to my advantage. The normal way we would do it, it's really simple. we can, instead of doing that, here we have in the functions, an actor onClicked, which is the one we used before, and then the decal, we just make it appear, set visibility, and set hidden in-game. This is what we did for the buildings, but it would be a waste of time to make the same functionality. And oh, didn't work there. Visibility true, new hidden true. Is this working? Like, there's anything that collides with this? Bound. Oh, visibility is blocked. Okay. But because I don't want to do this, we'll fix the other stuff in a minute. Because I don't want to do this for every worker I will have, or for every unit that I will select, here in the unit component, I'm gonna create that. So in the begin play, we're gonna do something called binding. So what is binding? It forms part of a way of communicating blueprints, so that whenever a blueprint sends a signal, we can start listening to that signal and do something upon it. It's really similar, like how we here in the capsule component do right click and add the event, begin overlap. Here I'm listening to that begin overlap event. So whenever something overlaps this capsule, then something will happen here. But I want to listen to this event on actor clicked. So this component, because it is inside this blueprint, the owner of this component is the blueprint worker. So what I'm gonna do is first get the owner, and the owner of an actor component should be an actor. And from the actor, I'm gonna type onClicked, and we have this event onClicked. I'm gonna bind it like this. So every time the onClicked event is fired, then this component will also be able to do something. So we can create whatever we're gonna do here, and the event, we can connect this to the events like this, but it needs to fit. Here is not compatible because it is not receiving the same information. So what I'm gonna do is here create event, and we could select event if something fits, but nothing fits, so let's create a matching event. And I'm gonna call this on owner clicked. Could be clicked, could be selected. Let's just call it on owner clicked. Okay, and here, because we changed the name, we need to select again on owner clicked. Perfect. With this, now every time this worker is clicked, we will have an event that listens to it. So for now, I'm gonna print string here. The owner was clicked, and we will see if it's working. Right now, I believe it's not working because I'm not colliding with anything, and it is time to replace our collision. Right now, the capsule component, if we check the collision, it is a pawn, and currently our pawn ignores the visibility. I don't really want to mess around too much with these trace responses, so what I'm gonna do is create another collision channel, so we can have some channel that will only work with our mouse or our cursor. Let's go to project settings, and in collision we can create a new trace channel. So here, The default response will be blocked, so we don't have to modify anything. And we're gonna call it maybe mouse or click or cursor. Let's just say cursor. So it will be the channel for the cursor, because here I believe most of the mouse stuff, yeah, cursor. Okay, so we need to use that channel. We will see that whenever we compile now and select our capsule in the collision presets, there is another channel called cursor and it is blocking it. So let's go to our player controller, and here in the class defaults in mouse interface, we will use the default click trace channel and change it to cursor. Let's save it, and now let's press play. Should be working. The owner was clicked, and also it is working the selection material. With the component set up as we have done it, just like this, we can then modify the way that we are doing this part. So we don't need to add the code here. So here I'm just going to just copy these two nodes and delete this. And the unit component, whenever the owner is clicked, I want to select to make the decal show up. So here I'm gonna create a custom event in the unit component. Show selection decal. And from the owner, I'm gonna find the decal component. So get component by class. I'm gonna put decal. And now here, I'm going to paste this stuff, set visibility, and set hidden in game. The target will be the decal component. Let's compile it and save it, and also let's put the show selection decal here. Show selection decal. Let's press play, and even though my blueprint with our worker doesn't have any code to make the decal disappear, our component will get busy and make that decal work. That way we only need to set up the decal and how it will be seen, and that's pretty much it. The component will be in charge of making the selection show up. We are now going to make this unit move. We need to save the reference of this unit somewhere, and we are also going to use this player controller, my first RTS. So, oh, I was testing stuff here. We have an add actor selected to list. We have this deselect all actors that we will modify in the future whenever we added the multiple selection, the multiple unit selection. For now, let's, in the unit component, create a custom event, and let me move this here. Custom event, add unit to selection list. And I'm gonna call it here. Let me remove this message. Add unit to selection list. Just so we have a clear understanding of what's happening here. And if we need to go to the specific of what is adding a unit to the selection list, we can go and read the custom event. So this custom event should get the player controller. We should cast it to my player controller. And you may wonder why I'm not using an interface for our player controller. It's because we will only have one, and at the start of the game this is loaded, so it doesn't matter if I cast it to it. And here, add unit, add selected, how was the add actor selected? Add actor selected to list, and the selected actor in this case is not this, because this is a unit component, it's a actor component, it's the owner, like this. This makes sure that whenever we click on the owner, we select it, we add it to the selection list, and also we show the selection decal. Now in my player controller of my project, save everything and compile. Don't remember exactly if we added this input, but just in case, let's go to inputs. And in action mappings, we will add the mouse selection. I believe we did add it in a previous video, but let's make sure that we have this mouse selection, left mouse button. And here in my first RTS player controller, let's go a little bit down and let's use it mouse selection. So if I have something in my selected actors, I want them or it to move to the place that we are selecting. Okay, so whenever we release the button, and it probably should be the right click if I want to move it, so let's just add the right click, mouse selection and mouse action. Right mouse button, mouse action. So whenever we release this mouse action, which is the right click, we want to ask if these selected actors are not empty. So if they are not empty, oh, and it's not in the pressed, it's in the released. If this array is not empty, then we should make them move. Because I don't know what type of actors are here, and we need to do again the for each loop, exactly the same as we did before with the deselection, that we use an interface. Let's also create an interface for unit actions. So in the unit, let's just right click, blueprint interface, and let's call it BPI unit actions. Let's double click it and let's rename this function to move to this location. Great. Now we need to send them a location, so let's add an input and let's put a vector here. This will be the goal location. Compile it, save it, and yeah, that's it for this interface. So this mouse action, if our selected actors are, well, it is empty, it's not empty, excuse me, we will send them to move to this location. Now we need to get the location of the mouse. To get the location of the mouse, we can right click and get cursor hit result under by channel. This one. And we will use the visibility channel because if I click on top of a character, I really don't want to collide with it. So visibility is fine. The hit result, we can break it. And here we will use only the location. We can draw debug sphere just to see if this is working. Center here, radius is fine. Let me put a red color so we can see it very easily. Duration maybe 10 seconds and the thickness maybe 5. Let's press play, and right now I'm right clicking, nothing is happening. I'll select the unit, right click, and I can see where our movement will go. Pretty good. So it is working. I only need to add the validation here and ask if it is implementing this interface. And if I didn't add it, then if the interface is not implemented, this just gets ignored, but this keeps our code pretty safe. And this will be BPI unit action. So now this should be working correctly, and let's put the code like this. Perfect. This will send a message to my unit to move. My unit, in order to understand the message, we need to, well, go to the worker here in class defaults, and let's implement the interface. And it was in class settings, excuse me, implemented interfaces. Let's add my unit actions. We have this move to this location and implement event. And here what we are gonna do is drag a node here. And for now, let's just use the move to. And there should be an AI move to. AI move to. This is the one that I needed. AI moved. The destination will be this. The acceptance radius, let's just put 50, just in case. The pound is, well, this is the pound. So it would be self. And the target actor, we can leave it blank. Now, this won't work out of the box. Because one, we have not added the navigation information of the map, and also we have not added a controller suitable for the worker to move on its own. So first we need to add the information of our map. How do we do this? Let's here in add new content, type nav mesh, or just nav mesh bounds and volume. And this volume, right now you see is not doing anything, but if we press the key P, we can see that a green area has been added. This green area is right now the only movable surface inside our map. So let's make it bigger, like this. And now you will see that whenever this collides with something, for example these mountains, it is, even though it is bigger, the collision ends here. So even though my volume is bigger, because of the collisions, our AI agents won't be able to go this far. We can fix this by increasing our height. And this should cover most of the map. Or well, most of the playable map. If we really don't want them to go near the mountains, then we can make it just like this. And I'm gonna move it a little more. And make sure it's fitting your map. For example, like this. These parts are not inside my collision, so let's add a little bit more height and make it fit. Perfect. So all the green zones are the parts where our player can move freely. Well, our AI will be able to move freely. Great. Let's put P again, so you don't need to see the green stuff. And maybe this nav mesh, let's add it to its folder called AI. But still, this won't solve the problem. Oh well, it did. I thought it wouldn't, but it seemed it did. But let's add the player, well, the AI controller for this character, because we will use it later, so we still need to add that AI. Here, in the unit, right-click it, blueprint class, and we are not gonna control it through our inputs in the keyboard, gamepads, etc. We need the AI to control it. So all classes, let's just type controller. And here the AI controller is a type of controller, just like the player controller is a type of controller. So let's just click on AI controller. Let's call it AI controller dwarf, or well, worker, or could be unit. Yeah, would be better, unit. Let's double click it, and we don't really need to change much here. So just save it, close it, and in your worker, go to the class defaults, and in the pound category, auto possess AI, let's just change it to place in word or spawn, because our buildings will spawn units. And the AI controller class by default, it did have an AI controller, so that's why it worked. But we will select our own AI controller unit. So this should be still working. Right now my rotation is not working that well, so here in the worker, where's the arrow pointing to? It's pointing that way, so we need to rotate it 90 degrees. Compile and save it, and this unit should be able to go wherever we need it to go. The magic thing about this setup is that if we add, and let me press P again, if we add maybe where's my cube? A cube here, and I'll make it large. This cube already interacts with the nav mesh. So whenever I press play and I ask my player to go this way, my unit will avoid the cube that way. Perfect. With our character moving, it would be a good idea to show an indicator on where did I click on the map. let's create that by going to the player folder here, create a Niagara system, new system from selected emitter, and we could use the dynamic beam or the static beam. Let's use that. Finish. Let's call it Niagara system. Click indicator. With this in place, let's double click it. We can see what's happening. And right now it's spawning to the side. So let's click on the static beam here and search for the spawn beam. Was it this or was it that? Oh, beam emitter setup. Here it is. Let's change the beam end from 0 in X, Y 0, and C. Let's put it 600. Save it. Let's go to my player controller, my first RTS. And here in the mouse action, at the end of this code, let's add spawn system at location. This system is the click indicator and the location will be this location. Let's press play, click, and we can see the beam. Let's tweak it a little bit. We want it to be a lot more, have more width, and also to not be looping infinitely. Let's go back to our Niagara editor, which is really an editor for any type of particle. We are using a static beam, so we don't have to create stuff from scratch. So in order for our particle to not loop indefinitely, let's click here to the default values of our Niagara system and go to system state, loop behavior once, loop duration 0.5, and you would think that's it, right? It's not. First, we need to set up the timeline to go to 0.5, and if you can't select it, you can type it here and press here to set the playback end. Right now we have changed the loop duration of the overall particle, but not in this emitter. A Niagara system consists of multiple emitters. In this case, it's a simple one, so one emitter is fine. In each meter, then I need to go to here, loop behavior once, and loop duration 0.5. Now we still need to change the beam lifetime 0.5. Now we are seeing that it disappears, and we need to change the width. That will be in the, where is our beam? Here it is, beam width. You could also find it here. If you click here, it just shows you the specific part that you need in this editor. You can change the scale, but we could also just change the scale of the curve. Excuse me, you can change the curve, but we only need to change the scale. So let's multiply it by 100 and test it. Click. It may be too much, so 50 could be a good value. Yeah, there we go. Working pretty good. Next, we're going to add the gold resource. Here is my static mesh for the gold. And let's go to my content drawer. At the core, I need a parent blueprint for all my resources. Let's go to blueprint. And first, let's create a folder for it. New folder, resource. Here, right click, blueprint class, actor, blueprint, resource. I need a child of this blueprint, so right click, create child blueprint, and here this one will be blueprint gold. Again, I need a folder here for my resources, and this gold resource should be here. I'm doing this separation because that way any type of artist can enter this blueprint and it won't affect the logic of the resource. And only the programmers should enter the core folder, or well, anyone who knows what they're doing should enter here and can manipulate with what is going to happen here. The resource, I need a type of resource. Let's just right click, and we're going to create a, here in the blueprint category, enumeration, which will give me a list of numbers which will be from 0 to 255, but I can assign them a text to it. So here, let's call it resource type, and let's add an enumerator. And for now, we just need two. The first one, it's a good idea to always have a non value at the start. And here, this one will be gold. And if I had more resources, maybe wood, I could add it here. Let's save. And in the blueprint resource, because I don't want to have to rely too much on this blueprint, what I'm going to do is create a blueprint class, actor component, and this one will be blueprint resource component. I will add this resource component, and inside my resource component, let's right click, edit it. I'm going to add the variables type, the type of resource type. This one is just gonna be called type, and I'm gonna make it instance editable by clicking here, compile, and maybe here another variable that will hold the number of times it can be mined. Also, how many resources it will give, that also should be an integer. I don't want to deal with 2.5 gold, right? So here, resources to give, number of resources to give. It is better to have long names in the variables if they are going to make it easier to understand later on. So if I just put, I don't know, X here, then I need to ask myself, oh, what did I was thinking when I called this just X? What does X mean? So it doesn't matter if it's a little big, the name. It's a matter of clarity, a matter of being easy to understand. So let's compile, save, and also make them instance editable. Now here, in my blueprint resource, I can see the type of resources, but I don't need to modify that. What I need to do is open my gold resource. Where is my resources? Gold. And inside it, I can click on the resource component. The type of resource, I can change it to gold times it can be mined. For now I'll put it 10 and it will give me, I don't know, 5 gold every mining. Compile it, and that's pretty much it. I need to add my static mesh here on the blueprint gold. So here I'll add, where is it? My static mesh. Gonna call it gold mesh, and here let's find the gold pile. Let's compile it. Let's drag and drop it because I know it is definitely too small. So I'm going to select my gold mesh and the scale. Gonna click on the lock, so I just need to modify it once and every value will get modified 2 times, maybe 3 times its size. Yeah, that's a lot better. Right now this gold does not have a collision. We could create a collision for it. Let's double click this value. And if I needed a collision, here I can add a sphere collision, box collision. Maybe one of these could give me some kind of interesting result. If you don't like the collision that you get, you can remove the collision. And yeah, this one is good enough. I don't need that much precision in my collision. So let's save it. And now when I press play or Alt P, I can move this and it will start avoiding my gold. We need to change how we're clicking on the map. So we can here click on top of the gold and start mining it. Right, first let me move the gold. Remove this static mesh and move the gold a little bit to the side. Something like this. And this gold, I need to know if I'm clicking on a resource. For example, where was I clicking on stuff? It was on my player controller. Let me save everything just in case. Player. Here is my player controller. And here I'm clicking on stuff. I need to know if my click was in an empty space while having someone here. I need to know if I clicked on an empty space or on a resource or maybe a building. So this doesn't happen, right? What I'm going to do is add some code to the mouse action. I still need to know if I have a selected actor, otherwise this won't work. We can call this part unit movement. But now I need to define when I want to use this unit movement. So what I'm going to do is get this hit result again. And in the impact, well, in the location, impact point and location in this case, because it is a line trace, it will be the same. So let's not worry about that too much. At the location, I want to know with who did I click. So I could get here location, or also I could just get the actor that I am clicking. I'm not doing this because there will be cases like when I'm trying to go here that maybe I should have clicked on the building instead of just trying to go here. So I do want to have some kind of room to know where I'm clicking. What am I going to do? Just like I did with the draw debug sphere a few sections before. Draw debug, where is my sphere? Something like this. Center, radius, call it red, whatever. I want to know if I have overlapped someone or something here. So what I'm gonna do is, in the location, from this true pin, I'm gonna call it overlap, and we have a sphere overlapped actors. Where is the sphere position? The same as this one. The radius for now, 100 seems like a good number. Oh, and we have a little error because our object types is not ready. And the object types, we can just drag and drop here and make an array. Make array. Word static, and we can see which type of collision object it is. If we go here, we select our blueprint, and in the collision section of whatever has collision here, in this case it's the mesh collision, block all dynamic makes it a word object type dynamic. This one is this one should be a pound. Collision presets pound, object type pound. So I need word dynamics and pounds. So here word dynamic, and add a pin, pound. Pretty good. Now, if it's a pound, we should attack it. If it's a word dynamic, then it means it's a building or maybe a resource. Because if I go to the resource, well, to the gold mesh should also be a word dynamic. Word dynamic is anything that could be moved around or could change during runtime, like being destroyed, for example. That is considered a change. So now, if I do not click any word dynamic or any pound, then this will be empty. So if this is empty, gonna create a branch here. If this is empty, it means I didn't click on any building resource or unit, so we can proceed with our unit movement. Let's press play and see if it's working. I will select here, and here it did work. I'm not sure why here it didn't. Let me check with this draw debug sphere that I completely erased, I believe. So again, let's add it again. Draw debug sphere. The center is this one. I'm going to make it last longer. 20. Thickness 5. Line color red. Play. Select it. This worked. This didn't work. Why didn't it work? I can press tab. Excuse me. The apostrophe and tab, and we can move our camera. And it seems it didn't hit the building, and I don't remember if the building had some collision. Maybe we're missing a collision there. Town hall, viewport, town mesh. Let's double click this. Let's see the collision. Show simple collision. Seems it doesn't have a collision, so we can here convert. I just need a simple box collision. That's it. What's that? Why is it only there? We can move this to make it fit. That's more than enough. Let's save it. And now let's try it again. Yeah, here I'm colliding. Here I'm not colliding with it. Colliding with this. Perfect. It's working. This is considered as a world static, so that's why I'm able to go there. Because anything that we just drag and drop an static mesh, here the collision presets default makes it a object with the type world static. We can go back to the player controller. Where's my player controller? I'm going to put it here. And we don't need this resource type, the town hall. I only need these three things. So in my player controller, now I know that I can click. I'm gonna leave that draw debug sphere just in case I need to add it again. I don't need to check no more for if I need to move or not. I already did that here. So what happens when it's false? When we do click on something? I want to know if it's a resource, I want to know if it's a building, or I want to know if it's a unit. Let's just check first if it's a resource. So if it's false, then we will here make an if statement, and what I'm gonna do is ask the overlapped actors, and for each one of them I'm going to try to do something. So I have an array here because we may be able to overlap more than one actor. I believe there's also just an sphere overlap actor. No, it gives me all the actors. This will be a rare occasion if we have more than one. Shouldn't happen that much. So what we're going to do is that if this is false, it means that this is not empty. So from here, I'm just gonna get the first value. And from this first value, what I'm going to ask, if you remember, my resource has the component, the blueprint resource component. So I'm gonna ask get component by class. I'm gonna ask for the resource component, and if it does have this resource component, this will be valid. So it's valid, and if this is true, then I can do something with this resource. So I can put a string saying resource select it. This shows me nothing. This shows me resource. Pretty good, right? Now, what should happen with this resource is that I need to tell my character not only to move to that location, but I need to tell it to mine it. So I will go back to my unit. We have an interface called unit actions, and let's use that. Let's double click it. Instead of move to this location, I'm gonna add a new function, and I'm going to call, maybe it won't always be a gold or something that I can mine, so I will call it gather this resource. And I will send it the type of resource, resource type, resource underscore resource type. Here it is. And this is type of, because with this type of resource I could make it do different animations, because if it's a tree then it could be another type of animation as if it is the gold resource. So let's compile, save it. We can close the interface, and now in my player controller I can ask of this actor that I want to gather this resource. And I should probably send a reference to the oh, excuse me, this is the resource I'm getting. Excuse me. I need to send all my selected actors to gather the resource. It's the same exact code. And I need here, gather this resource, and I could send just the reference to a resource. That would probably be best. Yeah, I'm gonna open up the blueprint actions. We can double click that, gather the resource. Let's just send an actor reference. And this will be resource reference. Compile, save it. We can close it now. Here it changed the resource reference, and the resource is this one. Let's double click this wire so we can organize it a little bit better. So here I'm checking if I have collided with something. I'm checking if it's a resource using the component class that it could have inside it. And then I'm telling all the selected actors to gather this resource. Again, I can add this verification just to keep my code very clean and safe. Excellent. And if you want to straighten this up, select these two nodes and press Q and save it. With this logic implemented, we are telling all our selected actors to gather this resource. Well, the resource that we found in the sphere overlap. What we need to do now is tell our actors how to understand this order. Because if we tell, I don't know, a unit that can attack, that is a fighter unit, to gather a resource, they will probably ignore the resource. But in the case of the workers, we do need to explain what does it mean, this function gather this resource. So let's implement it in the workers. Let's find our workers. Should be in our project folder, core unit worker. And here we have implemented the move to this location. Let's also implement the gather this resource. What our unit should do is go to the resource, and start mining it. So first we can copy and paste this because we need it to go to this location. What location? We could get the get actor location and connect it like this, but let's do it another way. Just target actor. This will work equally well. Here in the acceptance radius, I'm gonna use 200 because it's a little big, this blueprint, this gold blueprint. A little big. So after moving to it, let's test if this is working. Yeah, it is working. We should look towards the gold. So on success, let's set the actor rotation. And to get the location, well, to get the rotation, the correct rotation, we need to use a simple function called find look at rotation. This function will ask a start and a target. The target is the resource, so we can connect this. And the start will be, well, this actor location, like this. So this worker, I'm getting the location here, should look to the resource, and I'm getting the location of that resource here. And with this function, we can get the rotation where we are looking towards this target. Let's see if it's working. Yeah, and it is working. Now, I'm pressing apostrophe and tab so I can look more closer to what's happening. Here, tab, and we see that it's changing the rotation even in the z-axis, the pitch, and probably the roll if it was needed. I only need the jaw rotation, so that doesn't happen. So let's just break this. Well, with Alt and click, we can remove the connection. Let's split this, and just connect the jaw. This should be able to fix it. And with my apostrophe key and then tab, then I know that the rotation is a correct one. Now that our our unit is looking towards the gold, we should start mining. Also, it would be a good idea to add some animation so we know that something is happening. Here in the content drawer, let's go to strategy game assets, characters, dwarf, animations. There should be a walk forward. Could not find the skeleton, it's okay. Let's press yes. Let's choose our new skeleton 1 because this is the one that works, I believe. Yeah. And also we need the attack that we will use as a mining animation. Skeleton 1, this is it. Let's open the anim montage also. Let's use the grunt skeleton 1. And let's fix this. Select on this animation and select our attack 1 new. Yeah, it seems like it is mining something, right? Now with those animations in place, and let's save everything, we are gonna here, whenever we have rotated towards our mining, let's just get the mesh component and set, well, we can play the animation. Play animation. And this should be the mining animation, which is the attack one. Let's also add an animation here for movement. As soon as we start moving, we should play a moving animation. And here, let's walk forward. And this one should be looping, and this one also. Compile, save, play. Our character is not moving at all. We probably should also give it an idle animation. So here in the mesh, we can set it up as use animation asset, and we'll find the idle. Let's double click the idle. I don't know if the idle is working. Yeah, it is. Nice. So let's compile and save again. Play it. We have an idle animation. Select it, move it. I don't know if it was moving, but here it is working. Let's move it towards another place. There it goes. And when this movement finishes, we should go back to the idle animation. So here on finish, where is my event move location? On success or on fail, we should play the idle animation. Idle new. Compile, save. Let's see if this is working. We're moving. We're here. Idle again. Let's go to our resource. Oh, and it seems that it failed, but it was still moving. So let's fix that. Right? It's because I'm... let's check it out. Play, print string, fail. Because I changed the new route, it is giving me a fail. And here I can get what type of result of the movement. Aborted. So if it's aborted, I should keep playing my movement animation. But if it's... oh, it's still aborted. How many states are here? Equals. We have success, blocked, off path, aborted, invalid. Okay, so let's just put if it fails, and this result, let's just do a switch so we can decide, and let's connect it to on fail. We can decide what to do here. And if it's aborted, then we shouldn't do anything. If it's for some other reason that it fails, then we should go back to idle. So if it's blocked, idle. If it's off path, idle also. If it's invalid, also go to abort, to the idle. Success shouldn't happen, only should happen here. So with that, if it's aborted, we are not changing the movement animation. Let's press play. And now we should keep moving. And whenever we reach our mining stuff, then it starts the mining animation. And we can go other place. One thing I would like to mention is that everything that we are doing here, we could also add by using behavior trees or the new technology called state trees in Unreal 5. Those are a specific functionality of the AI system inside Unreal, but we don't want to overcomplicate this beginner's tutorial. So that's why I'm doing all the logic here in the character blueprint, so it is easier to understand. So up until now, whenever we are gathering a resource, we are going to the resource, which would be the first task. When this is a success, then we are going to look at the resource, and then we're gonna play an animation of the mining action. Now we should really know how much time does it consume this unit, so we can play this animation that amount of time. So we have as an input the resource reference, and we can add something like the time it takes to mine, and I don't remember if we did add it or not, but let's check it out. Let's go to core, resource, and it should be in the resource component. And here, type of resource, times it can be mined. Let's add another variable. This one will be a float, a decimal, and I will call it time it takes to be gathered in seconds. And I don't want to wait that much time, so I'll just put 1 second here. Compile and save it. Here in the worker, I really don't care which type of resource this is. So let's just get the component, and let me drag this something like that. Get component by class. We just need our resource component. Perfect. And now let's create a delay node. So here, delay, which will stop the execution of this line for this amount of seconds. How much seconds should I use? We can get from the resource component. Here I will ask get time it takes to be gathered. After this amount of time, and I will put it something like this. After this amount of time, we should return the animation to idle. For now, we should really make it go back to the town center. And here I'll just put idle. Let's see if this is working. Select it, click it. And yeah, after 1 second, maybe 1 second is too quick. Let's just add 3 seconds. Save it, Alt P to play, and make it mine it. After 3 seconds, it is finished. Let's put it 2 seconds. Now it was too long for me. So this is working. Now we need to create the logic where we're gonna store what type of resource did I got, and also which type of, how much of that resource this worker got. To store the amount of resources that this worker will get from mining, we need some variables, which are these boxes that will store information. Let me reset this to a boolean. And here I'm gonna call this resource being carried. And I will use the enumerator called resource type that we created before. Now I want to store here the amount of resource of this type, so let's create an integer and amount of resource. Now, here's when it gets a little bit tricky. First, we need to know if our character, well, if our worker is already carrying a resource. Because if we are going to mine the same resource type, then we need to cancel this action. Also, if we're going to mine another type of resource, then we should get rid of the current resource. So if our character started mining gold, and then it finished, and then it started mining trees, well, gathering trees, then it should get rid of the gold and just have the trees. To do that, here, after we have moved to it, after we have looked to the resource, before we start the mining animation, we should really know if we are going to mine the resource. So let's add a branch here. And let's check if the resource being carried. Let's get this. And where is my component? Here is my component. We seem to be going to use this a lot, so let's put it like this. If the resource being carried is different, is not equal, that the resource I'm gonna get type of resource, then we should mine it. So this will be true. So again, if we are mining a different type of resource, then we should start mining. But we should reset our amount of resources. Because if this was of the type of wood and this is gold, then we should reset the gold and just store the new type of resource. So let's here reset the amount of resources. And also let's set up the resource being carried. So after playing the animation and after the delay, here is also the animation, and I don't want to have the animation being a bother, so let's do a sequence here like this. So after getting the resource, then we can set up, yes, the resource being carried is this type of resource. And let me put this like that. Type of resource. And also the amount of resources should be the amount, or how did I call that variable? Times it can be mine, number of resources to give. Number of resources to give. Like this. And well, the animation will play after. It will be almost at the same time, but this is the main part of the code. So what do we have? Until here, we will move to a resource. We will look to the resource. We will check if we are getting a new type of resource. So if the resource being carried is none, or gold or wood, then we will reset the amount of resources, play the animation to start mining. After the time it takes To start mining, we will get the resources and save the type and save the amount. Now we should know that maybe this action could be interrupted, right? How? Well, here we can press play. This will start mining and then I can move it around, but right now I am getting the resources. Why do I know that? Because here I was going to idle animation after this finishes, but the idle animation fire even though we were not mining anymore. So let's create a way to check the states of this unit. For that, we're gonna use a enumerator. So let's go to the content drawer, unit, and here let's create, where is my blueprints, enumerator, gonna call it E unit states. Let's open it. The first one will be always none. Very few rare cases where this will be something other than none. And here the first state is idle. Second will be movement. And third one for now will be mining. Whenever we get more units, oh, definitely there will be a death state for all the units, and here we will add more states like attacking whenever we get more units. So for now, this is enough. And the worker, whenever it goes to any location, well, it will be, oh, I need to save these states, and I'm gonna do it in the unit component, so every unit gets benefits from that. So let's edit the unit component, and here we will create a variable called unit state. And we will just call it state, or unit state should be better. Compile it, save it. By default will be none. Let's just put it to idle. Let's close it, and in the worker we will get the unit component and we will set the state. And it's a good idea whenever you're working with these components that you don't just set it like this. I mean, you could do it, but probably later on we will use this changing of the states to do something. So in the unit component, let's open it again. Let's create a function called handle and set handle or set new unit state. Because if I just call it set unit state, it will be the same as accessing it directly. Let's just call it handle new unit state, like this. And this function will be very simple. We just set the unit state with a new one. And let's call this new unit state. Perfect. Now let's make some use of it. Handle new unit state, and this will be movement. Gonna copy this. When this finishes or is goes to success, we will go back to idle. And now here whenever we want to go somewhere to the go to the resource, again will be handle new unit state, and this new unit state, on success we will set the actor looking towards it and, well, start mining, right? So here I will add my mining behavior, mining, just like this. Mining, delay. This means that our resource has been completely mined, so we can go back for now to the idle movement. And I'm going to delete this because it's taking too much of my space and it's not worth it just yet. Now we are handling the states, so whenever we are moving or whenever we are here's the delay. If we started moving, this delay should not trigger this part. So here I'm going to add an if statement after this delay, and I'm going to get the unit component, get the unit state, and I'm gonna ask if it is still mining. So with this added, when we press play, we will move this around. We will mine the object. I see that the animation is breaking. Let's not worry about that too much. And whenever it finishes, and it's not finishing for some reason, oh, it seems I broke everything. Whenever it finishes, this is mining. This should enter, and this. Oh, I didn't add my idle animation. Excuse me. I deleted it. Just wanted to put it here on top. Idle. Let's press play now. It finishes. Idle. That's great. Movement. I'm gonna mine again. And for some reason, let me see if this is working again. Mining, movement, and it does interrupt, and whatever it was after the delay is not being executed, which is good. Something I need to do also here is to change this delay for a retriggerable delay. So whenever this delay gets called again, it will reset the countdown. So let's just do something like this. This is working, but our animations got a little bit broken, and it's starting to get a little bit confusing on when to play each animation. But now that we have a state, we can use those states, so whenever this state changes, we change the animation with it. So let's open again the unit component, right click it, edit unit component, and whenever this state changes, we will here do a switch, and we're gonna create event dispatchers. This is a way of communicating between blueprints, so the message is sent through the initial blueprint, But the initial blueprint doesn't need to know about the other blueprint receiving the message. It's the other way around. The blueprint receiving the message, it's the one that needs to know about the sender. It's different from interfaces because in this interface, the sender, that it's this class, the player controller, needs to know about the other blueprints that will receive this message. So in our case, blueprint component, let's create an event dispatcher. And this will be called on idle or on enter idle, on enter movement, and on enter mining. We're gonna call these dispatchers here, call idle, call enter movement, and call enter mining. I have called it enter idle just in case I need to add on leaving idle, something like that. Just in case. But for now, if you just call it on idle or on movement or on mining, it should be fine. Compile and save it. And how are we going to use this event dispatcher? Well, in our worker, we already here have the unit component, and we can right click it, add event, and we will find these events because they are being dispatched by, well, the unit component. So whenever we enter idle, I want to play the idle animation. So here, where is my idle animation? Let's copy this. Something like this. Also, right click on enter movement and right click on enter mining. We will copy this and just change it to move forward, this one, and this one to mining. Now every time our unit changes its state, it will change the animation. I'm handling the animation this way because using an animation blueprint for a lot of this type of small units may be overkill. And where's my mining attack? Here it is. No, it was this one. It was the montage. Just think it could be the other one. Doesn't really matter for now. We're not using a complex animation graph. Because as I was saying, it could be overkill to be ticking all the animations inside an animation blueprint. Let's save, compile, and we can now remove every play animation here in our code. So move to this location. Let's just remove this. Here, play this animation. I will, with Control and drag, I can move every node to my new node. And the same for the gather this resource. We are changing to the new state movement. Here, mining, play animation shouldn't be used. And after this is done, handle new animation, idle should change it to our idle animation. So let's press play. Well, compile, save it, and now press play. Right now I'm in idle. I'm moving around. It's in movement. I'm going to mine, and it should change to mining. It stop, it go to idle. We can move again. We can mine again, and it will do nothing if we have already gotten that resource. So if it's not doing anything, then I should set it up to idle again. Here I'm checking this, so this is the flow of execution if we can mine, but if we don't, then we can set the new state to idle. Let's press play. And if we cancel the mining, let's say we move it, then the mining didn't happen, and we can try to mine again. After 2 seconds, it should stay like this. If I try to mine again, I go to idle. Yeah, pretty good. And if you don't want to experience this weird rotation, maybe we could tweak some stuff here, but for now it is working good enough for me. And any animations bug that we have has been solved. Our animation is solved, but we still need to get the gold, right? So here in the event gather this resource, we are moving to the resource, and we should really break it up a little bit. Something like this. And let's select this part, move to the resource and look to it. Well, look towards it. This is the part of the code that does exactly this. This will start mining the resource. This part in specific. This part gets the resource after waiting some time. So here, start gathering the resource. And here should be getting the resource. Now, immediately after getting the resource, automatically my worker should go to my town center, well, town hall, to deposit the resource, right? So we need to know where this town hall is. The placement of most of the important buildings, like especially the starting building of each player, should be stored somewhere that the player can find it easily. And because this is something that the game will revolve towards, for example, if your town hall gets destroyed, then you should lose, or if the enemy's town hall gets destroyed, you should win, then it's something that will affect the state of the game. And if it's affecting the state of the game, then we should really put it in the game mode. So this town hall will need to save its reference to be used in the game mode. So let's open our game mode. Framework, game mode, open editor. And here I need to mention that in the case of a multiplayer game, multiplayer right now is out of the scope of this tutorial. Instead of using the game mode, we should use the game state, which is something that can be shared around, and the game mode will only check through the game state the locations of the town halls, and especially the state of the town halls, if it's destroyed or if it's working. So that's a little parenthesis. In the game mode, I need to store where my town hall is. So here I will create a variable called which is a actor type, actor object reference, and this will be town hall for now. Later on, we probably will need an array of town halls, but I need the one, just one for my player. Now, how will I fill this town hall? I could either in the game mode get all actors of class, and that way I could get the town halls, or from each, where is my town hall? Unit, where's my town hall? Oh, building and buildings should be it. Or in my town hall, here in the event graph, in the begin play, I can get the game mode, cast to my project game mode, and here set down, something like this, and put this here. This I usually would use this way of adding stuff to my game mode, but in this specific case of an RTS, when we will, well, you will probably want to change it up to a multiplayer game, I will probably prefer it here in the begin play, get all actors of class, and I am gonna convert this to an array. Gonna call it town halls and set it up just like this. The actor will be town hall, and compile and save. This way, if we have more town halls, then we will need to some way know which town hall we are using, right? So a quick way to do that, here in my Rocky level, let's say this is my player's town hall, I can add a little tag, and let's search for tags. Here I can add an element and add here player. The other ones could be enemy, and that's it. So let's just save it. I'm not really sure if I'm going to use this, but this is a quick way of adding identifier information to any actor that exists in the level. With that information, let's go back to my worker and let me close this town hall. In the worker, here I need to move to the town hall. So let's, where is my move to? Copy this, and well, copy all this so we know that we are moving. Let's replace that with our movement state. Here I'm moving. I need to know where am I moving. So I'm going to get an actor from the game mode. So let's get game mode. I'm gonna cast it to my own game mode. And from here, I'm going to, where's my game mode? In my game mode, create a function called get player town hall. So in this town hall, I'm just going to do a for each loop. And in this case, a for each loop with a break. Because if I find our player's town hall, then I would want to stop the looping. Here I'm just going to ask to get the tags, get tags, and find item. The item is player, and this needs to be exactly the same as the tag that we added here, player. And if this is something other than -1, let's get... Oh, let's save it as a... Let's save it if this is something other than -1. If different, not equal, or, well, greater than 0, greater or equal than 0 should be good enough. If this is true, then we should save it, and I'm gonna use a local variable, which is an integer and is not an array. This will be the found index. Like this, found index should be whatever it was found here. And after that, I'm going to break it, and I'm going to return here an output. I'm going to return the town halls, but I'm gonna get the specific one that I need, which is the found index. And I can just create another output like this, just drag it and drop it on top of my function and deleting the other output. So player town hall. Hopefully that was not too confusing. We are just iterating through each of these town halls that we could have gotten at the start of the game. And we are searching the one that has the player tag. And if it is found, it means that this value will not be -1. So if it's greater than 0 or equal, it will be the index that we will use to get the specific town hall that I need. And with this, I can close my game mode. I can also close my unit component and my resource component. And in the worker, I'm going to get player town hall. And because we are only getting information, I'm going to double click this, select the function. Where's my function? Get player town hall. And I'm gonna select it as a pure function because we are not making any modifications to previous variables. We are only getting stuff and accessing information. So let's compile, save, and what the pure check does is that it makes my function be called like this. And here it will be AI move to the player town hall. And in this case, I'm going to add the stop on overlap just because maybe the acceptance radius will be too small, and I really don't know how much the acceptance radius is. Or excuse me, how much the town hall, what are their dimensions, I really don't know. So after getting there, for now I'm just going to ask it to stay in the idle mode. So compile, save it, select it, let's start mining it. It is mining, stops and goes to my town hall. Our character successfully reaches its destination. Now we need to get the gold. To get the gold, we need some place to store the gold. And this gold, I'm not gonna save it in the worker because the worker is the one giving it. I'm not going to save it in my player camera because it doesn't make sense that our camera is holding our resources. And if I change for whatever reason to another camera, I will lose it. I'm gonna add it to the player controller. Why not the game mode? Because the resources are not affecting the game state in any way. If I have 0 resources, it doesn't mean that I have lost. So why would I store it there? My player controller will be a better place. if you needed these resources to be public knowledge to other players in a multiplayer game, then you should probably use the player state, which would be a class that will be shared to another clients. In our case, player controller is just fine. So in the player controller, we should have a function to get the resources. So here, in the functions, receive resources, and I need to know which type of resource and how much. Here is the resource type and the amount. Right. I need a variable that will store the type of resources and how much. I could use two types of variables, or maybe just a variable for gold, a variable for wood, or for whatever resource that I have. To make it a lot more scalable, this just means that it will get easier to create more content on top of it. I will create a variable called, well, known as a map, and this will be player or stored resources. This will be, I'm gonna use the resource type, and I'm going to convert it here to a map. A map has two sides. One, which we are using the enumerator, will serve as a key, and the other side, which are integers, as a value. So I will drag and drop the map, and we will use, first we will ask if we already have the resource here, so should be contains. I need to ask which type of resource. Here I have gold or wood. We just need to add something like this, and let's put an branch, and we will do the easier case at the start. Which is the easier case is, well, we don't contain it. So if we don't contain this type of resource, then we just need to add. And this add will ask me, oh, which type of resource you are wanting to add. I can connect this like this, but because we are using a function, I can just right click and type. And it should be the last one here, get type. This is a local variable that we are using because it's the input variable. And amount, I'll do the same. Now, what will happen if it does contain the resource that we are searching here in this map? Then, well, we need to get the amount and add it to our resource. Whenever we are adding here, you can see that it says if something already uses the provided key, which is the resource in this case, it will be overwritten with a new value. So doing this just overwrites the current value with a new one, but we don't want to overwrite the amount, we just want to add to it. So here I'm going to get, or well, let's find, and this find will find the value associated with the provided key. Which is the key? Is the type, the resource type. So I'm going to add it here. This find should always be true because I'm already checking if the key is contained inside this map. So with this, I can add the current value, and this is multiply. Let's add the current value with this value. And with this, we are effectively getting the gold. And if we added any other type of resources, then it will be easier to maintain. And we really don't need to change anything of this function. This will work regardless of how many type of resources we will have. Let's check if it is working. After everything, let's just create a sequence here pretty quickly. And I want to know the value, find the value of the resource. Should give me, I believe it was 10 or 20, don't remember. So let's just click here. And now, nothing happened. Oh, that's great. Oh, and that's because in our worker, we have not tell it to do anything. So again, in my player controller, we will set the unit to idle, and here let's just cast to my player controller, and here add or receive resources. The type will be the resource being carried, and the amount will also be this one. By receiving this, we're effectively getting rid of any resource being carried. So I will reset it back to none and here to 0. Compile, save it, and this should be attached like this to my player controller because it's a function inside it. Let's press play, and now let's see if it's working. And we got the gold, 5 gold. In these types of games, whenever you get the resource, then you should go back to mining that resource. And that's what we're going to do. Now, here, we'll see that we have not... we need to play this again, right? Event gather this resource. And again, amount of resources. Here we will just ask it again. And we need to call this, it's a very long graph. Event gather this resource. We can call it like this. Gather this resource. And because we are in the same blueprint that has implemented this event, this type of node will work, and we don't need to pass the reference. But this node is essentially the same as doing this. Self, and here, gather this resource, and no, this was not it. Gather, this wasn't it also. Let's just content sensitive, gather this resource. Add the message, here it is. It's the same as doing this. We are just using this type of node with this weird color. I know I got scared the first time I saw a node like this, but it's the same as just calling the self and sending the message this way. This just happened because we already have implemented the interface in the same class. So here, at the end of this, we are gathering the resource, and we also need the resource reference. So again, we will get it from here. This is my resource reference. Yes, it is. And we are going to put something like this. If I wanted to get rid of this type of nodes, which can get really long, I would probably make each of these steps its own custom event, which doesn't seem like a bad idea, actually. Let me move these animations here at the right. Yeah, that's fine. And yeah, I'll clean this up later. I don't want to make the tutorial last a lot just because I'm cleaning some stuff up. Gather this resource after we receive the resource. So let's press play. This should give me 5 gold and go back to it again. And now I should have 10, and oh, it is working. I was a little bit scared that it wasn't going to work, but it is. Now it needs to end some way, and that's when this gold pile stops having resources. We need to check here before we are gathering again the resource. We need to check if we can repeat the action again. Okay, so whenever, where is our getting the resource? Whenever we get the resource, not only are we getting the resource in this how should I call it, in this actor, but we are also taking that resource from my blueprint, our resource blueprint, which it's being driven by this component. So let's open this resource component, and instead of just getting the the number of resources to give and the type of resource, let's create a function. This function will be called give resource, and we only need outputs. This output will be the type of resource it is given and the number of resources it has to give. So something like this and something like that. Let's just delete that. And whenever we give these resources, we also need to reduce the times it can be mined. So here, times it can be mined, I'm gonna put it like this set, and it will be times it can be mined minus 1. I'm not gonna check if this number is 0 or negative number, because this should be checked someplace else. And compile, save it. We're also going to create exactly that functionality to check if we can mine this resource. So this function will be called can this resource be mined. And before I forget, I don't remember if I explained this, we're using functions and not events. They're mostly the same, but the thing about function is that they will run immediately after they are called. I will be sure that whenever I call a function, everything inside it will be executed in that same frame. The event does not have that guarantee, because inside an event, the benefits I get is that I can add a delay. So this, if I this event is called, then it will wait some time. So this means that the functionality inside it not necessarily will be run in the same frame. So that's why I'm using functions. Whenever I'm just changing values, I do want them to change the exact same frame that I'm calling it. So in this one, I just want to know the output should be a return value, a boolean value, and here I will check if the number of resources, no, the times it can be mined is greater than 0, then for sure it can be mined. And again, this function, I'm gonna put it as a pure function. Compile it, save it. In the worker, now I need to check. Before I start gathering this resource, I also need to check not only if the resource is the same type or not, but if the resource can be mined or not. So if it cannot be mined, then I don't get anything by mining it. So here I will ask, can this resource be mined? And if this is true and this is true also, then it will start the mining process. So I will add an AND. So both of these values need to be true for this condition to also be truth. And also we are going to add this, can this resource be mined, whenever we want to gather this resource again. So when we try to gather this resource again, I will ask, but first, can the resource be mined? And this should be from the component class, just like this. This component class. And if it can be mined, then it will gather the resource. So for a really quick test, I'm gonna select this resource, gonna select its resource component. This one is gold, times it can be mined. I'm gonna put just 2. And what happened with the 2? 2, and here I will put 10. Now let's press play. Make it mine the resource. It mined it. It will give it to me. 10, perfect. Again, it will mine it. It will give it to me. 20. And this resource should be 0. 30, and seems that it's not working. Worker, and we can see what part of the execution is working if we just select the worker. Well, you just need to here press Shift F1 so your mouse is released, and in the blueprint worker, just select here blueprint worker, and we will see which part of the execution where we are in. And let's just add a breakpoint so we know what's happening. Maybe I'm not reducing the times a resource can be mined. This is true. Let's double click to check if whenever I'm giving the resource, the times it can be mined. I'm also going to check this. Oh, and I'm not using this give resource. Now that I remember. Receive. Yeah, we're not using it, so that's why it wasn't working. I was getting scared. From the component here, the resource component, instead of getting the values like this, I'm gonna give the resource. And this give resource will be type and the number. Just by calling this, we are getting the same information, right? But we are also adding a code specific to the resource, which is reducing the times it can be mined. Now we should be able, and let me just delete those breakpoints. This should be working. And that was a small overlook that it happened. Then this is a second time. This should go to 0, 20, and it stops. Ooh, excellent. This is a golden opportunity to again take a break. This is a very long tutorial. It definitely is longer than what I anticipated, but let's review what we have done since the last break. We have selected a unit, we can send it movement, and also now we can send it the action to mine some stuff. After mining it, we are telling it to deposit it in our town hall, where we will store the resources. But the value of those resources are being stored in our player controller. Also, we have added states to our unit, so it is a lot easier to manage the animation that any of our units could have. And well, we are getting the gold, and now there will probably be a part where we will touch a little bit of the user interface just to know how much gold do we have. Hopefully you have taken a little break, have gotten out of your seat, take a little walk, breathe some fresh air. I for sure know that I will do it. And let's come back with more energy. Now it will be a good idea to create a simple HUD so we can know how much gold do we have. Let's create our HUD class. Here in the core, we can use either player or framework. In my case, I consider the HUD very tied to the player, so let's just create here blueprint class and find the HUD class. This will be my blueprint HUD. Let's open it, and we need to use this HUD. Let's go to our project settings, and in maps and modes we will find the default game mode, and in the default game mode we can change the HUD class. Now we need to show some kind of HUD, so let's create also the widget blueprint that will be used by the HUD. So here, right click, user interface, widget blueprint. Here we can just choose user widget. These widgets are the main form that we can create easily user interface inside Unreal Engine. So I'm just gonna call it WBP from widget blueprint. Now inside it, I need to show something. I want it to cover all my screen, so I'm gonna drag a canvas panel. Now we have these canvas panels that can be changed in the dimension that I need, and this is fine. It will scale properly later. I want to show the gold maybe at this side. Let me press play and see which side could I put it. Yeah, in this corner could be fine. So let's, for now, just add a horizontal box here. And inside it, I will drag a image and a text. You will see that my horizontal box is organizing the elements inside it, so they keep this horizontal type of alignment. Every single part of these elements are also called widgets, so we can put widgets inside widgets. Now, this is how we can easily create an interface, and for now, here in the horizontal box, I'm gonna make it size to content. I also want to align this content to this part of the screen. So what I'm going to do is here in the anchors, I'm gonna select this one, but before I click, I'm gonna hold Shift and Ctrl. There we go. Now I'm gonna move this a little bit in X and a little bit in Y. And I'm gonna use -Y so it comes a little bit higher. Let's press play, and I'm not seeing it. So in order for me to see what I just created, let's go to the blueprint HUD. In the event graph of this blueprint HUD, in the begin play, I'm going to create that widget. This widget will be my HUD, and I'm going to save a variable to it so later I can access it. This will be the widget reference, and let's call it HUD widget reference. And I'm going to add this widget to the viewport so I can see it. Let's press play, and now I see this widget, and it may be too much. I'll put it at 20 and this at also 20. The image, I'm gonna select it here or here. I'm gonna add some padding to it, maybe 10 all around. And in the text, I'm going to center align vertically, and this should be a number. I'm going to replace this by a gold image, and I'm gonna search the web. I will use Icon Finder, which is a website that lets you search for free stuff and also with all types of licenses. So here commercial use could be fine. Be sure to check how do you need to use that license. And this one could be, or maybe this one, yeah. There are no more sizes. This size is okay, it's a little image. So let's download it. Let's search for it. Let's call it gold. And I'm gonna drag it and go to my content drawer. And I can't do that because I didn't have my content drawer open. Now I can drag it. Here in my content drawer, I should have this texture, and I need to move this to here in my RTS. Let's create a new folder called UI, new folder called HUD, and inside it I will put that texture. And let's rename it to T-gold. I will use this texture here in the brush of the image, and this one should be gold. There it is. I'm going to press play, and there I have my gold with, well, the text on it. Now that we have the HUD working, we do need to update these values with the resources that we will have. Because here it shows 20, but it's not giving me anything. Here in the HUD, let's compile and save it. I need this number to be a variable, and I'm gonna call it text block gold amount. And in the graph of this widget editor, because every widget editor has two sides, the designer where we have created the HUD that we need, and also the graph where we can add some functionality. Here, functions, I'm going to add a new function and update resource value. I need to know the new, well, the type of resource type, and also the amount. And the amount should be an integer. So type and amount. With this function, what I want to do is, well, get this text block and set the text. If for whatever reason we need more text blocks, we can decide which one to use with this enumerator. I'm going to plan for the future, and here I'm just going to select. And with this type of select, I can choose a wildcard. Here the wildcard will be type. And now you know, if you need more text blocks, then you can use this. Now I need to change the text. So what I'm gonna do is connect this like that, the text, and here I'm gonna make it so it's always showing 2 digits, like this. Now I need to use this update resource value. I'm gonna save this, and the HUD will be my main way of interacting with this widget. Because I have this variable saved here in my player, and I won't need this part anymore. In my player controller, I can add here or here the update to the widget. But what I'm going to do is, because I really don't care if I'm adding or overwriting or whatever I'm doing here, I don't care if we didn't have the resource or not. So I'm gonna use this sequence to, instead of printing, what I'm gonna do is get my player controller. Oh, I'm in a player controller. Get the HUD. And this works because I'm in the player controller. And with the HUD, I'm gonna cast it to my blueprint HUD. Now let me remove this and this. Let's connect the sequence. And in my blueprint HUD, I know I have the reference. And from this reference, I can update the resource value. And let me organize this a little bit. So which type of resource? Well, I have it right here. This type. Which is the amount? I had it also right here. Now let's compile, save, play it. Let's click on my worker. I have 0 gold. It's mining it. It's going to my town hall, and then I receive the 20 gold that this gold is giving me. Perfect. To finally finish the gathering resource functionality, what we can do is check for any unwanted behavior. And one that I tested a few minutes ago was whenever I interrupted that movement. This means that I already have the resource, so I won't mine it, but it's still stuck there. I'm not gathering, and also nothing else is happening. So we need to solve it, and there are two steps to this solution. One, when we click the resource again, and we don't need to mine it, or well, to gather it, we should go to our town hall. And also, if I just click on the town hall, then we should also deposit it. So let's go with the easier fix. We will go to our worker. We don't need the HUD anymore. We also don't need the resource. And here in my HUD, here at the start, we had getting the resource. And this happens whenever I want to try to mine it. So if I'm not mining it, here it says that we shouldn't do anything, right? And even before it, this is the branch that is not letting me mine. So here I should ask if, and I'm gonna ask it here, if I don't have any resource, or yeah, the question should be if the resource being carried is equal to the resource I will mine, then I should go back to the town hall and deposit my resource. So here I will do it like this type of resource. If these are both equals, and let me make sure that the amount of resources is more than 0. So greater than 0. If both of these events are true, then we should not go to idle, but instead go to the town hall. And I will put false here because if those are not, if any of these declarations fails, then we should just stay in idle. So what should I do in order for me to return to the town hall? Well, I could skip a few of the steps. For example, here is when I'm telling it I'm getting the resource here, and here I'm telling it that this unit will move. We should move here, and when this is a success, then we will go to receive resources. So yeah, what I'm going to do here is I'm going to make this into another event, and whenever this event finishes, we should receive the resources and everything that goes with it. So everything from this point forwards will be something that I can call here. So we will just select everything. And can I make it another event here? I can collapse to a function, but I don't need a function. Otherwise, I won't be able to use this AI move to, because these have the icon of a clock, which means that this will not end running. It won't end the execution in the same frame that it is called. Like we were saying, the difference between events and functions. So let's see what I need. I need a resource component object reference and also the actor object reference. And I believe I can get that resource from the actor. Yeah, that's true. So what I'm gonna do is create an event. Here, custom event. This custom event will be the name of whatever I'm doing here. So for now, this will be get move go to town hall and deposit resource. I need as an input an actor. And this will be the resource reference, right? Yeah, resource reference. Perfect. So I'm just going to connect this to here. And here I will call go to town hall and deposit the resource. I need and let me compile so this is updated. There's an error because this name is not equal to this one. So let's right click and refresh this node. Now I do have it. And as a source resource reference, it was this one, actor object reference. So I'm gonna connect it like this. I'm gonna move everything a little bit to the right for now. And I'm gonna replace this. Was it this actor reference? Yes, it was. And this resource component I can get from, I'm gonna copy and paste this node, resource component, get component by class, and I'm going to replace whatever it is here, like this. Now this is self-contained in its own custom event, which is appropriately called go to town hall and deposit the resource. And I'm going to make this straight. I'm gonna straighten that, and well, this can stay the same. These two also. And here, if this is true, then I can call the go to town hall and deposit resource. This should be the actor or the component. Here is the actor, so I'm just going to double click that wire and connect it like this. Let's compile, save it, and let's see if we have solved that little problem. So I'm going to collect that resource. I'm gonna interrupt the path of my character. So right now this is not working, but if I right click, then immediately, oh, I have gathered that resource already, and then it proceeds with its logic. Now we need to fix the other way of interrupting this mechanic, which was interrupting the return path and then clicking here in the town hall. We need to go to my player controller. We can close this receive resource function. And here in the input mouse action, Let's go to here. I'm testing unit movement, but if I collide it with something, I'm assuming that we will gather the resource, but we really don't know. Here I'm checking if it's a resource. We should also check if this is a building. And just like we did with the other kinds of objects that we have, for example, we have a unit, we have a resource, we should also get, well, we should also create a unit, a building component. So here, I will go to core, building, right click, and a new blueprint class, actor component, blueprint, building component. In this building component, I will double click it, and I can define several aspects of my building. For now, that it exists is enough for me. So I will go to, I can close the worker even, or maybe just not yet. Here in my first RTS, I'm gonna check if it's a building. So if, and that's most of the checks that I'm going to do. Well, I need another one to see if I'm clicking on top of a unit, and that's it. Here I will get component by class, building, component, and if it is valid, what I need to do is interact with that building. So just like we created a gather this resource, let's double click this and create a function called interact with building. In the case of the worker should deliver the resources if it has some resources, and if it doesn't, then it should check if the building has a low health. If it does, then we should repair it, but if not, then it does nothing. It should just go to the location. So interact with this building will be a little bit more complicated, a little bit, but we do need where is the actor of the building. So here, actor, object reference, building reference, compile and save. So again, here in my player controller, exactly the same. I will copy and paste this, and here we should have something like this. If we look closer to our code, you will see that we are repeating a lot of the stuff that we are doing here. This one not so much because we have an spawn system at location, but this one, it is getting repeated a lot. Whenever we have something like this, it means that we will probably need to repeat this again. So why bother with too much code being repeated when we can encapsulate everything in one simple execution path? So whenever you have this type of repetition, most likely is the case where you can simplify your approach. For example, in my case, what I can do is this value. I know that this is being repeated every time. So if this value does implement interface, is the only thing that will be changing. Here should be building. No, it is unit action. So even here is the same thing. So is unit action. This is fine. Then we can get rid of this validation. And here we can add the check. So we can add another check here, if, and if it is this resource component, then we will put it here. And we do need to add the target, that is this element that we found. If it isn't, then let's copy and paste this, false, and let me move everything here down, and I just need to validate this part like this. And again, building, this should be interact with building. And if I needed to add something else here, the target should be the element, this element. So let me double click this and connect it to the target. And let me just disconnect everything, connect the target, and connect the building reference, which will be the object that we found in these overlap actors. And now if we need to add something else, we will add it here. We don't need to copy and paste too much code. So this part of the code we can get rid of. And it will look a lot cleaner, because we were repeating this part also, and we just needed to check these values. Now this doesn't look so good, but I won't mind it just yet. I just need to know that this is the array element that I'm going to be using, and that array element will be used also with the reference of the object that will be found here. That looks a lot better actually. And now we would need to implement this interact with building. Let's implement the interact with the building by going to the building. First, by going to the building and adding our component, our building component. And we could define different types of building, which, yeah, we really should do that. Building here, right click, blueprints, we already know how to do this. Enumerator, building types. Open it. Let's just put none, town, all, and that's not how you spell town. And maybe a house, and the barracks. Let's save it. Pretty good. Inside the building component, I should add the type of variable. Type of building type. Compile. By default should be none. That way, here in our buildings folder, we can open the town hall and we can set up the town hall as a town hall. Save it, compile it. With this information, we can close the town hall. Here in the worker, I would need to... What do we need to do? Well, we need to implement the new action that our unit has, which is interact with building. Right-click it, implement event. We have the reference of the building, and the only thing that we will check is first get component by class. We need the building component. If this is valid, and let me check my context sensitive. I don't know how much time I didn't have it on. Is valid. You can use this, or you can just use the macro is valid. If it is valid, let me check. And first I need to know if I have resources. So if this amount of resources is greater than 0, then we need to deposit. So here I will want to deposit stuff. If it isn't, then I would want to try to fix the building, to repair it. So here I'm just going to create a reroute node just to put a comment on top of it. Here we should repair the building if needed. Whenever I leave a comment like that, it's good to add a to do. So later we can Control F and yeah, just type to do, enter, and you can search in all the blueprints to know where are your to do nodes. And well, here we will just ask if this type of building is a town hall. So type get type of building, and if this is equal to a town hall, then we can do something. If it is not equal to the town hall, then we should go to this part of the logic, which means we should repair the building even though we have resources inside our unit. So if we do have resources and we are dealing with a town hall, then we can call go to town hall and deposit resource. Now we have a little problem here, which means that we need a reference to the resource. Because we do need a reference to the resource, then what we should do whenever we start to gather a resource is get a reference to it and save that reference. So this is what we are going to do now. Here, gonna right click it, and before saving the reference we should move to the resource, look to it, and see if we will gather the resource. So after we decide that we will gather the resource, then we will save it. Yeah, and that should be good. But let's think this logically. If I press play and compile and play our game, is it logical for our game that whenever I interrupted the path, I want it to go back to the resource, or just give me the resource and stay there. That would probably make sense, which it's something that it just happened here, and there will probably be some errors because I didn't have the there it goes. I send a null reference here. So maybe going to town and depositing the resource shouldn't need the resource reference. So maybe I could just, after doing all this, making this last part another part of the code, because nothing in here needs the reference to the resource. So what I'm going to do is move this part of the code to another function. So what am I going to do with this? Because I really don't like saving references that later on I won't use, and in this case it doesn't make much sense to me if I just click and interrupt the flow of execution like this, and then make it so that, oh, you deposit this, then I should immediately go back and mine the previous resource. Yeah, I don't remember games doing it, that functionality like that. So what I'm gonna do is this, I'm gonna move it like that, and I'm gonna make a custom event here. Custom event. This will be repeat the mining action. This does need an actor, so let me put it here, and I need to put this event so this part can work. This is the resource reference. I'm gonna make it a little bit more readable. Great. Repeat the mining action. And this repeating the mining action should be after going to town hall and deposit the resource, because we do want that to happen when we are gathering the resource. So I'm gonna put it here. Repeat the mining action. And again, we didn't compile this, so when I compile it, this will show an error. Just refresh it. And we will exchange this node by pressing Ctrl, drag and drop in here. And going to town hall and depositing the resource, we really don't need it. Oh, but here's a little issue. Here's a little issue with that approach, is that this happens only on success. Well, this should happen only on success, so repeating the mining action should be here. So how can we fix that part? And let me organize this part. Well, I guess it could be simple. We could just send the resource reference through here. Yeah, let's just validate this. So if this resource reference is valid, then it means that we can repeat this mining action. And let's return this to the go to town hall and deposit the resource. I didn't realize that this repeating action happens only when we reach the town hall. So here, let me put it at the end. And if this resource is valid, then we should repeat the mining action. Now, that should fix the problem. And give us the functionality that we need. So let's press play. I'm going to right click on the resource. It will mine it. It will try to deposit it. Now let's click on the town hall. It will deposit it. And because the resource value is not valid, because here I'm sending it without any data, then now, whoops, because we have validated it, we won't get any error. And these errors are from the other compilation, so don't worry about that. And our mining functionality or gathering resource functionality is finally done. Excellent. We got this worker working, so it's a good idea to make sure that whenever this resource is exhausted, we stop seeing it, because otherwise we will see that our worker just is not working. So for example, this resource, if we click it, we should go to the resource component. We can see how many times it can be mined. Let's just put it one time. And with that, this resource can only be mined once. So let's press play. Let's mine it once. The worker should return to the base, and then it should stop there, because this resource has been exhausted. Now, it should be a good idea to stop showing this mesh. So let's open the gold. We can just right click it, edit gold. And here, we will add some code so we can stop showing this mesh. The component is the one that knows when this resource has been depleted. So I'll open this component. And here we have this give resource. And also we can ask if this resource can be mined. Now, here we could know whenever this resource is exhausted. So we're going to create an event dispatcher. And this will be called on resource exhaustion or exhausted. And we are just going to call it here, call, like that. Now it will be up to the actor that will be using the component, in this case, this actor. This component, I can right click it, add event, and here it is, the add on resource exhausted. Now here, maybe I can destroy this actor, maybe I can just hide the mesh. We could do whatever we needed to. But we do need to keep in mind that this resource on resource exhausted, let's go back to the component, it's being called every time I'm giving the resource. And it should only be called whenever this times it can be mined is 0. So I'm going to create another event dispatcher on resource mined or gathered. This should be here, like this. Here I'm going to create a sequence because I want to determine if this resource can be mined. Then, well, nothing should happen, but if it is false, so let's just negate this with a not boolean. If this is false, well, excuse me, if this resource cannot be mined, it means this resource has been exhausted. And I will put this here, and I'm going to create a sequence so everything stays very tidy, like this. Let's save it. And now I can also use this. Where is my resource component? And let's also use the... Oh, I didn't compile this, so I don't have the access to the resource gathered. Now I should have it on resource gathered. So whenever I exhaust this resource, then for now I'm just going to destroy it. And let's try it. Save it, play it. I'll pick it up. As soon as that resource is finished, then it is destroyed. If we needed to refill that resource or make it appear again, then we should not destroy it, we should just hide it. And every time the resource gathered, I wanted to add an effect. The effect that I will add is like a little icon on top of the head of the worker. So for that, I'm going to create a blueprint here in core, unit, and maybe inside of resources it would be a better idea. Let's create a blueprint class, an actor, because it's something that will pop up in the map. Blueprint resource gathered indicator, and inside it, it will be a simple, let's just add a static mesh. This static mesh will be set up whenever I gather any type of resource. So I need to make this a variable, and I'm going to set it up in the construction script. Here in the construction script, I'll drag and drop this static mesh that I should probably call resource mesh. It would be a good idea maybe if it's an icon or something like that. For now, I will use a mesh. We can later change this blueprint and everything will change with it. This resource mesh, let's set up the static mesh. And I will make this a variable. And this one will be instance editable and exposed on spawn. So we can change it whenever we spawn this class. By default, let's just use the gold bar. Here it is. It shouldn't have any collision, so let's remove the collision. We also don't want it to have too complicated behavior. And because this is an RTS, we need to optimize whenever it's possible. So here in the class settings, in the class defaults, I will disable the tick, because this blueprint, it's not going to use it. Now, where's my gold? Did I lost it? Oh, the gold is not showing because even though this mesh has it set up in the construction script, we are using this other mesh. So let's change here to the gold, and now it should pop up again in my viewport. In the event graph, we only want it to play a little timeline. This timeline is the upwards animation. And this upward animation will be... We could set up a timeline here. Let's just put it 1, length, float track. This will be the C value. alpha, and it will go from 0 to 1. And I'm shift clicking here, so it's easier for me to add keys. 0, 0, and here 1, and the value 1. That's good enough for me. We can close it. We will have this value, and we want to change this resource mesh in the local, well, in the relative space. So set relative location. The new location should be, let's just split this, and here should be the C value. We could just connect it here, but we are only going to go from the value 0 to the value 1. So we should create a variable here to set up the maximum distance to go upwards. So upward distance. This should be a float. And maybe max upward distance. And this will be, let's try with 150. So now we can multiply this value with this upward distance. Let's compile and save it. If we just drag and drop it here in my map, it's good that it is small, so it can fit directly in the head. And also let's simulate this. And it is going upwards. Whenever it's going upwards, when it's finished, let's just destroy it. And right now I'm using a lot of creation and destroying. That's also another category that we could improve upon, but we're just trying to get this beginner tutorial finished. Now with this, save it, compile it. It was going maybe too slow, and we can change this by getting here in the components the upwards animation timeline, and we're gonna set up the play rate. We could create a variable, but we probably will use this same value for all, and I want it 1.7. Compile it, save it, and let's just test it. And yeah, it's a lot faster. I like it a lot. We can now start to use it. Here in the gold, whenever our resource is gathered, we are gonna spawn the blueprint, the actor. And now let's use our blueprint resource gather indicator. By default is the gold one. We will leave it at that. The spawn transformation, we should be able to attach it to the actor that mined the gold. So let's go back to the resource component. Here, can I now give resource? I don't believe that this will give me the information. So because I don't have clear access to the worker, I'll just spawn it on top of this mine. So here, gold, just get actor location, split it and spawn, compile, save it, and let's try it. I'll remove this one. I'll press play, and I do want to play the game, not just simulate it. Click on it. This should mine it, and the gold should appear like that. Yeah, and probably I want to add some C value here. Maybe 200. Because if this blueprint doesn't get destroyed, I'm gonna set it up to be mined 2 times. Going to press play. Then we won't be able to see that little indicator. There you go. Before continuing the tutorial, it will be a good idea to make this town a little bit more presentable. So let's fix some other buildings. Let's go to the content drawer, static mesh. Let's again turn on our filter and let's see what can be helpful to us. So maybe these two things could be helpful. And that one is really small. Which other stuff could be helpful? Definitely these two buildings. And we will know that the materials are broken. So we have to fix them. And also, these are some base of towers that we could use just to make a little bit of variety while making this town. Let's fix these materials. Ctrl D, we can open the static mesh editor. In the material here, probably there should be something called brewery. If that isn't the name, then here TD maybe could give us a name. TD brewery add. And it's still broken. No surprise there. Let's double click it. In the parent should probably be the brewery. Oh, here it is. And in the mask, I'm going to change it to, there should be here, TD, brewery, E1. Let's save it. Let's see if it's working now. Yeah, it seems to be working. Let's open the other one. And here, let's use the same material. Should be here. This one. And it's looking different, so it is working. Let's save this. We can close this material now. Save this. And here we have more buildings, right? I have to take in account that these buildings are open in the back side, and for some reason, in some angles, it stopped showing. But doesn't matter because my game will probably just be from looking from one angle, which is this one. So the scale here should be a little bit bigger. So let's scale it by 2. And let's see if it's working. Yeah, it looks a lot better actually. Now, this blueprint was our house. But it's looking like our town hall. So let's just replace the mesh. I'm opening it, and here in the viewport, let's change the town mesh. Let's just call it house mesh. This one, let's change it with the brewery. Let's see which one looks more like a house. Maybe not this one, or maybe, yeah, but why not? Let's make it look to the x-axis so we know that it's facing the front, and translate it to the center. Like this. And we could also open the top view and move it like this. Let's go back to the perspective, compile and save it, and our house should be looking like this. Let's scale it. And the scale probably will mess with the... Yes, of course it does. In order to avoid that type of issue, we can just create here a scene component. And the scene should be not attached to the house. So let's reset the location. We will attach the house to the scene. And now this scene, oh, the scale, let's just return it to 1. House mesh should also be 1. And of course this mess up with my, let's just reset the scale in every part here. 1, 1, perfect. And the scene is at 0, 0. Now it is. Okay, now that the scene is in 0, 0, scale 1, the mesh also, the house mesh is also in scale 1. We attach the house mesh to the scene and we can scale the scene without issues. It works like a new pivot. Let's compile and save it. Now we have the house. With the house working, let's also add this one. To avoid any necessary duplicate work, let's just remove the filter. Let's go back to the buildings and let's duplicate the house. Let's just call it, this will be the barrack or the training center. Training center. And inside it, I'll just replace the mesh. And this will be the training center mesh. And we will use the other asset. And of course, it's looking to the other side. What surprise! So let's go to the top view and just move it around. There should be good. Compile it, save it. Let's just drag and drop it. And we have it here. Should be fine. Let's press play. And yeah, it's definitely good. With these two buildings, what we're going to do is create a little town so this guy is not walking around aimlessly. We have the houses and these training centers that I don't really know what they will do but for now, but let's just use them. I'm gonna delete everything that I don't need, and I deleted all the other stuff that I dragged to the map. So here I will put my houses, usually with the, in any RTS probably you will have some kind of grid, so whenever you place a house side by side you will have something like this. And we can select the 4 of them and just put them like that. There, I'm gonna put this here just to break a little bit of the pattern. And my armory should probably be a little bit bigger, so let's open it. Here in the scene, I will put it in 2.5, so it's a little bit larger. Let's save it, and here we have it. It's a little bit different than the other one. I'm going to put these buildings like this. I'm going to put a lot of gold in this zone, and if our blueprint is floating, we can just use the end key so it snaps to our map. And we really don't need for them to align exactly, so we can just move them like this. And let's just, oops, I deleted it. Let's just press end on all of them so they are in the map. Like this. And let's fix a little bit of the terrain. Let's go to the landscape. Let's go to paint. and select our rocky ground. Probably our rocky ground will be near our houses. I should probably reduce the brush size here. Something like this. And if we open an entrance somewhere, could be here. And maybe a road that way. Now we need some blending here, so it is not that noticeable that our materials are tiling. So let's grab the smooth and smooth it out. And here I could easily notice that this is tiling, so let's just smooth that part a little bit more. Something like this. And I would like a little more of this rock. Surrounding the houses. And let's smooth it. Now, doesn't look like a town because nothing is blocking the paths or nothing is limiting the frontiers or, well, the borders of the town. Let's go and find some rocks that we can use here. I had a rock that we can scale and maybe use it later, but the content that we imported, let's find these static meshes, had also combined rocks and, well, two types of combined rocks actually. I'm going to use this one and maybe this one if I was gonna say if it was closed on the outside, but it isn't, so let's not use that one. Let's use this one. This one, let's Control E to open it in the static mesh editor and change the material with the one that we already fixed here with this rock. Let's just search it in the content drawer and use it here. Should be working fine. Let's save it. In my rocky level, I can use this. I'll scale it a little bit. And let's scale it just by 1.3. Should be good. Let's have something like this. If we needed more of this asset, we could just also scale it the other way and rotate it a little bit. But no, it's not going to work that well with that. I want to have a little wall here, and I will do that with this asset, this rock asset that we drag and drop at the start of the tutorial. Just remember that it's also not closed, so make sure that every part that is not closed is facing that way, so our camera won't be able to see it. And for now, let's just duplicate it this way. This way. And now we can add some variation. For example, here, just scale it a little bit. Some rotation. Something like that. And to hide this part, we're gonna add a mountain here and be done with it. So let's save everything, just in case this crashes for some reason or another. Landscape mode, let's go to sculpt. Sculpt, tool strength is fine, brush size should be a little bit bigger, and let's just create some type of mountain here. I'm gonna smooth it, and I'm gonna add it some erosion, just so it looks a little bit more rough. I'm gonna paint it to the rocks, and let me see the tool strength, rocks, and I'm smoothing, so let's paint. So now it is being painted. Now with that, if we want to make it match, we can alter the material in this landscape. We can find the landscape here. Well, if we double click, this is the material instance, but we need to go to the parent, which is here. Double click it. I'll keep this instance here. And this is the rock tiling. I just want to add some color to it, so let's multiply it by a color. The color is just a vector of 3 components, and let's just call it, convert it to parameter, rock color modifier. Let's save it. This will apply it. And in my rocky level, you'll see that everything is a little more black. By selecting this part of the terrain, we can play around the color. And I will make it match one of these. And yeah, this color could be fine. Yeah, that's alright. Let's save it. And there we have our little town, where we will start adding more of these guys. Now it's a good time to take another break. Let's stretch our legs, take a walk, drink some water, and review what we have done thus far. We have shown the amount of money that we have in the HUD. We have updated that variable with the goal that our worker gives us. We have polished the gathering mechanic of the worker. So whenever we interrupt it, for example, now that it has gathered it, we interrupt it by just telling it to go another place. We can return to our town hall to deliver it, and then we can assign it another task. Also, we have shown, well, we have made a way to represent that the resource has been emptied and that it has been gathered. Here, whenever we gather it, we see a little indicator popped up. And we have created a little town that could represent our base if we had the ability to build it. After coming back energized from the break, what we're going to do now is create a way of selecting multiple units. In any RTS game, you will probably start with more than one worker. I believe in StarCraft it was like 5. So you need a way to select them. And also you will find that we have a little bug where we are not deselecting these actors. But we really need to drag and drop our mouse and create a little marquee here. So anything inside it will be part of our selection. To do that, I will create a blueprint. And let me end the play mode. Let's create a blueprint. Let's go to our project folder. Let's go to core, let's go to player, because it's something very, very important in our game. And it has to do with the player, so let's put it in this folder. Let's create another actor, and let's call it blueprint selection. Or maybe unit selection Marquee. Let's open it, and we are going to use a box collision. Let's add a box collision here. Yeah, and that's for now pretty much it. We need a way to determine where do we want this selection marquee. So let's go to our content drawer again. All my selection was being done through my first RTS player controller. So let's open that. And here we should have mouse action, which is the right click, and mouse selection, which I believe it was the click. So let's try it. Don't really remember. So hello. Here we have, well, we could have, and I know I just deleted that, but we can have the click and the release. So whenever this is being clicked, I can move my selection marquee. And whenever I release it, I just move my collision box out of the way. So let's do that. We need to create this blueprint, and we only need one. So whenever we start the game, let's go to the begin play here. I'm gonna create a blueprint. Spawn actor. That actor will be my selection marquee. And also the spawn transform really doesn't matter. I didn't want to create a variable, excuse me, I just wanted to split the struct. It doesn't matter the location or the scale, because we're gonna modify that with our mouse clicks. We only need to save a reference to this actor so we can modify it later. With this reference, then we can go back to our mouse selection, and whenever we click it, we want this unit selection marquee to be in this place. So I can delete that, and this selection marquee, I'm gonna set actor location, connect it like this, and the location that I will want is the get hit result under cursor channel. Visibility is fine. Let's just break this. If I split it, it will be too long, so I'm just going to break it. Location, and again I'm gonna return it that way so it doesn't occupy that much space. And to see if this is working, let's compile, save it. Let's just add here a mesh for now. A sphere will be fine. Let's press play. I'm gonna click, and whenever I click, that blueprint moves around. With this first step, we can easily know where is the starting point. I need to determine the end point now. So whenever I click and drag, I know where the marquee should be. So I'm going to, well, first get rid of my sphere, or yeah, let's get rid of that sphere. I need a way here in my blueprint to change the location of the end point. Now, if I go to my input action, I do not have the location of my mouse I only know when this has been pressed and this has been released. Nothing else. So I'm in a bit of a pickle because I need to update the size of that marquee not every frame, but almost every frame. So I need to use my tick, which I don't normally use that much. And here in the tick, I will have I'll add again the sphere. And this sphere, just so I know that it is working correctly, set world location. And in order for me to get the mouse location, I need to get the player controller. I need to cast it to my player controller. And here I will set, get hit under the result, get hit result under cursor for channel. With that, again, going to break this. And the new location is this location. Let's press play. And right now, because my sphere has collision and I should really remove the collision. Where is it? No collision. And I'm going to add another sphere. Just as I said that, we should delete that sphere. I'll add it again. We should now have a sphere that stays at the starting point and a sphere that follows my mouse. So this one is the sphere that is always following my mouse, and whenever I click and drag, I have my starting point sphere. Now, we should only use this part of the code if we are resizing this marquee. So I need a variable called should resize marquee. And I'll add a conditional. And if this is true, that. Compile and save it. And what my first RTS player controller here, what we should do is, you press this selection marquee, let's make it resize. So I'm going to create a function. I really don't like getting the variables from the reference like this, like set should, and setting it up like that. So I prefer a function handle set start resizing marquee. Duplicate it. First, if we are starting to resize, should be true. We'll duplicate this and end. And this should be false. With that, in my player controller, I can set the actor of set the actor location of my blueprint, and here start resizing. And whenever I release it, I should end resizing or stop resizing, whatever makes more sense for you guys. So compile, save, play. In the unique selection, this value should start at false. Compile and save. Now I click, it should be resized. I stop clicking, and now I know where my start and my end point is. With these two functions created, we can now start resizing this collision box, because it's this collision box that will be in charge of telling me with which units did I collide. So this collision box, let's just add an event, add component begin overlap, and I'm just going to print the actor that had the collision. Now, right now it's not working because we need to resize our location, our box collision, and that's what we are going to do now. We are going to also resize it in the tick, because, well, if you are moving your mouse around, it needs to resize. We can't escape that. So here, the box, and let me just call it box collision. We are going to set the relative location. Yeah, we could do that. Should we do this? Probably would be easier with word location. So let's use word location. So let's set word location, and because we are not gonna rotate it, then it will be really easy to handle. So let's set word location. I need this location as a variable, so this will be, because eventually I will delete this sphere. This is the end mouse location, and the start mouse location is the actor location of this. So we have these two values. If we want the location of, let me set it up like this. If we want this box collision, we need to take in account that the box collision, whenever it grows from the center. And even if you added like a scene component, it will still be growing from the center. So we just need to modify the location of this box collision. And I'm going to add another sphere for that, just so we can see it. This sphere will also be set up like this. And the start location is the get actor location. And the end mouse location is, well, the end location. If we want to get a value between these two vectors, you can just subtract, add it like this, press play, and let's see if that works. It is not working. So another way to get the middle point, because probably I'm messing up my subtraction here, is like do a lerp, and the alpha should be 0.5. If you're very comfortable with materials, lerping should probably be like really common to you. So that's an easier way. Probably I was missing some other part of that way of getting the distance between two vectors, between 2 points. But Unreal already gives us tools that we can use. So here we have where our box will exist, and I'm going to put this, I'm going to uncheck hidden in game so we can try to see it. We can see it like that. We just need to change the box extent, set box extent, and for this part I do need to get first the distance in terms of x, y, and z, and subtract it. Let's just test it for now. Let's see what happens. It is growing. I don't think it is growing at the same dimension. So let's just divide it. Let's convert this pin to float. And float again. 2. And now it's working. And we can see there in the top side of the screen whenever we are colliding with something. I do need to add first, I do need to make a vector here. Add some value to the C box stand. So here, make vector. I'm going to split this X, Y, and this will be 300. Yeah, that's more than enough. And why am I only colliding with the worker 4? Okay, so I'm resizing the marquee. We should do something more interesting. And the way we're selecting here in my player controller is something that we can add to this marquee. Let's select our units with our box collision component. Here in the box collision component, we already added the component begin overlap. What we will use here to select this actor is check first if we're implementing a certain interface. If we remember, we have a selection interface that we created like hours ago. Selection event, and I will ask here if this is true. If this is true, then we should select this actor. We should select this actor in my player controller. So what I'm going to do is open my selection interface, double click it. We have already deselect this. We will create select this. I will need an actor reference so I know which unit I'm selecting. So this will be the actor selected. This will be an actor reference. Let's compile, save it. We can close the interface. And the only thing that I need to do here in the selection marquee is call that interface. So I want to create the way to select stuff because I already have it here in the player controller. So here in the player controller, I need to, here in the unit selection marquee, let's get the player controller. And I will call select this. Which is the actor selected? It will be this one. And that's pretty much it for this part of the class. Now I just need to, here in my player controller, implement that event. Now I don't have my selection interface implemented here, so I'm going to go to the class settings, interfaces, and again, I'm in my player controller. Implemented interface, let's add selection event. Should be selection actions or something like that, but it is fine. It won't kill me. Now, interfaces, select this, let's implement the event. And I already had something called add actors to selected. Add actor selected to list. And this deselect all actors and add the selected actors to an array. And Yeah, we just need to call that. We're going to add the selected actor to the list. And we're gonna tell them that they have been selected. So after adding this here in my add actor selected to list, I'm going to select this. And well, this time I'm not gonna get to bother about this actor selection. Yeah, let's keep it clean. Okay, let's keep it clean. Let's duplicate this. Let's double click that, excuse me, duplicate this. And select this should stay like it is. And this one should be called select this actor. Should be two of them. Why? I'll explain it right now. This one is the one that I'm using here, so I'm going to change this one to select this actor and this one to select this. Gonna compile, and this one should be select actor. So whenever we choose this select actor, we have a reference to the actor, and whenever we choose select this, we shouldn't have this reference. The marquee will be updated with the select this actor. The player controller also have this select this actor. We don't want to use that. We just need to here select this. Excellent. And this will call inside the actor blueprint the indicators, so we know that it is selected. Okay, so my selection, actor selection, yeah, this event did break because this implementation had another name, so let's just remove it and implement again the select this actor. Right click it, implement event, and here we have it. Perfect. Let's see if it's working. I don't believe it will show me. Yeah, it doesn't show me anything. We need to go to the worker. Control P, and let's go to worker. And here, this should have the selection interface also. So let's create that. Class settings. We have unit actions, and we should also have select selection event. Should be selection actions. I regret naming that. But well, we can change it later. After implementing this interface, we will have these other actions. So select this implement event, and this one should be calling the event that should show the indicator. How are we doing that? Let me check in the player controller. Here we have the action, and it should be also in the worker, I believe. Mining, go to town hall, gather, enter movement. It isn't. Come on. Then it is in the unit component. I haven't looked at the actor in a long time, so that's why I'm searching for it. One reference, and let's just edit. And yeah, we have the owner clicked. So we have the show selection decal here. In the worker, we're going to change that. Select this, we're gonna get the unit component and show selection decal. Now let's see if it's working. Let's press play. And we are selecting them not exactly as we would have liked, but it is working. We're going to fix this little bug in a minute. And by minute, I meant like how much time is gonna take us to fix this. For example, this little bug only happens from the right side, and from the left side, everything is selected correctly. This is happening because the box extent is in a negative value. So here, player, let's open the unit selection because I close it. And here in the event tick, we have the set world location, and here, this value, I want the absolute value, so I always get a positive number. With this, let's press play. Should work correctly if we do it from that side or from the other side. Now we need to deselect these characters. To deselect the character, here we need to add something whenever our box collision gives us an end overlap event. Now we can just duplicate this and change it by a deselect. And this is called select this actor. Let's double click this so we can open the interface and just duplicate select this actor, Control D, and I'm gonna call it deselect this actor. Actor selected, actor deselected. Let's compile and save. We can close that, and we need to change this. Deselect this actor. We need the actor to deselect, and it will be this other actor. Pretty similar to the previous code. Now we need to do something with this new interface function. We are calling deselect this actor in the player controller, so let's open the player controller. Should be in player controller. Now we have this event select this actor. We need also the, where is my interface, deselect this actor. Implement event. And here we want to deselect the actor selected. If we remember, here in add actor selected to list, we already have a function to deselect all actors. We don't want to deselect all actors every time we select a new actor, so I'm just going to move this like that, and I'm gonna see what's happening with this deselect all actors. Here, deselect all actors just searches and runs this deselect this, and also clears the selected actors array. So I'm just gonna copy this. Gonna go back to my event deselect this actor, and before deselecting it, I want to clear it from the array. So here, I'm gonna get it. I'm gonna remove item, and this is gonna search for this specific item. If it's existing here, then, well, it will remove it. So if it is removed, it means that something was deselected. Otherwise, we don't want to deselect it because I would be deselecting it again. And in order to check if the interface selection event is being used, then I do need to do something like this. Now I can save myself an if condition, a branch condition, if I just add here an AND boolean. So in order for this to be true, both of these statements need to also be true. So let's remove this if, well, branch, and connect our and boolean there. I do need the target of the deselection, so here I'm just going to connect it to the actor deselected and move this a little bit closer. So now I remove it from our selected actor array. We check if the actor is implementing this event, and we are deselecting it. So now we need to do something with this function in my actor. This is the worker, most likely. So let's open the worker. So let's just Control P worker. And here in this worker, we already have select this, which shows the selection decal. We should also have deselect this, which should hide the selection decal. So in the unit component, edit unit component, in the event graph, we had the show selection decal. We will just copy and paste everything. This will be hide. And the visibility will be false, and the set hidden in game will be true. Compile it. We can close this now. In the worker, we should call hide. And that should be it. So let's press play. We'll select everything, and every time we stop overlapping a component, well, it gets deselected. One thing that we do need to have in consideration is that we only need to select or deselect when this marquee is active, because otherwise, whenever I click and I move my units, they get deselected. So in order to avoid that, let's go back to my unit selection marquee, and here I should check if the marquee is active. So if we should be resizing the marquee, then I will provide the deselection this way. And again, we can save ourselves a branch if we just use an AND statement and connect it like this. Let's try it now. And now that thing isn't happening anymore. Another thing that we should do is remove the marquee when it's not active. If we remember, this boolean tells us if the marquee is active or not, because whenever we are clicking and dragging, we should be resizing the marquee. And we're handling by these two functions, which we can use. So in the end resizing marquee, what I'm gonna do is here, the box collision, I'm just going to set collision enabled, no collision. If we see our collision presets, it starts with query only. So whenever we are starting the marquee resizing, we should also enable the collisions query only. That way, compile and save, we press play, we select it, and we can now click inside this marquee because it doesn't have any type of collision. Perfect. If later we add something to indicate where our marquee is existing, then we can do it easily here in the start resizing marquee or the end resizing marquee. With the marquee working correctly, we need to finalize some details. First, we need to stop showing the spheres and also the collision, because now we know that it is working correctly. So here in the spheres, I will make it not visible, or it could be, let's remove the visibility and also hide them in game, just in case we need to debug this again. This box collision, I need to stop making it visible, and we should really hide it in game. Oh, well, visibility is fine. Otherwise, we won't be able to see it here in the editor. So here, now I can select it. Select everything. But if you see, we're not deselecting whenever we are clicking at nowhere. So what we need to do is save this in your player controller. Whenever we click and drag, where is the click? Here it is, mouse selection. Before resizing the marquee, we should really get rid of all the actor. So we will call deselect all actors. So here, before resizing the marquee, and I will probably need a little bit of space, I'm gonna deselect the actors first. Perfect. If we press click, we click. If we click at nowhere, we deselect them, and every time we are going to select these actors, then it should be working. Now, the marquee is working correctly, but what is not working anymore is just clicking on the actor. So now we need to fix that. Whenever we click on the actor, let's go to the blueprint worker, and the capsule component, we should have an event on clicked. What this event should do is select specifically this character. But before that, we're gonna deselect everything and then just select that character. So here, I need, instead of just select this actor, I'm going to create only select this actor. So instead of just calling the select this actor, I'm going to open my selection event interface, and I'm gonna select only this actor. We should really duplicate this one. I'll duplicate that one. Only select this actor, and what that will do, let's first call it here. Only select this actor. Actor selected is, well, this one. So here it will be self. In the, let's save and compile. In the player controller, we need to right click, implement only select this actor. What this will do is clear everything. And I didn't want to use this event select this actor because I'm using this to clear, to add stuff to my marquee selection. But if I'm just clicking on one actor, then what I want to do is, well, just select it. So here, I'm going to deselect all actors, and then select this actor, which is what we have here So this interface function is deselecting all actors and then calling this other interface function. This way, if I need to change our way of selecting stuff, I only need to check here, because I'm executing this part and then going to, oh, I lost my break, and then going here, because this call is returning this function. So let's see how that looks. We can select, and if it's not working, then I must, here in my worker, only select this actor, player controller. Let me see if I'm missing anything. And what it seems to be happening is that the actor is getting immediately deselected. Whoops, I was just trying some stuff out there. Every time our character gets selected, then it gets immediately deselected here in this mouse selection. Here we're deselecting. So we need a way of avoiding this problem. So what I will do is create a way of knowing if we are just click selecting or just drag selecting. To do that, here, instead of this being called only select this actor, oh, this could be fine. Although it would be better if it's just called click select this actor. So yeah, let me rename that. I'm going to open my interface and let's click select this actor, compile it. I will find some errors here probably. Compile in the worker, maybe. Oh, it was fine. Here, click select this actor. So when we are click selecting the worker actor, or well, any actor, what we're going to do here in my player controller is save a variable called is click selected. So this will make this, yeah, truth, because we are definitely click selecting. Now we need to check this value. So in our mouse selection, if we are not click selecting, and again here in the relist, if we are not click selecting, then everything related to the drag select will work. And here, if we were click selecting, we just need to reset this value to false. So we are no longer click selecting. Let's compile, save, play. Click selection should be working. Drag selection should also be working. And whenever I just click select, then it should be also working. So that's very good actually. And then we later need to fix this movement issue. Now that our marquee is hidden, it is a good idea to try to show it in our HUD. So let's open our HUD. It should be in content, player, and we just need to open the widget. Before fixing it, well, before showing our selection, I just realized that this texture that we imported, there already was a coin texture that we could use. That looks a lot more like an RTS asset. So let's fix the missing functionality of the marquee, of the selection marquee that we should see here. right? So we need a border, or well, a square that we can resize whenever we click our screen. So what we will do is get an image. This image, for now, I will put this at 0, 0, size. For now, let's just leave it at 100. Here in the brush, we will draw this as a border. And in order to show the border, here in the margin, let's put 1. This should make it so we can see some border. And if you're not seeing every part of the border, then be sure that the margin is 1 in all of their sizes. And now it's not letting me, so let's do something like this. Yeah, like that. Perfect. I mean, it can also be 0.5. I believe that would be acceptable, but then I can't see the sides, so yeah, just use the sliders and put everything to 1. Perfect, we can return this to 0, 0. It won't matter, but let's just put it that way. So we need to know when our mouse is clicking, so we can resize this and reposition it. So we're just going to resize it and reposition it. This will be done here in the graph. And just like we did like an update resource value, I'm gonna close that. I'm gonna add 3 functions. One, to start updating the marquee. So start marquee update. And it will be a good idea in the designer for this image to have a unique name. Perfect. So we need the start marquee update. We also need the actual update. And a stop marquee update. When are we going to call this? Well, let's open again, because I closed it, the unit selection marquee. And we already have a start resizing marquee and resizing marquee. So at first, here in the HUD, I want to, in the designer, hide this marquee, because I don't need to see it unless I click on it on my screen. So in visibility, and let me find it, let's just put it hidden. Here it is, behavior, visibility, hidden. It's not visible but occupies layout space, so let's just use collapsed. This is not visible and does not take any space, so it won't be able to be hidden. Perfect. Now that it's collapsed, whenever I press play, I will not be able to see it. And now in the graph, whenever we start the marquee update, I want to save the start position of the mouse. So let's, here, if I put mouse, get mouse position on viewport, and let's save it to start location. Also, let's just drag this image marquee and set the visibility to visible, or better yet, not hit testable, self and all children, because the hit testable stuff is if we need to press on it, like buttons or something else, and we really don't need that, so this is just fine. Compile and save. And whenever we stop the marquee update, we just need to set up the visibility to collapse again. So whenever we compile and save, here in the unit selection marquee, in the start resizing marquee, we should get the player controller. From here, get the HUD. We will cast this to our HUD. We will get the reference to our HUD, our widget HUD. And from this reference, what we'll do is start marquee update. And we need to do the same exact thing to the other side. So this, in the end resizing marquee function, let's just paste this. And here let's call it stop marquee update. Now if we press play, we click, our marquee shows up, and then it disappears. Now let's prepare ourselves because we will be facing some math. For the marquee to be resized, we definitely need to know where is the starting point and where is the end point. So in order to do that, we will need to do some math. Let's go to our HUD and we need to update the marquee. So this should be called here in the blueprint unit selection marquee inside the tick event here at the end of this. And we should really get rid of this sphere. So let's start removing the spheres. We don't need that. Let's leave it like this. Are there any spheres here? No spheres. This is the box collision. This is fine. We can right click and straighten the connection. And this is also the box collision. So we need to add it after this. So very easy. We just need to copy this again from the start resizing marquee and just add it again. And let's call update marquee. Now we're calling this marquee update whenever we need it, which is perfect for what we need to do now. And let's just get rid of these spheres. Compile and save it. We will go back to our widget blueprint and inside the function called update marquee, we first need to know where our mouse is. So here again, let's get mouse position on viewport and let's save it as an end location. So now we have a start location and also an end location. We will need to do some magic with this. First, we will set the position of this marquee. of this image. So we need the image. This image, because I need to change the location, we will call it slot as canvas slot. This will allow me to change its position with this nifty function called setPosition. Perfect. And we need an in position. This could be our start location. If we press play, we click, and wherever we click, our image will follow. Then it's a matter of, here again, I'll duplicate this and set size. This is the one I need. And the size could just be the end location minus the start location. So graphically, if this is my start position and this is my end position, we are just getting this value in y, excuse me, and this value in x. Because we can just, if this is the 0, we can compare it like this, just so it's a little more easier to understand the math. Let's say that this is 0. So from here to here will be the start location, and from here to here is the end location. So subtracting the end location by the start location, we're effectively getting rid of these parts. And we are just getting this value. The same will be in the y-axis. So let's just subtract. And by the way, these are just vector 2D. So if I split it, we have an x and a y. And with this, let's try to just plug it in. We will compile, save, play. And look at that, it is working. But you will find out, and it's working pretty well actually. The only thing that we need to fix is that it only works in this direction. If I go up, I won't see anything. If I go to the side, I won't see anything. And here either. Why is that happening? Because whenever we are subtracting the end location minus the start location, this starts giving me a negative value. And if you put a size minus than, excuse me, a size with a value less than 0, then you get nothing. So we need to fix this. To make it resize in all directions, that is where the magic part enters. Let's, for now, just work with the position. So I'm just gonna put this a little bit further, and in size, I'm just gonna put 100 and 100 here. That way I know when my position is working. So what we need to do is that whenever we cross this value to this side, instead of resizing it, we first need to move the position. And let me just draw here. Let's say my mouse is here. We need to move this way, and then we need to resize it so it fits the amount that we move it. Let's just worry about the movement, then we will worry about the resizing. So in the position, this in position will depend entirely if my start location is later, and let me just, it will depend entirely if this start position is here and my end location is here. I need to know if this value is positive or if it is negative. So what I will do is make a vector 2D, because I will need to check the x value and the y value in both axes, because there will be sometimes where, oh, it is positive in both sides, here is just negative in x but positive in y, and in this case it's positive, it's negative in both sides. So we need to do something like that. So to do that, let's just worry first about x. I'm going to split the start location, and for now let's just connect the y. X now should always be in that place. Perfect. We need to here select float, and we need to do a little operation to know if my value is negative or positive. So what I'm going to do is the end location minus the start location. This will be giving me a positive or a negative number. Now I need to check on both, so I can break the vector like this, or yeah, let's break the vector like this. We could also split it, but I would probably be using this again. So I'm just going to break the vector and compare if this is greater or equal than 0. So if I have a positive value, I want to use the normal start location in X. If I press play, here should be fine. And whenever my value stops being positive in X, then it's going back to 0. So it's good because I can now play around with what should I put here. And what should I put here? Well, from this result, we need to add the starting point, the starting location. Why? Because this is giving me, for example, if it's this way, minus something, my starting point is here, so this minus something will give me this new location. And I should really split this. X should be going here. And let's put this like this for now. And let's press play. We go that way, we go this way, and it is changing its location. So it is fine because here I'm changing the X location, and here we should just be resizing it. In this case also it should be a resize, and here we are changing the X position. We just need to do the exact same thing for the Y value. So let's just copy this, connect it to Y. The A will be whenever this value is a positive value. And the B is, well, this result. I will put this way, just so it's a little bit more easy on the eyes. Hopefully. Okay, so with this, let's press play. Should be working this way and upwards. We just need to resize our our marquee, and we should be done with it. So let's fix the size of this image. Here, let's again start with the X value, see if that works, and then we can see how we can just copy and paste to the Y value. So the process is very similar. We need to make this a vector, so it gets easier to handle individual values. And then we just need to get the, well, this operation is the one that we need. End location, start location, we will break it. And we need to ask if this is a positive value. And we need the select. And should be something like this for now. This is if we are dealing with positive values, so we can use the value between the end location and the start location, just like we had before. This should be working in the positive space, and now I'm not seeing anything, so I may have, oh, here at 0 this should be 100, so we can test around. Yeah, so this should make it work as always, as it was working before, because it was working with positive values. But in the other hand, it is not working. So we need to fix this part so we don't have a wrong value here. So to do that, we just need to get the size, exactly this size. Let's remember, and I will put like a, or start will be an S, and the end location will be here. We are subtracting this. This seems to be a bigger value in terms of X, so it's something like this. So whatever this value is, it is definitely negative. But we do still need this part of the value. But we always want it to be positive, otherwise my size, if it goes under than 0, it won't show me anything. So we need the absolute value of this operation. With this absolute value, we can plug it in, and let's split it, plug the X value here. Let's press play. Here is working, and now it is working the other way. We just need to fix the Y value, and we should be done with it. It's more of the same. Here we will connect Y, again Y, and Y. Let's press play. And now it should be working correctly. And we can see what we are selecting. And it's very precise. I didn't expect it to be that precise. Yeah, it's pretty good. Actually, I like it a lot. That seems perfect for me. At some point, our game needs to end. I'm planning to make some enemies attack our town, and whenever our town hall is damaged and, well, destroyed, we should lose the game. For that, I need a way to add some damage and also to show some damage. The best way to do that will be through a health bar. So I'm going to create a health bar. First, This health bar probably will be used in every unit, so I'm going to create it here. I'm gonna right click, user interface, widget blueprint. I'm gonna select user widget and I'm going to call it widget health bar. It could be health bar. Maybe later on we could reuse this bar for something, but for now let's just call it health bar. This doesn't have anything inside it, so what I do need inside it is a progress bar. This will be the progress bar, and this widget have some values that we can change. For example, this percentage. I'm gonna call this progress bar health. And to update this health bar, well, I need to go to the graph part of this widget. So let's go to graph. Let's create a function and let's call it update health. Or better yet, update bar. I will get this progress bar, set the percentage, set %, and here it will be the in %. Yeah, that's pretty much it, what I need with this bar. Now I need to define a size. In this case, there is no other widget on top of this. So whatever I tell it to be created, whatever widget I put it as a parent, then it will change. For example, if I right click it and wrap with a canvas panel, it will make our widget go to that side, and it will depend on the parent size. But I do not need this because I will create this on top of my characters, and I can try to guess a good size. If I go here in screen size, no, excuse me, instead of fill screen, just put desire or custom on a screen, and I can change the width that I need. And I will probably just need, I will try with 300 and then 50. Yeah, so I am narrowing down the look of this progress bar. Let's compile and save it. And I'm going to use this on top of a character, but for that I need a component called, and let's create it. Let's just right click here, blueprint class, and search for widget. And I need this widget component. Let's select it, and this will be my blueprint health bar widget component. Let's double click it, and here in the user interface category, I want to choose screen. Widget class will be my widget health bar. The draw size is gonna be 300 in X and 50 in Y. And let's try to use it. Let's compile, save it. And inside my level, I can click anywhere. Well, any actor, for example, this worker. And I'm going to add that component called health bar. And whenever I press play, I should be able to see the health bar, and it's definitely too big. So let's regroup with that and just divide by 4. Let's press play. And it's a little bit better. I need to adjust it a little bit so it's on top of stuff. So probably this worker, I could take this component and just put it up on top. Press play, and now the health bar is on top. This way I can add health bars to whatever thing that I need. So here I can do the same. But I will definitely try to add this in the blueprint, not just in the level like this. But at least I know that it is working. Let me remove these components. Excellent. Connecting the health bar to the health of each character should be pretty simple. First, let's open the worker. And in this worker, we have a unit component. This unit component should have the health value. So let's just right click it, edit it. And here as a variable, I will add two values. Well, two variables. The first one is the health, which is a float. And the second one should be the health max value. I need both of them so I know, I can get the percentage that, for example, if I have 50 health, if my max health is 100, then the percentage should be 0.5 or 50%. So that's why I need these two values. By default, I'll put my health at 100 and also my current health. So I have my max health and my current health as 100. Let's compile. Now in the worker, I do need to add my health bar. So let's add the health bar. Health bar here. In the viewport, our worker should be here. Let's compile and save and see the results of that. Yeah, every worker has a health bar now. Perfect. And it may be too long for the workers. It will be a good idea to change this draw size maybe to 50. And this I'm editing in this component, not in the parent one, but in the instance of the parent. You see that here I have these default values, and here I'm editing the default values. And looks better for that unit. Now, I do need to update this health bar. To update it, first, in the event graph, I'll go to the begin play. And here I can add some code that will update the health bar. But I would need to add that code to any type of unit that I create later. So because I know all units will have a health bar widget component, what I'm going to do is go to the unit component. And let me close this unit selection marquee and the HUD so I don't have some clutter here. In the unit component, what I'm gonna do is here in the begin play, I'm gonna make a sequence. Just so I have the bindings at the bottom and some actions at the top. So I need to get the owner, and I want to know if we have the health bar. If this is valid, and it should, but you really don't have any assurance that it will be valid. If it isn't, just in case, I will print string bp unit. Oh, just call it unit component no health bar component valid. And I sure wish I could type faster. There it is. But if I do find my health bar component, then we can update. Oh, and I do not have the update value here. Well, I can get the widget and I would need to cast it. So maybe in the health bar, let's go back to the health bar. Let's create a function called update health bar. This will call the get widget. And where's my widget? Reference. Get widget. This is the one that I need. This get widget that targets a widget component, which will give me this widget. I'm gonna cast it to the health bar. And from here, I will update the bar. In %, update the health bar in %. Compile, save it. Let's go back to the unit component. And now, from the health bar reference, update the health bar. And the in % will be that health divided by the health max. This should give me 1 because my health is equal to the health max. So let's check it out. And yeah, it is 1. If we modify the health maybe to 70, everyone should start like that. We have connected the health to the health bar, but only at the start. We should really connect it every time our character gets damaged. So for that, I will go to the worker, and in the worker, there is in every actor, we can apply or receive damage. If we just type damage, we can apply it. Damage, point damage, if this is usually used for bullets. Radial damage, usually used by grenades, so because it is an area. And also we can receive those 3 types of damage. We'll use any damage so it is easier to handle. And I can go here, any damage, and every time I receive damage, then I'll get the health bar widget and then do some stuff. But again, I would need to do this in every worker and in every other unit. So because it's gonna be repeated in a unit, then well, let's use again the unit component. So let's edit it, and we need to bind the event called, and let me put this here, the event called on any damage. Let me remove the tick. I don't believe we need the tick in this component. We can optimize something by class defaults and just disable the tick. If something works wrong, then we can enable it and see what's happening, but I don't believe something will fail. So get owner again and bind on take any damage. So here, let's connect this, create an event, and this event will be called, let's create a matching function, function. No, let's create a matching event. This will be called on owner take any damage. And let's check that this is pointing the right direction. Compile, save it. And I will do the same like this. I'm gonna copy that. Oh, I could copy everything here, actually. And yeah, if we're gonna copy all of this, then we can make this a function, like something like this. Collapse to function. Yeah, because what I'm going to do, copy this and put it here. So we'll apply some damage and then we'll update it. But because we're repeating some code, then it will be a lot better if I select all this, right click it, collapse it to a function, and this one will be called update health bar. Now we need to take the damage and, well, health minus the damage will be the new health. But in order for us not to get to negative numbers, then we should here, I'll use the max. So if this returns maybe 70 and 0, the max number is 70. But if it returns a negative number, the max value will be 0. So it limits it to 0. This will update the health, and here I will update the health bar. Let's compile, save it, and everything should be the same. Let's check the health. Why is that happening now? What did I break now? Update the health bar. Yeah, should be working correctly. Or here in the worker, unit component, health. Yeah, it seems like it is fine. And it seems that sometimes it's working, and sometimes it's not working. It's really weird. And it does have to do with, here in the worker we have two components, and depending on which one initializes first, then we are getting different results. So to avoid that, I'm just in the blueprint worker, just going to delete this health bar component. I'm gonna compile and save. Right now we shouldn't be getting, we should be getting that error. And now in the unit component, before updating this, we're gonna make sure that we will always have a health bar. How will we do that? Here in the event graph, before updating the health bar, we're gonna add the health bar. So spawn. Oh, and this is not an actor, excuse me. Component, was it add? Component by class. Perfect, the class is health bar. The attachment should be by default false. We don't want manual attachment. We can even create a variable for this widget component, but I don't want to do that. The target is not self because self is not an actor. If we compile, this will be error. So let's get the owner. So I'm adding this actor to the I'm adding this component to the actor, which is the owner. And we need a relative transform. And if I remember correctly, this relative transform should be maybe 50. And let's save it. Play. It was a little bit more. 100. More. 200. And that was too much. So I'll compromise with 150 or 110. Yeah, that's better. Now, the damage, we need to test that. We already have linked an event to take the damage and then update the health bar widget component that I believe I missed named component. So a quick way to check that here in the worker, I'll add a delay, maybe 3 seconds so we can see it, or 2 seconds is more than enough. And I will apply some damage. The damage actor will be ourselves, and the base damage will be 20. For now, I can leave this empty, it won't matter. Let's press play. 2 seconds, and we receive the damage, so I know that it is working. We should do the same for the buildings, so we can also damage the buildings. Let's just remove this. Compile. Let's go to the unit component. And yeah, we will be doing something fairly similar. I could also make the unit component and use it as a building, but yeah, so it is a little bit different, I won't do it. Building, it also has its building component. At the begin play, I do need to do this stuff. So I don't have this function. Let's create a matching function, confirm, add it to the sequence. Deselection, I will probably put it in another component, so I'm not gonna add that. The damage, I should really add that. Create a matching event. It was called owner take any damage. Excellent. I need to fill that health bar. This is fine. This is also fine. The update health bar, I need to fill that in. So I'm just gonna copy and paste the code that I already did in the unit component. Like that. I also need the health max, create the variables for them. And this will be building component. Just like this. I don't want to modify the... where is it? This is the blueprint component. Excuse me, I'm searching for class settings, class default here. I want to modify this draw size for each. So in the worker, excuse me, in the unit component, I will here add the set draw size. And I will make this into a variable. And I will open the eye, so we can modify it later. And also this health and max health should be open. Unit state, no, that changes depending on what the unit does. The transformation should also be a variable, and I'm in the unit component, by the way. Health bar, relative location. And because both of these are from the health bar, I'm gonna add a category health bar. And I can add it like that. And both of them are using the health bar. And I'm just going to, yeah, because if you drag it like that, then you will have these two type of health bar. Just choose the one that you like. Okay, so we have this that we can later modify if we need it. For example, in the worker, the draw size in the unit component should be, by default, I should set it up as, what was my draw size here? I'll just copy this unit component and I will paste it. Compile and save it. In the worker, I'm gonna click on the unit component and change this to 50. So it is smaller. Perfect. And now we can close the worker. In the building component, I already add my update health bar function. I do need to add the other code that I added here. So this and this, I'm gonna copy it, building, just like that. Right click on the variable and create health bar relative, and you need to click here at the side, not on top of the text. So just like that. I need to connect this set draw size to the widget component that I created. And here, I don't know, no, of course it's not there. Let's copy again this draw size, copy it, building component, paste it. And here I will just put maybe 100. Again, this health bar, I do not have the category here, so let's create it. Health bar. And again, health bar. Open the eyes of this. Compile, save it. We can press play. And we do have the buildings. The health, it will be maybe 400 for the max health and the starting health. Compile, save it, perfect. Let's play. Here is the health bar. I do need to change the location of that health bar in my town hall. So let's go to the town hall. And because this event on take any damage, it's been binded, then whatever we put here will start working, and we should put the same code. I was forgetting that. Let's just copy this and paste it. So whenever also the, yeah, that's better. Whenever the building gets damaged, let's compile, save it, and let's go to my town hall. Buildings, town hall. Let's delay it. And again, apply damage to itself. The damage actor will be self. And the amount of damage will be 150. Let's press play. And this should change. Yeah, it is working as I expected. Now in the building component, I do need to change this draw size and the relative location. This should be a little bit higher. And maybe changed in the x-axis. let's just put 50, 100, and this move it here, so minus that. Yeah, it could be, could be. Let's put this 1000. Yeah, it's a little bit better. 2 maybe would be even better. That's too much. This value should be great, and I will increase the draw size. 12 could be maybe 20 and 200. Yeah, now it's like a different kind of... Yeah, and remember, every building now gets its own health bar that we can modify, and if they get attacked, then, well, we can change it. Let's fix the other buildings. Let's just set them up correctly. We had houses, and the town hall, we don't need to apply that much anymore to it. The house building component here, probably 600, and I will put this to 100, and let's see if that works. Yeah, should be fine. Maybe 600 is too much. And I will do the same for the other building, which is the... Was it the training center or was it the barracks? Probably the training center. Building component, 100. This should be 50. And yeah. Now everything from our buildings has its own health bar. Now that our building is showing the health, we can create enemies to attack our buildings. First, let's close all the irrelevant tabs. And now we need a way of controlling our enemy units. So if we were the player, we would use a player controller, but in this case, we are going to use a AI controller. So let's go to core, let's create a new folder, enemy, and inside it, I'm going to create a blueprint class. This blueprint class will derive from our AI controller that already exists. It's called AI controller unit, but this one is AI controller enemy unit, and it will have a very simple way of controlling our character. Now, it's also a good idea that if we're gonna change some materials here to make our enemies maybe not use those blue gloves, but some red gloves, maybe, if we can, it would be a good addition. We should create two types of enemy here. So we have this folder called unit, and inside it there is our worker. Like we did with the buildings, we are going to create a folder called units. And let's say it will be two kinds of tribes. Let's create tribe 1 and tribe 2. Let's go back to the unit. Let's create one child blueprint class, worker, drive 1. And this one will be worker, drive 2. If we have another skeletal mesh, we could change them. And let's just put the drive 1 in drive 1 and move here. Do the same for the other one. Perfect. Let's save all. With this in place, we can go to the tribe one that will be our enemy tribe for now. Let's double click that, and in AI controller class, we're gonna select our enemy unit. Let's compile. Let's remember that inside it, we have all the code that is in our parent class. Okay, so this means that if I drag and drop my worker here and I play it, I could be able to select it. We have not defined a way to treat this as an enemy, and we should really do that. We're going to go to our unit component, and as a variable, let's go call this alliance. And there's a better word for it. Let me just search it. It's team attitude. And yeah, we can call it that. Let's just call it team attitude. It's more descriptive. Compile and save it. By default, it is friendly, but it can be friendly, neutral, and hostile. This enumerator already comes with the engine, and it has not changed since Unreal Engine 4, so I believe it won't change in the future. Let's go to the... Oh, and let's open its eyes so we can change it later. Compile, save it in the worker drive. Unit component, it's a drive 2. Let's put it as hostile. Compile and save it. Now we can still click it. So we need to fix that selection issue. We are selecting stuff in our player controller. Or no, we are selecting stuff in our select unit selection marquee. We changed that, if I remember correctly. So here in the begin overlap box, we do need to check this, but also we need to check its team attitude. So let's here other actor, get component by class, unit component, team attitude should be equal to friendly. And I need both of these statements to be true. So and we're checking if both statements are true. Like this. Now if we press play, I can select this, but I cannot select this one. And we should really change also the color of the health bar, right? So here in the unit component, we're going to check its team attitude. And where are we creating our widget component? We should be able to change its color. Just like we created an update health bar, we're going to create a new function, and let's call this update health bar, which is the one that it's inside the blueprint widget bar widget component. Let's create set also update health bar color. We should receive a color, but let's do something very similar to the update health bar. And we need to go again to the health bar. W health bar. Go to the graph. Here another function, update health bar color. Is this health bar set color set fill color and opacity. Just connect it like this, compile it, save it, we can close this. Here I will code something with color, update health bar color. And again, we need the input here, so just connect it like that, compile and save it and close it. And in our unit component, we can go back to the event graph, and whenever we create this, we are setting the draw size, but we are also setting the color, update health bar color. If it is, and let's get the team attitude here, select, and I'll connect this return value to the in color. If it is friendly, I should set up a blue type of color. Something like this, maybe. If it is hostile, I'll just change it to red. Complete red, if I can. And neutral, maybe some yellow. We probably won't have any neutral, but just in case, let's just save it like this. Let's press play. And we should try to match this color, but our enemy will be red. To match that color, it's pretty simple. Let's open our widget health. Select this color. And with this color selected, we can drag and drop colors to save them. Let's press OK. We can go back to our unit component, click on this color, and we will have here all the colors saved before. So I can just click it, and this will be the new color. Okay, play, and yeah, we can select these guys, and we cannot select. Oh well, I cannot select with the marquee. I do really need to change the way I am clicking this other character, which is, I believe, through here. Unclicked. Where is my add unit to selection? Owner click. I need to make the same validation here. If the team attitude is equal to friendly, then this will be true. So now that should fix it. Or maybe not. So we need to go to our worker blueprint, because I believe we have some selection stuff there. Select this actor. Yeah. And here we should add another validation. Right now, I'm not really satisfied with the way our selection is working, so we will definitely change it so it can all be inside one component. But here I'll just get team attitude, and again, if it is friendly, then we should be able to select this. Otherwise, okay, we can select this, and we cannot select this one. Let's make the AI controller of the enemy make the enemy do some stuff. So let me close all this stuff, and it's a good idea to save everything. Now in the worker, let me make sure that we are using the enemy unit AI controller. And with this, double click it. In the event graph, we just need to do something pretty similar to my player controller. If we don't remember what we did, just in case, I'll just open it. And here we have a mouse action, gather resource, interact with building, move to this location, etc. So, for example, let's just use move to this location. I'm gonna copy it, and here in the begin play, I'm just going to make a delay of 2 seconds. And now, after those 2 seconds, I'm gonna tell it to move to the location. The target is the controlled pawn. And let's put the location, let's just grab this location. Copy this. And AI controller enemy unit. I just want to test it, so I'm gonna paste this here because it won't let me paste it here. Oh, let's create this as a variable for now. So it lets me paste it easily. Paste. There it is. Compile, save, play. And after 2 seconds, this should start moving around. So we need to add a way of attacking. And with that, we can simply put a little delay here and send our unit to attack the town hall. So it should be pretty simple. So just like we have this order of move to this location, let's just double click this so we can open our interface. And I'm going to create attack this actor. We could have unit, but then we would need to create attack this unit or attack this building. So we could say attack this actor. As an input, I need an actor. And this will be called actor to attack. Compile it, save it, and we can close it. In the AI controller of the enemy, we won't be using move this location. We will be using attack this actor. We don't really need this variable also. And we just need to, well, set up this reference. To do it very simply, very straightforward, we could get all actors of class, and with this get town hall, well, town hall, and there should be only one because our enemies really don't have a starting point. They will randomly appear and then will start attacking this town hall. But if we remember, if we get the game mode and cast it to my game mode, we should have an array of our town halls, if I remember correctly. Get town halls. I will get these ones. And from here, I will iterate with a for each loop and search for the one that it says it will be friendly, because the other town halls should be telling hostile or something like that, or neutral maybe. So here I will search for the friendly town hall. Get building, and I need to get the component, and here I'll get the building component. And if I remember correctly, I haven't added that team attitude. Team attitude. Because I'm really duplicating a lot of variables, I could probably put all this in a structure, and then I just put the structure here and the structure there, and then I'm done. But I don't believe I will be doing that just yet. And by default, this one should be friendly. Friendly, it means it's my player, and neutral, something else, and hostile, the enemies. So the enemy needs to check if the team attitude is friendly. Like this. And if it is, then we should get rid of it. So this element, I need to put this attack actor here, and the array element, which is the friendly town hall that we found, should go in the actor to attack, just like this. This is a very simple way of setting up enemies. For more complex behavior, we should be using a behavior tree or maybe an state tree in order to determine which building should we be attacking to. But here we just need some enemies to attack us. Now, this sends the enemy the order to attack this specific town hall. But we need to implement that, because right now nothing should be happening right now. Now it is a matter of implementing this attack order. So let's save this. Let's go back to our worker, and let's go back to our main class of our worker. So let's edit this. We don't need the building component and I don't need the worker drive also. So the orders are here, I believe. Gather the resource, event, and we should really move them someplace else. I will delete this. I will select this move to location, and I'm going to call it move to location order. This is the event gather this resource. Gather this resource order. And I'm gonna put it here. Yeah, pretty clean. This, I don't remember what it was. Doesn't seem to be an interface, so let's not mess with it. Repeat demand in action also. This is the interact with the building order. And we had some code that we could add later. For now, I will leave it like this. I'll go to interfaces and select the attack this actor, implement that event, and move it with my other orders. And let me put this here. And whenever we are attacking, we need to go that place. So it is pretty similar to this. So let's go AI move to. We need to move to the actor. Now this actor could have a big radius, and we should really put our radius somewhere in a component. Maybe we could check if this is a building or if it's a unit and then get a radius. For now, attacking the actor will have acceptance radius. Well, this one I believe is okay, and I'll just put stop on overlap just in case our character gets stuck trying to attack the building. Now on success, it means I reached the place, so let's see if this is working. With a hello. Yeah, it is sending the moving action. And I don't know why my animations broke. But yeah, it reached the location. So at least that's working correctly. And I do know why my animation broke. Here I'm not setting the state. So I did forgot about that. Movement. Now the animation should be fine. There it is. With this, when it's a success, I need to start attacking stuff. And if we remember, we had a mining state. Let's just create another unit state. So I'm gonna open E unit states. I'm gonna create a new one, attacking, and it's gonna be the same animation, so I don't need to add something else. I want to create the attacking animation, and it will be very similar, like when we are gathering stuff. Movement, we should set the actor rotation. So thus far is pretty similar. There is a way to reuse this stuff if we were using behavior trees, but I do not want to overcomplicate this beginner's tutorial. I mean, it's already a bit complicated, but hopefully I have not lost you just yet. So we're copying and pasting this code. And now I want it to attack. I'm not gonna do too much validation here. I just want to here handle the unit state, mining, attacking. And again, here we had on enter movement, on enter mining, we should create those, the one for attacking. So unit component, let's right click and edit it. On enter attack. Because we are going to have a lot of event dispatchers, or well, a lot of states. Let's go back to handle new unit states. We can avoid having to create an event dispatcher for every little things by here creating one called on enter new state. And I'm just not going to use this enter new state. I need an input here on enter new state, and I did not mean to click it. Where's my handle new unit? Here it is. On enter new state, I need an input. This input will be E unit state, and new state. I'm just going to call it here. I should really compile. I'll delete that, compile, save it, and I'm gonna call it again. And the new state will be this one. Compile it, save it. We can remove this. And in the worker, we need to change some of this. Okay, so instead of using this type of states, we will just right click, add event, on enter new unit state, and let me put this where our animations were, here. And I will do a switch. Or no, better yet, we just need to use display animation. This will be a select. I can delete all this. And the new state is the one that I will use. So if it is none, I leave it none. If it is idle, I'll use the idle. The walk forward, I'll use it in movement. The animmontage, I'll use it in mining and also in attacking. So every time I create a new state, it will ask me for an animation here. And I don't need to worry about creating more event dispatchers. Also, I can just delete the other event dispatchers, because I have one that it's encapsulating everything, and if I add another state, then I don't need to worry too much about it. It's very scalable this way. And I wanted to show it because usually code gets out of hand really quick and you need to be very fast in order to keep your code clean and scalable. So we're attacking here, play animation. Let's go back to our attack order. Movement, move to here, handle. And what I will do is, just like gathering, where I have a retriggerable delay, I will call something in order to attack, and then I will repeat that attack. So we will have this retriggerable delay. And another way to do this, because you already know how to do just use this delay, is through timers. And I don't think I have added timers in this project, so it's a good idea to also test them. To add a timer, you will just set timer. We can add a function, use it by function name or by event. I will use an event so it is easier. This event will be called just add event, add custom event, and it can be connected like this, or just like with event dispatchers and bindings, we can create event and then we can use whatever event there is, or create another one. This event will be called attack. But the thing about this is that with timers, I won't be able to get this reference, because a timer isn't able to get any input value. So now I do need to save it as a variable. So here I will save it. So let's right click here, promote to a variable. Actor to attack seems like a good name actually. And just to avoid any type of these wires, I'll just change it like this. It will be the same. And every time I get here, I want to attack. I need to attack the actor. So here I will select attack. The actor will be the actor to attack, and I want to apply some damage to it. How much is my damage? Well, the unit component should probably tell me which is the amount of base damage it should be doing. And I wanted to loop this attack unless I need to interrupt it by any chance. But for now, let's just put that it will attack every maybe 1 second. And I want it to loop. Let's compile, save. For now, the base damage will be, I don't know, maybe 50. Let's press, well, save, compile. I want this enemy to be a little bit more closer. And let's press play. After 2 seconds, this enemy should start attacking my city. Nothing is happening yet with my building, but at least I know that the attack is working. Again, here in the unit component, I should also add attack value or damage to apply. This will be a float. Compile, save it. In my worker, the damage to do, I need to open. It's something that I should be able to change from anywhere. So I'll open the eye here. Damage to apply. By default, I'll leave it at 10. So the worker will, yeah, doing 10 of damage is fine. Maybe 20. 20. And the workers of the other tribe. This is my base worker, excuse me. This should be 10. Compile, save. Let's open our workers from tribe 1, which is my tribe, the player tribes. Maybe they attack 20. And the other tribe, maybe they are stronger. So I'll just open the full editor, unit component, and they will do 50 damage. Which means that I need to, in my blueprint worker, whenever I'm applying damage, I need to use the unit component get damage to apply. Perfect. Compile and save. And there it is. It should be doing some damage. And my workers should be also able to do that. But they can't. It's because, well, I have not set up the behavior whenever I'm clicking on some enemy unit. And maybe that we should do that. So whenever we click on an enemy, we attack it, and then we can finish this attack behavior, because right now this attack cannot be interrupted by anything. So let's go, well, let's save this drive worker unit component. Yeah, let's close it also. We need to go to our player controller. And here, whenever we do a mouse action, we are moving selected actors, units. If it is true, I'm checking if it's a resource. If it is false, I can check if it's a building. And if this is false, then I can check if it is another unit. If it has the unit component, unit component, the target is this one, the same that is going to the other get component by class. And if it is a unit component, I need to check if it is hostile. So if it is hostile, this is done in my player character, in my player controller. So hostile means the AI. Get team attitude. And if this is hostile, then we should really attack the unit, which is the unit that we want to attack. Gather this resource is something like this. Attack this unit. This is the actor that will attack the unit, and the actor to attack, it's the other one. Actor reference. There it is. A little bit hard to understand, but we're in the same flow of execution, so should be pretty simple to know. This is an object reference, this is an actor object reference. So here we will attack the actor. Let's see if this works. We click this worker, we click that unit, and now it is following, is attacking. And now you see this little problem that whenever I reach the actor, then it's still attacking it, which is not very good actually. We need to account for that. To account for it, I will do a simple validation. Worker, before attacking, what I will do is check if I'm close enough. So I will need to have a range. And with that range, check if, well, I'm in range, and if I am, then I should apply the damage. And to do that, let's just check here in attack. If the attack, I need the actor to attack, and I need this actor, so get actor location. This one also get actor location. We can copy and paste this. And we can get the distance. This will be the distance between two vectors. And if this distance is bigger than our range, then we should not be able to attack. Again, the range may be in the unit component, or we could actually use the capsule component radius. So I'm gonna do that as capsule component get scaled radius, just in case we have scaled this actor by any number. And I will add it maybe 30 units as an extra range. So if this distance is greater than my range, and I will add a comment, this is the worker range. And if this is true, then I want to cancel this attack. So what I'm going to do is, if this distance is less or equal my range, then the attack should proceed. If it isn't the same, the attack should be cancelled. I need to cancel this event whenever this range is not fulfilled. So I need a reference to this timer. Call it attack timer. And I need to cancel the timer first. And let's get the timer and use clear and invalidate the timer. Otherwise, if we're in range, then we will keep applying damage and this will be still looping. But in this case, we are going to attack. We are going to check if we are in range, and we can add here or maybe here. Check if we are in range. And if we are not in range, we are clearing the attack timer so this won't execute. And we need to send this attack again, which should handle the movement. So let's go here again. Attack this actor. The actor to attack, well, it's this one. And let's see if that's working. Oh, and I didn't click exactly on it. There it is. Our range failed, and now our range... Oh, our range keeps failing. Maybe our range is too small. And maybe we can solve it in an easier way. We could just copy this, and whenever our movement finishes, we will save that range, because it means that we are really close to the other actor. Yeah, let's save the range there. Just like this. Promote it to a variable. Range 2. Actor to attack. Just like this. Yeah. This is where we are saving the range. And let me move this a little bit to the side. Here it is. Range to actor to attack, and we're gonna use that range here. So if the distance is less or equal than the range to the actor to attack, then we should keep attacking. Come on, there it is. The range should be higher and the range should be equal or less. And everyone could join the party and attack that guy. Let's finish the attack behavior by trying to first attack this guy. We're attacking him and we try to move to another place, but our timer, whenever the range is going to another side, it's equally trying to attack, because, well, if we are invalidating the attack, we are calling the attack behavior again. We need to check here if we're still attacking. So we want to check if the unit state is equal to attacking, then for sure we should continue attacking. But if we change our mind and we start mining or, well, doing something else, then we shouldn't be locked to the attack behavior. See, now we were just moving, so we are just avoiding the fact that this will send me to attack again. Let's fix a little bit of problems that I have with the navigations. If we press P, we have this part that is not properly built. We can go to, was it platforms? Nope. Settings? No, it was built. And navigation build path. Yeah, this will tell me that some errors happened, but it will fix my nav mesh. Also, these are a little bit hard to click, these workers. So let me open my worker, and in the viewport, let me increase the capsule radius maybe to 50. So they are a little bit easier to click on. Also, we had some issues when our workers were trying to move, and they were getting stuck like this. To fix that, we will go to the project settings, we will go to navigation, and in navigation mesh, we will find the agent radius, and we will put 100, which is the radius of my worker is 50, so the whole worker is like 100. This will build the navigation again. We can press play, and we should be able to move around very cleanly. And we're still getting stuck, then we can up the agent radius to maybe 150. Oh, and excuse me, I believe that amount was too much, maybe 120. Still. And let's return that to 100, and the worker, maybe 50 was too much, 45 as the capsule radius should be good enough for me. Oh, and I should really increase this. Let me open it. Let me get the mesh. And the collision, I remember that it was, yeah, it may be too exact for me, so I just need a box here. Remove collision, add a box. And this box should not be floating around. Yeah, that's a lot better. Save it. Should be better for our navigation also. Oh, come on, don't get stuck now. So it seems I was missing a piece of the puzzle. Here in the project settings, just agent radius. Let's just try with 100. And let's wait for this. In order to be really sure that that value called 100 of the agent radius is working, here you will search for recast nav mesh. This is automatically created when you add a nav mesh, and here you should also find the agent radius being 100. So let's press play. And now it does avoid being stuck. It was pretty weird. I mean, it has to do with me being a little bit hasty by pressing Alt P so we can play. But at least that thing is working. Again, just in case, I put my worker, and this is not the worker, the capsule component, put it at 45, the capsule radius. And the gold, I just set up its new collision to be a little more simple. And well, you can change the recast nav mesh, and here is the cell size and well, you just need to change the agent radius and wait for it to compile. Otherwise, you will get results like mine. Now we have this like bumping of factors here like this. We can also fix that very simply with two approaches. One is here in the worker, character movement, and we will search for RVO. And it was almost at the end, RVO avoidance, which will just push our characters apart, like that. Or the other one, which it's probably the one that we will be using. Let me remove the RVO. RVO is very useful. The only thing about that is that it can push us out of the nav mesh, which will make our AI stuck. The other one is, let's go to our, well, let's save, because I'm gonna do a kind of a big change. Let's go to our AI controller, unit, where is it? AI controller, unit, and here the parent class is AI controller. Now we are gonna change that by going to class settings, parent class, and let's find our AI controller, detour crowd AI controller. Let's compile, save it, let's press play, and we should start avoiding each other. Oh, I clicked on it. Oh, excuse me. My bad. They should avoid each other by using the nav mesh. And we could get very weird results with it. Yeah, like that. The ROB is a little bit better with it finding the way to avoid themselves. But here we're using the nav mesh. It would be just a matter of making those rotation a little bit nicer. Let's take another break. Before continuing, to review what we have done and also to clean up these tabs. So what we have done is, well, a lot actually. Created the selection collision actor, changed the marquee dimension, fixed a lot of stuff with the marquee, select and deselect units, remove the marquee when it's not active, and well, many more, like adding a health bar, connecting it to our units, and also the fact that we now have an enemy that can attack us. So we have done a lot. The next steps are, well, getting to do something whenever our health bar reaches 0. So here, if this reaches 0, then it should be destroyed and I should lose the game. And also if the health bar of an enemy goes to 0, it should die. So those two go almost hand in hand, because, well, whenever the health is depleted, something should happen. So let's do something when the town hall is destroyed. Let's open our, well, let me finish closing the tabs. Let's open our town hall, and now I will open our building. And this building has, well, this building component. Inside it, well, I have the health bar. So this building component is the one that when we receive some damage, then, and let's open the building component. When we receive some damage, then we are setting the health and updating the health bar. Right. So when we get our health to 0, then we should do something about it. Here we are taking the damage, and also, well, here we have connected and binded this event. So here in the owner take any damage, I will, well, update the health bar. But after this, if my health is 0, So let's say if less or equal, definitely it won't be less than 0 because here I'm just making sure that that is not the case, but I like to make really sure that this will work. If our health is less or equal than 0, then we should destroy this building. What should it mean? Like, oh, destroy the building. We really don't know. Depends on the building. Maybe it's a building that can be rebuilt, or it's a building that just gets disabled. I don't know. So what I'm going to do is use an event dispatcher to later implement it inside the building class. So here, event dispatcher on destroy. And I'm just going to call it here. Just like that. Compile and save. And inside the building, I can select my building component, right click on it, and I have this new event. And if it's called on destroyed, later we could get some errors about it. So let's change the name to on building destroyed. Better. So in the building, I don't really need to put something, or I can just destroy the building. So on building destroyed, then we just destroy the actor. Something like this. So we press play. This guy should attack me, and I will bump the attack value of this enemy so it is faster. And then we have it. We have destroyed the building because this has been activated. I will get some errors because the worker is still attacking something that doesn't exist anymore. But whenever the town hall is destroyed, I want to lose the game. So I will go to the town hall. I will again building component, right click on it, add an event on building destroyed. I do want it to get destroyed, so let's right click and what? I cannot call a parent function. Let me compile and save, and then compile and save. It seems it doesn't let me. So we can just print here, hello. And now, and I said I was going to bump the attack. So let's do it pretty quickly in the Rocky level. Select this guy and go to the unit component, damage to apply, 200. Play, attack me. And it destroys and also prints the hello. This is happening because, well, these two classes, the main class is already implementing this, and the town hall, which is a child class, already has this event, but on top of it we are adding this. It seems that we didn't need to call the parent function when we are using events from components. Now, we really should just print the message, you have lost, and then play, just to see that it was really this message and it was not just a generic hello. You have lost. So now we have lost the game. Now, because this building being destroyed will affect the overall state of the game, this is a rule that we should put inside of our game mode. So let's open the game mode. And in the game mode, well, let's find where we get our town halls in the begin play. Then for each of these ones, we want to bind an event to that undestroyed dispatcher. That undestroyed, unbuilding destroyed dispatcher is here. We created it just by adding it. And what we will need to know in order to know if our building has been destroyed is, well, add an input and send the team attitude. And I will put here maybe, yeah, team attitude seems good enough. And here, whenever we're calling on building destroyed, team attitude, let's connect it like that. And let's compile. Right now it says new param, so I'm just going to refresh and connect it like that. Save it, and now compile again, just so we get rid of any compiler error. And after cleaning those errors, then we need to go back to the game mode. And in the game mode, here I'm going to bind and you won't find here the on building destroyed because we need to get the component. Building component. And now we can bind something to it. On building, bind event on building destroyed. Now, the event that I connect here will be the same event that will be used for every town hall that exists in our map. Okay, so let's event, add custom event. Let's keep it really simple. On town hall destroyed. There it is. And I just need to know if the town hall was a friendly one, so I can lose the game if it is. Later on, and by later on I mean maybe in the future, if you want to keep developing on top of this tutorial, there will probably come a time where you can have more than one town hall, and then you would need to check, oh, are there more town halls of my faction? If there are, then, well, you shouldn't lose then. But in this case, we only have one, so let's just check. If this is friendly, that it means that my town hall has been destroyed. And if it has, then I should lose the game, and here I should create another custom event, if I can type correctly. Jeez. And here, just lose the game. And everything that can make us lose the game should be able to call this function, well, this event. And well, if this is friendly, our town hall has been destroyed, then lose the game. Just like that. If we had other factions, then I will just put if false, then check if there are more town halls that are hostile. If they are not, then you'll win the game. In our case, this game won't be able to win, you just need to survive. And now we have an event that we can implement however we like. With this lose the game event, we can go back to the building, well, to the town hall, and just remove this destroy, because we are already using it here. We are already binding to it the begin play of my game mode. And if we could build stuff, then, well, we will need to, whenever we build a town hall, we need to add it and again bind to the building destroy event. Now, it's really, in the previous tutorial where I just put a you lose the game string, like, it was really anticlimactic. So we're going to delve into a little bit of user interface, because they are really easy to make. We just need to go to the content drawer, find our folder for the project, and in UI we already had HUD. So let's just right click, new folder. I'll just put, could be screens, could be menus. Inside it, user interface, widget blueprint, user widget, and let's call it widget blueprint lose screen. Let's open it. Inside it, we need a canvas panel. Inside this canvas panel, we need a text that says you lose. And let me select the text. Let me put it here in the middle, the anchor. And I'm just going to press Ctrl C to undo. And here you have hold shift to update the alignment to match and hold Ctrl to update the position to match. So I'm going to hold shift and Ctrl. And now it's still in the center. We want to size to the content. And now let's just type you lose. Let me change the size of the font. There it is, you lose. And we need some buttons so we know whenever we want to restart the game or if we just want to quit the game. So I have a button here and a button there. I want them to be aligned. So in order to do that, I will use something called a vertical box that I don't really remember if we already have used something like this. So quick way to add it, just select the button, right click it, wrap with, and select the vertical box. Now this vertical box should also size to the content, but not just yet. Here in the button 1, just drag it on top the vertical box, and now my vertical box is holding both buttons. If I want the buttons to use as much space as this vertical box is giving it, well, just select a button and press fill here in size. And if you press fill in the other one, then you will see that the size is more proportional. Now I want a little space in between these buttons. I'm going to select both of them with shift, like click shift and click shift here. And in padding, I'll just add maybe 20. Perfect. This vertical box should definitely be aligned here. So again, Ctrl Shift, align there. And the size, the position should be, no, X is okay, it should be 0, but Y should be minus something, minus 150. Seems good enough for me. Maybe I can move this a little bit, so it's a little bit bigger. And now we need some text inside these buttons. This button will be the retry. So I'll call it here button retry. And I will drag and drop a text inside that button. This text will be, well, retry. And the other one will be my quit. So button quit. And again, text inside it. And that text should say quit. We need to show this lose screen whenever we lose. So let's compile, save, go to my game mode, and in the lose event, lose the game event, let's just create the widget, lose screen, and just show it by adding it to the viewport. Let's press play, and we need to lose the game. You lose the game, you can retry, nothing happens, quit, nothing happens. Let's do something with those buttons. Here, the lose screen, let's click on retry, and the retry, here events unclicked. The retry will be very simple. We will just load again this rocky level. So let's and it's not called load map, it's called open level. Sorry, I just have a brain fart. Open level by object reference, so we can select the rocky level and we don't need to type the name. And that's pretty much it for the retry. For the quit here, unclicked. Also very simple. We will just quit the game. That's it. Now, if you have more than one level, then you really need to make sure that this takes in account the current level. So you are retrying the same level, right? You can get the current level, get current level name. And then now you can't use this object reference. You just need to connect this like this and open level by name and just connect the current level name to the open level by name. Yeah, that's it. That's it pretty much. Compile, save it, let's test it. If our building gets destroyed, we lose, we can quit the game and this just quits it. And also we can retry that it should load this level again. Retry, and then my level has been reloaded. Now we could get rid of that pesky message in a minute, because every time I'm pressing play, I'm having to deal with it. But now our game can finish, right? Our base is destroyed, we have the lose screen, and then we can choose if we retry the game, and then if we can also just quit the game. Let's fix that error whenever this worker tries to attack something that doesn't exist. We're gonna fix that right now. This error. Here you're attempting to access town hall via property actor to attack, and we can click on where we are trying to access that reference. Here, actor to attack. if it doesn't have an actor to attack, if this is not valid, when we try to attack, then we should do something about it. So we will just ask is valid, and you have this macro, but also because this is a variable inside our worker, we can just right click on it and convert to a validated get. So if it's valid, then of course go forward. If it isn't, then we should not be able to attack. And we can even just connect this like that, but I don't want to cross too much wires, so I'm just going to leave it there. Now, how can we stop attacking? Well, the same way we are stop attacking it whenever we are moving around, right? Attack this actor, handle new unit state. Well, we need to change the new unit state. And we can even create a custom event, which should be better actually. Yeah, let's create a custom event called stop attack. Handle new unit state should be idle. And we should stop the attack. This attack, when actor to attack is not valid, then we stop attacking. And what is this doing? Well, invalidating a timer, which we should also invalidate. Just like this. Pretty simple. And attack actor, we should really group all this stuff so it's not just floating around. It's a good idea to start using more comments, comment boxes, very helpful. So again, if we're attacking, we want to attack, the actor is not valid, then we will stop attacking, we will go back to idle, and then we will clear the attack timer. Just like we do whenever we attack once and we are not in range, we just clear it and then we start attacking again, but in our case we just stay in idle. And let's select everything regarding the attack. Just a comment box and attack order. If you want to know what it says here without having to zoom in, you can click on the comment box and then here click on show bubble when zoomed. And I'm going to do that with the orders that we have here. Yes, just so I don't need to lose them. For now, I'm going to select this part that deals with the animation, and I can just type that. This part deals with the animation. There it is. Great. Now our worker should be able to just break our stuff and we shouldn't get an error. Yeah, it now stops and we are not getting more errors popping up because of that. Let me close the worker. Let me close the loose screen. Let me close everything so we can start with other stuff. Now we have a game that works, starts and ends. But it is very boring if we have a unit that one can kill us in 2 hits, and two, if we manage to kill it, then nothing more happens. We need to add enemies during gameplay, during runtime. So what I'm going to do is create some spawners for these enemies. Let's just go to the core, folder, enemy, and here I'll create a blueprint class called, well, it's an actor, and it will be called enemy spawner. Inside it, I need a collision box, but the collision box will be empty. And by empty, I mean it will not have any collision. So here in collision presets, I'll just put no collision. I just want a visual marker of this box. Now in this box, what I want to have is first put it a little bit higher, and then I just want to modify the X and Y values like that, and I'll just put 150 and 150. This will be the area that my enemies will start spawning. Compile and save, and I'm going to check it out in Emap. And yeah, I believe it's more than enough. Let me check with the current worker. Or it may be too small, I don't know actually. Yeah, it may be too small. So let me bump these values to 400 and 400. Yeah, a lot better. And I will spawn enemies here, and the C value, let's just bump it to 100. A 100 in C also. So the box stand is almost like a radius. So if I put here 100, it means that I have 200 of height. And that's good enough. Why is it good enough? Because now that it is in my level, here, I want to spawn stuff inside it. And I will do that by getting a random point in this box. Let's go to the event graph, and let's just create a function, well, an event called event custom event called spawn enemy, like this. I need the location of this box, because here I can get, let's just right click and type get random point, get random location in navigable radius. Oh, and this is even better actually. I was gonna get a random point in a box that you can get like this, bounding box. Here it is, random point in bounding box. But if we can use the navigation, that will be even better. Random location in navigable radius. The origin, well, should be self. The radius, oh, just get actor location. Radius, I don't know, so let's just, instead of a box, let's use a sphere collision. Sphere radius maybe 70. Compile, save. Again, we don't need any collision here. No collision. Compile and save. Event graph. Sphere, just get radius. And scale radius in case by any chance I scale this blueprint up. Nav data, if we compile and save, should already be getting it automatically if there already exists a nav mesh, so we shouldn't be able to worry too much. And let's see if it's getting a random point. Just like that. Compile and save, and here we should put it there maybe. And it didn't give me anything. Oh, it's not giving me anything because I'm not calling a spawn enemy. So at the begin play, let's call a spawn enemy. Now it's giving me this, and now it's giving me that. I'm going to increase the radius to 400. Which means that something will be spawning in this radius. And it will spawn on top of the navigation mesh. So because we're using this information, we can change this code to spawn actor from class, and we had the workers, like, where is our characters? Oh, units, try for 2 worker. And let's just type drive2, this one. Spawn transform, let's just split it and connect the location. And for now, let's leave it default. Compile and save it. And let's check if this is working. I'm going to click on the 3 dots and simulate. And it didn't do it. Let's see why it's not doing it. To get the location, let's just put always spawn ignore collisions to see if it's trying to spawn it. And it is trying to spawn it. It's just that the location of this is the ground location. And we need something on top of it that can fit our worker. So we just need to add here 100. And now let's put it again in default, compile. We're still simulating, and now it should happen normally. And it's getting a random point inside that sphere. Yeah, that's a lot better. We can delete this, and if we press play, after 1 second of being spawned, it should go towards my town hall. This enemy spawner should spawn more than 1 enemy. So I'm going to put it near so I can see what's happening without moving around too much. And to spawn more than 1, we can just ask, how many enemies do I want to spawn? So I'm going to add an input to this event. Enemies spawn. I want this to be an integer. And the default value should be 1. Yeah, by default is 1. And now I want to loop this part of the code whatever times that I put here. So let's put, and it's not a for each loop because this is not an item. It's not a reference, an object reference. So it's just a for loop. A normal for loop. Just like that. We will put minus, and we can just connect this. If this is 1, then we are looping it 1 because of the 0 index, and then a second time because the index is now 1, which is the last index. So I'll just put here 1. Compile and save it. Should start working the same. But if now I put 2 here, now it should spawn to 3. Spawn 3. Cool. Let's just increase that radius a little bit more. And by default, we will spawn enemies between maybe 2 and 5. Maybe that's too much. 2 and 4. Or 3. 2 and 3. Yeah, that's fine. Or 1 and 3. To do that, we just need to call this spawn enemy. And I will create a custom, well, a timer, really, here in the begin play. Timer. Set timer by event. And it will be excellent if I could just connect these two, which I can't, because a timer only accepts an event that doesn't have any input. So what I need to do is here, custom event. I'll just call it spawn wave, and spawn wave will call spawn enemy, and enemies to spawn will be a random number, a random integer in range, minimum 1 and maximum 3. And now I can connect this like that. I just need to compile like this, or we can create event, and here we can search for the spawn wave. This is the same way of connecting, and this will be looping, and will be looping every 5 seconds. In order to get more random behavior, here in the timer, I can open it, and we can have a initial start delay or initial start variance, which I will do maybe. Could be 2. Or, yeah, 2. So it can start 2 seconds later or 2 seconds before. It's a good idea to save a variable to this timer. Just if later on we needed to stop this spawning. And the spawn time, again, should also be a variable. Seconds to spawn enemy, or spawn enemy X seconds. And I will make it instance editable, so we can modify this by each spawner that I could add, for example here. And this one could spawn maybe every 3 seconds. Let's press play, and every 3 seconds we should spawn something here, and every 5 seconds we should spawn something here also. Yeah, and there's a lot of enemies too quickly, so let's just reduce the time to, well, increase the time to 10, and here just 2. I will put, well, I will delete that and move this a little bit farther here, and let's press end so we can snap this. I will place it a little bit more farther there. Where is my enemy spawner? So I just can drag and drop it, and that'll be the end of it. Yeah, and just like that, let's press play, and let's just shift F1 to detach it and see what's happening here, and see that the enemies are spawning and they are going to come and attack us. What happened with my camera? Holy moly. Yeah, and I should reduce the damage of those, well, of that guy, but where did that guy appear? What? I deleted that guy. Let me search for drive. Here it is. Where is it here though? Let's just focus. And let me load everything in my world partition. Load selected cells. Or unload. Yeah, save everything. Load again. To see what's happening with this character. What? Yeah, and I cannot modify it. Well, I'll just close my project and open it again to see what's happening there. I opened and closed my project, and now this guy shows up again. So let's just delete it, save it, and let's press play and see if it's still there. Yeah, okay, now it's not there. I think I lost my spawners there. No, there they are. Excellent. Yeah, so now we have spawning enemies that can destroy our building, our main building. They have a very simple mechanic of just going straight for the throat and destroying our town. But you can choose however you would like to target stuff. That's something that you can do later on if you want to expand on top of this tutorial. Going forward in this tutorial, we are just going to fix stuff that was left pending, and we are really not gonna add more mechanics. It's a really long tutorial, so I really need to wrap this up. One of the things that I wanted to fix is this collision here. These rocks don't have any collision, so that's why our character is just, well, going like that. And also these rocks, I want them to be here. I will rotate them, and I will press P in order to see our map. Just so we have some of the nature protecting us, or something like that, I don't know. And this stuff should really be looking the other way, because my camera will never look to the way where they are open. Just like that. Something like that, maybe. Select it again. Rotate it. And yeah, that works works for me actually. It just needs not to be floating around. Just like that. This one is floating, right? Yes, of course it is. There it is. And whenever something can block a unit, you need to put it a little more hidden, like that. Yeah, just like that. And I have a mesh here that I'm not really using, so let's just delete it. I wanted to add collision to this. Let's select one and open it. See the collision, show simple collision. If it doesn't have any simple collision, let's add a box. And that box doesn't seem to be it, so let's just move it around so it fits a little bit better. Yeah, that's it. Let's save it. And now if we press play, our spawn units, our spawn, there it is, shouldn't be able to walk through there. But for sure, they can go through here. If I press Ctrl E, you will see that it's a little bit more complicated than just having a box collision. So let's try with, let's see the collision first. Simple collision, and that's, of course it doesn't have one. Let's just try with 26 DOP simplify collision. This could do the trick, actually. It's really not that bad. But if for some reason you needed more precision, which I really don't need actually, it's perfect for me, then you can remove all the collision. And here, auto convex collision, you will get this panel. Hull count, you can increase it, and hull precision also to create something more exact. Something more exact. But I don't really need the collision inside. You will see that you have different collisions just so they fit better. But I really don't need it, so I'll just remove this and add the 26 dot. Save this. And now if I press P, you should not be able to pass through here. If I here, instead of having our view mode in lit, put player collision, now we will see everything that is affecting the collision of our player. We see that we don't have collisions for our buildings. We really should fix that. Let's open a building. Let's select the mesh and double click on the static mesh. Probably no collision, of course no collision. Collision, box simplify collision. We don't really need more than a box for this. And just make it fit. You don't need to be really precise. Just eyeball it. If you want to be precise, you can use these views, different views. Oh, left view, I'm going to make it fit, and then you make it fit. But it's really not necessary. Yeah, something like that is more than enough. There. Save that. We have another mesh, which is these houses. Select the house mesh, double click on it, and add a box simplify collision. Select it, move it around. Now I will use this because, well, why not? I guess I already show how to do it. And from the side. Perfect. Save it. And now everything should have a collision. I don't need this. I'll go to lit and player collision. And yeah, everything should have a collision. We can press P again. If your nav mesh has not updated, then, well, first let's save everything. File and save all. Or I just press Ctrl Shift S. And let me close everything here. And build navigation. Where's my build navigation? Build path. That's it. That's basically it. The navigation has been completed? Yeah, really? Why is it not affecting this then? And we can test the navigation if we just press play, select a character, and then make it move it around. Yeah, my navigation has not been updated. So I need to know why is this happening. Let's just open up our building, select the mesh. Here, check if perspective, no, lit. No, I won't be able to see the collision. Here, in collision should be a check in order to affect the navigation, and it can affect the navigation, so it is more of a mystery to me. But for now, it's good enough. We have fixed the collision. We will now fix the navigation. I've been digging around, and this issue with these assets, for example, that my camera stops looking at it and they disappear, also that the collision does not work, and also they are not affecting the navigation, all has to do with the same problem, which is that the pivot point of these assets is really too far. So let's open the mesh. I'll select, for example, this house mesh. And even here, it doesn't show the mesh. So let's double click on it. If we try to see the pivot, show pivot is here. And you will also see that the approximate size is a lot bigger than what this really shows. So let me put this left. And yeah, this definitely is not like 100 something. If this is 1 meter, like 1 square is just 1 meter, then this is 100, 2000, 300. So yeah, no way, this is not 1000. So this means that the bounds of this object are all wrong, because the bounds, it will do like something like this for Unreal. All of this is the object, but the actual mesh is really little. And that makes it so whenever our camera leaves this area, it makes it disappear. Because that's the normal operation of our engine. Whenever our camera is not seeing something, then it doesn't mean it will render it. And we can show that, for example, I look this way, and I will freeze the rendering. You can freeze the rendering by going here in the console command and type freeze rendering. With that, we will look the other way and you will see that we are not rendering stuff that we are not currently seeing. So we are only rendering this stuff, and this other part gets rendered because, well, you could change the field of view and then it would get visible. So let's, again, I just press the up key, so I'm redoing the previous command, and now the rendering is normal. So the bounds make it so the engine will believe that, well, it's not in range, but when it truly is. To fix that, we can go here to the blueprint, open the blueprint. In the mesh, we can hack it like here, rendering, and search for bounce scale. Maybe bumping it to 3 will make it so our building does not disappear, because it seems like the bounds are inside my camera. But I really don't like to hack too much of this functionality unless I don't have any other choice. So what I'm going to do, and we have already tried to change the pivot of this mesh, and I believe like we got really bad results. Something that worked for me was, well, let's search again for the mesh, and these two meshes that are the two main culprits of this problem, I'll just select one and migrate it. And usually migration is to copy it to another project, but I made a mistake. I meant to say I'm going to export it. Export it will give me an FBX, and I'll just put it in my desktop there, and I'll just export it with the default settings. The same for this asset. Export it again in the desktop, and I'm going to add it again. So I'm going to go to buildings, and well, in my folder here, buildings, here I'm going to add the meshes. So import, let's go to the desktop, and here we will select these two assets. I don't want to import any materials with this because I already have materials for them. So here in material, do not create material. Import all. We will have that error, but here we have our meshes. These meshes already has a good bounds. Here the approximate size, it's like 300 something, which is the number that we were going to use. And if we search for the pivot point, it's still not in the center, but now we can fix them. We can fix them, fix this, trying to say this and them. We can fix them just by getting them here. They have this pivot point, which should be able to work if I just use this barrack, and this barrack has its pivot point there, and it will like be perfect. But because we are using it independently, we really don't need the pivot to be there. So now we can hop to the modeling editing mode. We click on pivot, and now if I press center, now it does detect the center. I'll choose button, and here also, let's accept, choose this other mesh, pivot, button, accept. Now these two meshes, let's go back to the select mode, have the correct pivot. Let's open them. Let's put the correct material. it was this one, brewery add, and it's still working correctly, so I'm going to search it and put it in my other mesh. No, let me select it again, and or just drag and drop on top of it. Finally, well, let me save everything. We just need to use these two. Let's browse to them. And in the house, let's use the one that should have the house. And now we really don't need this scene. So here, house, brewery add one, it's this one. And again, I really don't need the scene, but let's just delete it. This house mesh should already have the scale by 2. Rotation, let's leave the rotation, but the location just reset it. There it is, compile and save. And we also need to change the training center, right? Yeah, and here it is. Training center. Let's change it for our new imported mesh. We can just drag and drop, remove it from the scene, delete the scene, and reset the location. Compile and save. And now I can delete this and this. Everything should look the same, but I don't have the issues that I was having before. Regarding the navigation also, we don't have these issues now. It's still a good idea to go here and see how the collision is doing. And yeah, the collision is pretty good. If for some reason it does not fit or we don't have collision, let me just remove this collision. Again, now that our bounds are set up correctly, we can box simplify and it will properly box our mesh. And I'll do the same for this one. I'll just remove collision and add a box collision. There we go. Let's save everything. Save this. Come on. And now we really should be able to avoid these buildings because the nav mesh is working correctly and these buildings are currently blocking stuff. Let's press play again and let's get rid of some other errors. For example, this one, landscape physical material needs to be rebuilt. Here in build, you can find the landscape section. There are a lot of stuff here. It's asking us for the physical material, but we can build all landscape. And all landscape stuff will be built. Now when we press play, you won't have that message. And something else that we can add is here in the world partition panel. If you don't have it, again, window, world partition editor. We should be able to see a preview of our level here. If we go to build minimap, then we can, well, save all selected and wait for the minimap to be built. Now it's being built, and this is just a log saying that it has been built. Press OK, and you will have it here. And looks a lot better, actually. It gave us a better representation of where we are, right? So if our camera moves through here, then I can know that I'm near these objects. The next errors that we need to fix have to do with the gameplay. One of the things that I wanted to fix here is deselection marquee, which works pretty well for our units. Like you see, there are no errors here, but if you press play and select a building, nothing happens, and also I get an access none trying to read the property because we have tried to get a reference to something that does not exist. This has to do with the fact of how we are selecting our characters and our units, and also with the fact that whenever I'm selecting some unit and I select a building, I mean, it's just not the same. So what I want to do is create a selection component that I can reuse with these units and with any type of building or structure. That will let us reuse a lot of code and also make the solution for the selection marquee a lot more easy. So let's do it. Let's just ignore those errors for now. If we go to the unit, and I'll just keep in mind that I'm trying to making it work with a unit, I'll open the worker and see if this is a parent class, and it is. So I'll stay with this. Here in the blueprint worker, I'm gonna go to the viewport. Oh, that scared me a little bit. And we see that we have a decal, and this decal, I'll just right click and find references. There are no references to this decal. Well, in some part, I'm getting this decal and making it visible. And that part should have to do with the selection of this. And in this selection, we have the blueprint union component. Inside it, we have the show selection decal, and we have this part of the code. I want to move this part of the code to another component because my building is not a unit component. Well, it does not have a unit component. It has a blueprint building component. So I'm going to create another component here in core. Unit, could be player. Let's just put it in unit. Right click, blueprint class, actor component, and let's call it blueprint selection component. Come on, can't type today. There it is. Let's open it, and we need this show selection decal and hide selection decal, just like that. And I'm gonna go a step further. I'm not really going to get this component. What I'm gonna do is whenever we start playing, I will create this decal component and add it to the owner. So it will look something like this. Begin play. And I'll get the owner. I really don't need the tick. In fact, let's go to the class defaults and remove the start with tick enabled. Get owner, add component by class, and here I'll select a decal. This decal component, this should be false in order for it to attach itself automatically. And the relative transform, I'll just split this because if it's in the 0, 0, it's fine by me. If I see the worker here, the decal, the viewport is 0, 0, and it does have a little bit of movement, but I won't care too much because that is a 0, 0 and it's fine for me. The decal material is this one, and also the rotation did matter, I believe, because otherwise, if I just put it at 0, 0, it's like horizontal, and that's not what I need. So I believe it was here, or no, it's not in C, it's either in X or in Y. 90. I'll just use 90 in Y. Okay, so with these values, the scale, I won't care too much about it for now. I'll just create here in the blueprint selection component relative transform rotation, excuse me, just like that. And I'm going to save a variable, save this component as a variable, and I'll call it decal component reference. So instead of getting it like this, I can just get it like this. And this component is creating the decal, so it really can't be a null value, can't be a reference to something that does not exist, because if this does not exist for some reason, then all this component is wrong, or maybe this component didn't get created or something. But that's how we can know that something is going very, very wrong with our project. Now, if we see the worker, we need to change the decal material to MI selection indicator. So you can just drag and drop it from here. I don't know why, but I prefer just getting it like this. And I'll just set the decal material and select the MI selection indicator, was it right? Yeah, that's it. Now let's compile, save. In the worker, I'll just delete this decal, and in the unit component, instead of having this information here, we already have it in the selection component, so let's just delete it. Compile and save. And somewhere here, on owner clicked, it's something that, okay, here I have event select this. We already have some errors, right? So let's just remove this. And we need to add here our selection, our selection component. So let's call blueprint selection component. I'll just type selection. Here it is. And just replace what we had. Show selection decal. And again, hide. Now this class shouldn't have any more errors, but our blueprint unit component does have this call to the selection decal. So let's just check if it is working. Play. And there it is. If I select them, there it goes. If I stop selecting them, then again, there it goes. If I just clicked on them, it's still working. So that's pretty cool. We need to fix something. First, we have some errors here that we need to check, but the first thing is they start enabled. Here our decal started with the visibility set to false. So I'll just call hide selection decal at the start. There it is. We don't need to duplicate code that already exists. That's the first error. The second one is the size. This is too big. We need to set the scale. So let's just here in the worker, we should be able to select our selection component and here change the radius of that selection. So what I'm gonna do is inside the selection component create a variable, called, I'm gonna call this radius of indicator or indicator radius. A float is fine, and I'm gonna make it instance editable. That way, compile and save, in my worker I'm going to have that radius that I was talking about. And by default, I'm going to set it up as 100 units. Now with that setup, it's a good idea to also set up the size of this decal component. By default, I believe that, let's add one. It was 180 and 256, right? So what we need to do here, first let's check what's the size. That property was called decal size, and I'll just need to get decal size. And print it as a value. And yeah, it's the same default values that it has. And what we need to do now is change this decal size. Either that, or we change the scale how we did before. It would be easy to just change the scale. So I want to have a decal size that can help me. And with that information, we just need to transform the number that I input, probably using a rule of 3 kind of operation. So when I input maybe 100, then I know what's the normal decal size and then I can scale it easily. Something like that. So let's stop talking about it and just do it. Here, we already have the indicator radius. And what I'm going to do, because by default this decal spawns with a scale of 1 and this type of decal size, I only need to change these two values. So let's get that decal, this decal, let's set scale, and I'll just set the relative scale. If that doesn't work, then I'll change the world scale, but this should this should work, and it, for example, if I later just scale my unit that it's the owner of this component, then I don't need to do more calculations of that on that. So the relative scale is just fine. If I want a scale of 1 in every axis, then this decal size should be these values. Now I'm not going to change the X value, I'll just change these two values. So let's say, and let's just split this, split, I'll copy this value, and the other ones are the ones that I want to change. So I need my indicator radius, and if I wanted a scale of 1, well, this should be 256, right? Yeah. So I would need to divide by 256. How can I get it? Well, again, from this component reference, get, it was material size, right? Decal size, here it is. And I just need to get the X value, the X no, the Y and Z value, just like this. If this is 0, then, well, 0 divided by anything will be 0. If this is 256 divided by 256 is the same scale. If it is bigger, for example, twice the value, then this will result in 2, and I'll just scale it to 2, just like that. And I need the same functionality at the other side. And really, because this is a radius, I can just connect this like that. But what you would normally do is something like this, and then connect it like that. But again, it's a radius, it's giving me the same value, so you can save yourself one node. With that in place, let's compile and save. Our worker, and let's remove this decal, should still have the same size of the decal, because by default our indicator radius is that value. And if we check the size of this character, is really small. If we open the skeletal mesh, we see that is 244 by 154 by, well, 190. So a radius maybe of 150 could do the trick. So let's just try it. Let's get our selection component and just put 150. Let's press play, and when I select this, it's a little bit bigger. Why is it bigger? Because this is a radius. I need to divide between 2. Let's press play, and now it should be a better value for us. Sometimes when working with these decals, it may start affecting stuff that it shouldn't be affecting. If that is the case, for example, I have something here that let's just drag and drop a decal, and I'm not exactly sure if I already explained it, but it's something that I need to take in account. Here I have a decal, and if I put it on top, it will get affected unless I change this property. That it seems that I already did it for the character. Here, you see how the decal affects this? Well, we can go to details and search decal and receive decal. We just set it to false, and now the decal doesn't affect this value. It seems that I already did it with the worker, so it's just the mesh and search for decal, and yeah, receive decals, it's false. I'll close this, and now we have a component that is working almost the same, but we should be able to reuse it. And the best way of reusing this code is in the building. So I'll just close my unit component and my worker, and I will open the building. Here in the building, the blueprint building, which is the parent of the other buildings, we have this, and I believe this nav modifier didn't do that much, so I'll just delete it and compile. Oh, and it seems that it did do something, because now you can step on top of it. So let's just press Ctrl C and compile and save. Yeah, that nav modifier makes it so we don't have this type of navigation error that it really won't affect us, but it seems cleaner that way. Forgot about it. So in the building, let's add our selection component. Here it is. And here we have building click. Select this, well, excuse me, deselect this. Actor clicked, building clicked. If we look at our worker that I just closed, the way we're handling this is through these events. So I'll just copy them. And I don't believe, I see here that we are here on clicked friendly, click select this actor. Well, we have this value, this actor clicked. Yeah. So what we are going to do is just remove this, because we are going to copy and paste new stuff, and just paste what we copied. So when this is selected, the show selection decal is shown. And when we deselect it, then again, deselected. So now let's compile and save. We really don't need this selection decal. I will find every reference that there is there. And here, for now, I'll just disconnect this, okay? And I don't need to disconnect everything. I just need to disconnect this selection part. Let's compile and save and try it. If I select, our decal shows. And if I select more than one building, it does let me do that stuff, which is pretty cool. We need to make it a little bit bigger for certain buildings, and even in this type of building, we need to have a way to offset to the side. And again, for now, let's ignore the errors. And let me check if this works. Should work. House clicked. Building clicked. let's just leave it like that. And here, let's get our selection, and here is selecting it. Just do it like this. We are replacing, we are replacing code that already existed. We are not really trying to redo the code that we already did, because it's already working. Now with this, we can get rid of the selection decal, because nothing else should be using it. So let's remove it, compile and save it. And in each building, where are my buildings? I will need to modify the size. In this case, let's just open it. It says that the distance is approximately 3000 by 3000, so I'll just make it, where's my town hall? Selection component, 3000, and I'll just halve it. Let's press play, select this, and it's almost that size, but I need to move it a little bit. So I need to add here in my selection component not only the set relative scale, but also set relative location. We don't need to set the rotation because, well, it's a circle, so it doesn't matter if it's rotated or not. And the new location should be a variable called indicator offset. And again, make it instance editable. Perfect. And yeah, that's pretty much it, because by default, usually it will be in the middle, but in certain cases, like the town hall, it should move in X negative, if I'm not wrong. So in my selection component, X negative, I'll just move it. Let's try with 300, no, 300, yeah. And yeah, almost there. I'll just eyeball it. Yeah, that works. But I want the indicator radius to be a little bit less. Yeah, something like that. Or maybe a little bit bigger. Just maybe. And we have this error where our indicator is messing around with this mesh. So what I need to do again is here, decal, and it shouldn't receive any type of decal. Save it. Now it's looking better. These houses, we need to change them. We'll later see what's happening there, right? Let's just finish fixing all our components. House, let's double click it and let's see what's the approximate size. 400. So in my house, in the selection component, again, here should be like 200. Yeah, maybe it's too small. 400. Oh, and this is the house, excuse me. 500. Yeah, that's better. And again, the house decal. Just like that. The last thing we're missing is the training center. We're not really using those barracks, I believe. I'll just delete them. And this training center should be really similar to the house that I believe I put in my selection component. 500. Yeah, maybe a little bit more, just a little bit. And again, this mesh should not be affected by decals. Yeah, must be bigger. Must be a little bit bigger. Let's see if that's too big. Ah, that's perfect. And now, well, let's save everything. We have a selection component that we can reuse with anything really that we want to select. In this next part, we're going to talk a little bit about debugging. We are getting some errors when we are selecting stuff in our game. We need to determine what's triggering those errors, and that is through playtesting. If we press escape and nothing pops up, then, well, great, there wasn't any error. If we select a unit just by clicking on it and we press escape, nothing happened, then the unit seems to be working correctly. Select it by clicking, click something else, and again, everything works correctly. We can select more units, escape, and just like that, we can see what's triggering our errors. Or maybe if we right click with nothing selected, then no. What I discovered is that whenever a building is involved, an error pops up. For example, I just click on this building and I escape and we get this error. And we can click on the message, but let's understand a little bit more about these messages. This message log is very useful. It will tell us a lot about the status of our game, and anything that found that it was weird, then we can check it here. Right here, if the log is completely empty, you will see like a number in parentheses that can tell you more information about what the engine has checked. It's a better way to, well, not just a better way, it's just a cleaner way to visualize errors that can pop up inside the engine. If you needed more information of exactly what's happening here, you can go to the, where's window? Here, window, and check the output log. The output log is literally whatever it's happening that throws a message. For example, log word partition, generate, streaming, started, etc. And you can create these events also with prints divided by 0. Here you really have all the information that's going on that the blueprints or classes are throwing at us. Here we are dividing by 0. Here we have log blueprint user message. This is something that we are putting here in the log. And here's the error. And I just missed the error. Here it is. You need to keep in mind that this output log is for all of the lifetime. And you can just right click and clear the log. And if I press play, you will see again stuff happening. I select this, and just by selecting this building, I get an error. Here, I just would need to read like, oh, what's happening? Access none, trying to read property, get component by class, return value. And we didn't found that that class, BP unit selection marquee blueprint. Here is where the error has popped up. And if you needed specifically what function or what event is making this error pop up, let's just close the output log that you can also find here. The message log is really useful for that because it makes the text clickable. And also you can check out different sessions and you can decide which one do you want to check out. In this case, function, this is the function that I want to check out. Let's just click. And with that, our blueprint in question is opened. And it shows me the location of the offending code. In this case, we're testing this implementation, and also we're getting this component by class, which it's making it work only with unit components. And I'm checking the attitude, which maybe I should not do it like this. But this is failing because this selection marquee is checking for a unit component, and my buildings have building components. So that's the error. For me, it's very clear that that is the error. But maybe if you are just starting, for you, this makes sense, and you just wouldn't consider it an error. In order to avoid that and test even more, Unreal has a tool that we can use called breakpoints. And most programming languages and integrated development editors have these breakpoints, which is in the case of Unreal Engine. When you're using blueprints, you can click on any node, right click, and toggle a breakpoint. Why would I put a breakpoint here? Because in my message log that I just closed, I believe, here's my message log, there is an access none, which tells us that we are trying to access a variable that doesn't have anything inside it. In this case, this component class is not returning anything, but let's say I don't know that. Here I know that it says branch. And if we click this branch, it's selecting this branch. So I'll just put a breakpoint here. I can toggle it, or I can just add it, it's the same. Remove it or toggle again. F9, very useful in this case. When you add a breakpoint, whenever I press play, and let's say I select this, whenever this code is executed, our breakpoint will stop the execution. So if I try to go back to the execution, this is paused. And when you have your project in this state, you can hover on top of the variables to see what's the value that is being returned. This case is true for some reason. True. This means that this actor, which is the town hall, and you can open more information about every type of variable, especially if it's a reference to another actor or component. Here it is, town hall. Interface, it is implementing that interface, so it's true. And here, get component by class, the return value shows me unknown. So this is unknown. This is unknown. Of course, the team attitude is not showing anything. And when it's compared with this, for some reason it's telling that it's true. It maybe just an enumerator error. And to see if this is going to true or false, which should stay in false, we need to go to the next node. By clicking here, we will step to the next node. And again, the hotkey is F10. If you step to the next node, if this is true, it will step here. If this is false, then because nothing is connected here, you will regain control of the game. It will proceed as normal. So it says it's true, so I'm selecting that actor. Deselecting that actor has code inside it. Because this is an interface and a message using select this actor, and I'm telling this actor to be selected. If I double click it, I will see the interface, which is just a declaration of the stuff that I can later implement. But if I just press, where's my unit selection marquee? If I press, instead of step to next node, because there is no next node and I want to go inside this, there is another button called step into, and I will press it, and this will step inside that message, which is calling my player controller, is going to the actor selected list, and I can go here again. If I needed to get out of this, I can press step out. Pressing step out probably will return me to the normal game, or just, here it is, or just return me to another variable. So with that, again, I selected something. Seems it's true. What did I select now? Blueprint house. And there it is. I now know why this is showing me an error, because, well, this doesn't really exist. And it's through breakpoints that I can inspect certain values, and I'll just press F9 to fix this, right? We no longer want to ask for a unit component. We want to ask if this actor is selectable. If it's selectable, it means that it is implementing this interface. So if it is implementing this interface, it means that it should be a team. It should have a team attitude, right? It's either friendly, it's either hostile, or if it is not any one of these two, well, it should be neutral. Right now, you see that friendly is the first value. So whenever we compare something that doesn't have a value, by default gets the first value. So that's why this is going to true. And that's why one of the reasons I always say is that whenever we create an enumerator, the first element should be none. So I know that we are not getting a false positive. So the fix is really easy. Let's do it. And before I forget, whenever you are in a breakpoint, and let's just trigger it, and you already know what's happened and you don't need to go next or into, you can just resume play, and it will skip whatever you were checking around. Now, so let's fix this. I want to separate these two. First, I want to know if we can click this, just like that. Then I want to know if it is friendly, right? So I need to get the information of being friendly or not. But there are two components that has that information. What I will do then is, where is my selection event? Here, I will use this interface, double click it, and I'll create a new function. This new function, I'll call it get team attitude. Because whenever we are selecting something, we really do need to know what's the team attitude. And I need as an output the team attitude. Here it is. And let's call it team attitude. Now we have declared this in the selection event. We just need to make use of it. So if, and now that I know that this actor is implementing this selection event, which should be selection actions, but well, then I can do this. Get team attitude. Just to get the team attitude message. And also here in get attitude, now let's just leave it like that. Yeah, let's leave it like that. Here in the unit selection marquee, let's connect it like that. And the team attitude should be friendly. And I don't really need this and anymore. Just like that. Then we really don't need this. So it doesn't matter which type of component my actor or blueprint or building has. It will try to get the attitude like this. Let's compile and save. And we do need to implement this get team attitude. So let's go to the worker, interfaces, get team attitude. And we can just double click it because it has a return value. So to get that team attitude, let's just get the unit component and get team attitude. Just like that. And in the buildings, interfaces, double click this building component, get team attitude. You could have also do something like this, like, oh, let's get the component of the units, and if it's not valid, then I'll get the component of the building. But then if you add more components for different units, then, or for different types of objects, it will get very messy because you will have like 4 or 5 comparisons. With this, I just need to remember to implement this get team attitude. So if something is not selected, it's because we are not implementing that team attitude. Now let's compile and save. Let's press play. Let's select our building. Let's press escape. And now we do not have any type of issues. And it should also work that if I select here my building, select my building component and change the team attitude. Let's use this house or training center. Let's select the building component and let's change the attitude. And it seems that my attitude value is not instance editable. So let's go to building component. Hey, open my building component, edit. There it is. Team attitude, let's open its eye. So we are making it instance editable. So in the level, we can select this, select our building component, and here it is. If I put it to friend, no, to enemy, to hostile, I'll press play. I can select this. I cannot select that building, but I can select the other one. Now selecting everything, and I press escape, we shouldn't have any type of error. And let me close this here. The selection marquee. Yeah, we don't really need anything more in the selection marquee. Training center also. I just need to make sure that this training center is not hostile anymore. Friendly. Great. And the selection component should also be finished with this building. Yeah, let's just close everything. Later I just need to check some stuff. While I was checking the game, it seems that by adding here in the building this nav modifier, which makes it a nav area null, we are losing our functionality to be able to go to a building. For example, whenever we get a resource, just like that, we can get here, and our enemies are suffering the same fate. This happens, well, because there is no longer an nav mesh inside our building. If we were to remove it, let's go to a blueprint building and remove it, then there is now a nav mesh inside, and our character gets the idea that it can go there, right? The thing is that most of the navigation is always targeting the same point, and it will become very obvious with these two guys. It's always targeting the center. So this dude will try to get there. What I want to do is, I will probably get an error because these guys are going to start attacking something that does not exist. Let's just escape. Yeah, of course. Yeah, I know. I want to create points around my building, for example, here, 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 where the units can move around or can move to if they are near if they want to interact with this building, right? And later on you will be able to extend this, maybe have some points for just giving some resources, maybe points for attacking, I don't know, whatever you want. But I'll just use a simplistic approach. I'll just create points around it. Now, to do that, here, let's add again the nav mesh, because this really makes it clean and will make sure that our implementation is working, right? Because otherwise it won't work. My worker will stay in place, right? Here in my worker, in gathering the resource, here we are moving to the resource, we gather it. You already know how we did this. And at the end, we are going to the town hall and depositing the resource. Let's double click that. We're moving there and we're getting a location, well, a reference to this actor, and then we're sending our actor there. Usually you want to use target actor if the other actor can move around. So what happens is that if you target an enemy, then you are constantly following that enemy. Whenever it's something static, it's better to use a destination. So you can manipulate this destination, transform it a little bit to be a better fit with what you're trying to do. Like in our case, here in the town hall, blueprint town hall, I was just messing around here. What I want to create is locations where we can add those points, right? I could just create here add maybe a billboard and just put it here. And then in my level, I'll be able to see the point. And if needed, I could change it in the level like this billboard, and I can move it around, etc. But what I'm going to do is create my own, and let me go back to my town hall, create my own scene component that will have that functionality, or well, where I will dedicate that type of functionality. So let's go to my building folder and the building inside core, right click, blueprint class, and instead of actor component, which are these components that we have created before, we will use a scene component. This means that this component has a scene transform and can be attached to other scene components. So let's use scene component and let's give it a name. I'll just call it goal location. And for now, I will just save it. Now inside here, I will add a goal location. Or maybe multiple goal locations. I just want one here and a little bit upwards, just a little bit, in case the terrain is not a regular terrain. And I'll just press Ctrl D to duplicate this goal location and move it here. Duplicate again. Duplicate this again. And the goal location one, duplicate it again. Now we don't have a visual representation of this. Just take that in consideration. But we won't really need it. If you need it, well, you can attach something to this, maybe a billboard. But it will get a little bit bothersome here. Now you have a visual representation of that. But we don't really need it. With these locations in place, what I can do is here in my worker, I have a building, and I will ask the building component to give me a suitable location. I'm going to open the blueprint building component, and I'm going to create a function called get suitable location. This function will return a location. And it could return a location and the reference to the point, to the component. And maybe I will want to do that. You will see why in a minute. So let's just return a reference to my goal location, which is a component and scene component. This is the suitable location ref. And to get a suitable location, I need the get owner and just select get components by class, because there could be more than one, like here, could be more than one scene component. And here goal location, and that goal location should be goal location component. Let's not forget that. Save everything. Now with this, if this for some reason is empty, then we should return the scene component of the owner. But if it is not empty, then we just need to choose a goal location. So if it is not empty, then I'll just get a random item But if it is empty, then from the owner, and I can copy and paste this return node, just like this, I'll get the root component, which is always a scene component. Oh, it seems like it's asking for a blueprint go location. Well, we can then just remove this root component. I remove it here. And in the worker, I'll just need to ask get component by class. This must be a building. This building should return a get suitable component. And this suitable component, we're just getting data here, so I'll make it a pure function. Compile, save. This means that in my worker, now it looks like this, and I want to see if this is valid. If it is valid, then, oh, I need to move a lot around. If it is valid, then for sure, let's move to that location. If it is not valid, then, well, we should here order we had a way to go to idle. Move to this location, go to select this. We can just use this. If it's not valid, just go to idle. Just like that. Now we need to get this suitable location and connect it here. We cannot connect this like this because this go location is a component, not an actor. So from here, get world location. Just like that. And let me move this a little bit. Just like that. Let's compile. And let's press play. Select this guy, mine something. Hopefully our enemies are already doing some stuff. He's trying to move. Doesn't move around. Which is very weird. Let's do some debugging, right? So I'll just put a breakpoint here and just press play and mine something. Right, now it wants to go somewhere. I'm getting the go locations, which are 5 of them. Perfect. I'm returning a random one. I'll press F10 and that will leave me to the next execution path. Here it is. Oh, my target actor is still connected and the target actor is a priority, so let me just remove that and also remove my... Oh, I removed my breakpoint, okay. Let's see. Just like that. Oh, and you went to this one, okay. Well, now it's working. And now I don't really need this acceptance radius because I'm getting like the location, an actual location that doesn't have to do match with the type of building. Yep. And this time it selected that location. And now it's working. If I was going to mine with a lot of workers, then this time this worker selected that location, this time that worker selected the other location. So how should I select a location? We should probably select the nearest one. And maybe we can add if that location is, well, near, and if it's already being used by another worker. That's something that we can add inside our, where is my component? Town hall, go location, edit it. That's something that we can add inside this component. We can create the state like is full, and whenever we select this here in my building component, oh, you're selecting this one? Well, let me tell it that set is full is now true. So before selecting everything here, then we would need to first check, oh, which one of these components is the closest one, maybe, or maybe which one is not full, right? And then in another part of the code, here in worker, after it's a success and I reached my destination, I would need to tell it like, well, now this go location is no longer full. But that will take like, it's just a thing that it's a quality of life update, and it's something that you are able to do and could be a nice next step with the knowledge that we have acquired. Just don't forget that we are using this, and if for some reason we cannot attack our houses or our training centers, is because you have not added the correct components yet. These ones. So with that, the navigation should be better. With that also, we can put a lot of enemies. And oh, you need to do this this get world location of my suitable locations every time you're moving towards a enemy. For example, here, attack, raise it. Attack is valid. If it's not, we stop attacking. If it is, we're attacking. Attack this actor. And then state. AI move to. We have this actor. And we should be able to change this. So we are using the new code, which is this one. We get the actor to attack. We get component, which is a building component. And I could just connect it like this. If for some reason we do not have this component, we need to check it. Is valid. If it is not valid, if it is valid, then we can use this suitable location. If it is not valid, then we should just use this actor, target actor. So if it is not valid, the code will stay the same. But if it is valid, the code will change like this. And here the accepting radius doesn't need to be that big. Maybe 50 should be fine. Like this. Now, compile and save. We can drag and drop the other enemies. Where are my units? And I'll add more than one, so we know that they are not going to the same place. It's taking some time before they move to the normal place. You will see this one wants to go here, this one also wants to go there, this one there, and the other one there. So at least it's a little bit better, right? It's a little bit better. Let's now get rid of the end game errors. Here you have these guys trying to attack me and getting rid of me. Right, you lose. If we press escape, we have a lot of errors, actually. Actor to attack, it seems that it gets nulled. So let's just event graph. Let's see where this is happening. It's happening here. This is the actor to attack order, which is getting this part which should stop the attack eventually. And it does, but here I'm not checking. I'm not doing this is valid or not. So I should do that. Right click. And let's get... this is the set. And if we're setting this value and this value is null, then we just need to put here and is valid. Either that or see where this is being called. For example, let's put a breakpoint here. Press play. And here let's put no debug object selected, so the first object that calls this attack this actor should create a breakpoint. There it is. And if we want to know where this came from, we have here debug, blueprint debugger, and here we have, well, whatever happened with the blueprint worker, but even better yet, the call stack, which says that, oh, you're here, the event attack this actor, the AI controller is the one that called it. And this is being called at the start of everything. Now, this attack this actor, it's only being called at the start, so I really don't need to worry too much about this just yet. But here, this event attack this actor, after we attack it, I believe we are, creating a timer, checking if the actor to attack is still valid. If not, we're stopping the attack. We apply the damage, we clear the timer, and then we attack this actor again, but we are not checking here if it's valid or not. So that's what is missing. We need to check this if this actor to attack is still valid. So it's valid. Then sure, keep attacking. Otherwise, don't do anything. Let's press play. Let's remove this breakpoint. the attacks are working. You lose, I press escape, and now we have less errors, but we do still have errors. For example, this one, AI enemy controller. Here we're trying to attack something that doesn't have this. And let me see the other errors that pop up in my message log. All of these errors are happening in the AI controller. And they are happening. I closed it again. Alright, this is happening because we are still spawning enemies, and if we are spawning enemies and the actor to attack doesn't exist, then, well, how can we use it, right? So, and here we are trying to get to it through this array, but inside this array there exists a value that is no longer used because it has been destroyed. So it's a little bit more complex. We did fix the worker actions attack orders here. We did fix it, but it got a little bit more complicated because whenever we create more enemies, then those enemies are getting a variable that doesn't exist, and that has to do with the way we are handling the destruction of the town hall. Here in the town hall, let's see, did we created building component on destroy? Nothing. I believe that in my game mode, here it is, we lost the game, and here we bind it to the destruction of the town hall. So when the town hall is destroyed, then it is a good idea that, well, doesn't matter which one we are using, we need to remove it from the town hall's vector. So what I'm going to do is remove item, and we need an input for this. We need an input like this, but if I connect it here, then it won't be compatible with the onBuilding destroy event. So it would be a little overkill if we modify this event dispatcher. So what I'm going to do is, in the blueprint of the town hall, which is this one, I'm gonna get the building component on building destroyed, and I'm gonna get the game mode cast to my game mode, and here get the town halls and remove item. Which item? Well, ourselves. And that was not it. This was it. Just like that. Now let's press play. Let's let our enemies destroy our cool town hall. I'll press escape. You see that they stop attacking. And now we have another actor to attack. Another little error here. Oh, because it has been destroyed mid usage. I should really check here if our actor to attack is still valid. Just like that. If it's not valid, it won't do anything. Yeah, I could even call stop attacking. And every time I'm using this actor, maybe even here I will need to add some assurance that we do have the location and everything. But this should prove enough for us. Compile and save, and let's see if more errors pop up. Ideally, whenever the actor to attack gets destroyed, I immediately should abort everything. But now my validation is working. And what I would do ideally is, whenever I get this variable, for example here, I create an event dispatcher called, well, onDestroyed. You can already bind on actor begin overlap, bind on hit, take damage, onDestroyed. So you already can do this for any actor that you have, but I would bind it to onDestroyed, and then when this is destroyed, immediately stop whatever I'm doing here. Something like that. But that's how we get rid of any more warnings. So I'll just save everything, right click, and close the tabs to the right, so everything is clean and fresh. Also, I'll just delete this. Just like that. And now we have our working RTS without errors. Quick funny story. I already posted that I finished this tutorial, but while I was editing this video, I noticed that something was bothering me, and it's these health bars that shouldn't be showing if we have full health, and should only appear when we need that information. Otherwise, it may be too much. Okay, so let's remove them when we have our bar full, and let's just press Ctrl P and search for our health bar, this one, the widget. Now let's go to the graph, let's go to update bar, and here we know the percentage. If the percentage is greater or equal than 1, or less equal than 0, and it again would be fine if we just put if it's equal 1 or equal 0, it will work anyway. If that's true, then we need to get this health bar and set visibility to collapsed. If you just put hidden will make something like this, like, oh, okay, you don't see it, but it's still there, like it's still taking up this space. So if you had more text on top maybe, and text on the bottom, then this space is still being taken in account. And yeah, the tutorial is long enough, so I can just make a little a little test. I'll wrap it with a horizontal box because I consider it important. Maybe it's not, but let's just add a text on top and a text. Oh, I put a horizontal box. Let's right click, replace it with the vertical box. Now that's better. Text block there. The health should be, yeah, something like that. Here we are using collapsed. So you will see like text block, and that's it. If we use hidden, we will see more space between those text blocks. Because the space is still there, I cannot hit the button. If it were a button, I wouldn't be able to click it. But that is the main difference between hidden and collapsed. If it's collapsed, then the engine do optimize this and it just doesn't take it in account. So it's a little bit faster. So that's why I was using collapsed instead of just hidden. And let me return to normal. Perfect. So great. We don't have the bars. But if these are not the values of the percentage, then I want to put the visibility to not hit testable self and all children, because we don't need this widget to be hit testable. Hit testable means that we can click on it. And let's press play. And it will be easier if I just drag and drop some enemy worker here. And there it goes. Only pops up whenever we lose some life. And it disappears when it goes back to 0. We finally finished the tutorial. We have created a project from scratch, imported some assets, some free assets, and built our main functionality that every RTS will need to have. We have a worker, resources, we can mine them, we can move our workers, we created buildings, we extended that building to different types of buildings, and also we created a HUD that can show us the information needed for our game. At last we finished the selection of our units, and not only a single selection but also a multiple selection. The cherry on top was the part of artificial intelligence, where we have learned how to make our units move, interact, and also detail the steps that they need to follow in order to do some tasks. It has been a long journey, but I'm sure that we have learned a lot. And with the stuff that we have learned, well, you can create more features, create more units, more buildings, and even start creating features that we haven't touched in this tutorial, like building and other stuff, maybe attacking new units, etc. It has been a long journey, but I'm sure that you can take this little tutorial and build on top of it to create something unreal. Thank you so much for watching. Remember to subscribe if you don't want to miss more content like this one. If you're the type of person who wants to learn more and take your game dev skills to the next level, check the links in the description. You can become a member or visit our website to check some awesome premium resources. I am Ram, and I will see you in the next one.